Hello, everyone, and welcome to SHIPPED24. We're thrilled to have you here for this incredible day of learning, sharing, and connecting with you, the community. My name is John Bristow. I'm the community director for Octopus Deploy, and I'll be your host over the next couple of days. It's my pleasure to welcome you. Whether you're joining us for the first time or returning from last year, you're in for something special. SHIPPED24 is all about diving deep into the tools and practices that make modern software delivery not just efficient, but exceptional. With dedicated sessions on Octopus Deploy, Kubernetes, Argo, GitOps, and CodeFresh, we've crafted a content plan that will help you build expertise in the areas that matter most to you. Now, this event was born out of the passion for empowering our community with the knowledge, the tools, the inspiration needed to tackle the challenges of modern software delivery. At Octopus Deploy, we understand how fast the industry evolves and how critical it is to stay ahead of the curve. We've created this event as a platform to bring together practitioners, thought leaders, and innovators to share insights and to learn from each other and to explore the latest advancements in DevOps practices and technologies. And our goal is to provide a space where you, the attendee, can dive deep into topics like GitOps, Kubernetes, CI/CD, and walk away with, most importantly, actionable takeaways and feel connected to a global network of like-minded professionals and parts of your community. We've got lots of folks here joining from around the world, which is awesome to see. Just to highlight some folks here, we've got here Tony joining in from Ireland. Welcome, Tony. Justin here from Ontario, Canada. Shout out to Canada. I'm Canadian, so there you go. We've got Colin from Massachusetts, and we've got Silvert from Norway. Wow, welcome. I hope your weather's holding up there. I know it's getting too close to the winter time there, so there we go. Chris from Scotland, excellent. And we have Sheffield United in the house, which is Sheffield UK in the house, which is awesome to see. And we got Joanna here from Fargo, North Dakota, awesome. Robert here from the Netherlands, fantastic. Doug joining us all the way from Cambridge. Laura's joining us from St. Louis, go Blues. So there you go. Awesome to see you all. This is a great way for us to connect with you. Now, I mentioned earlier, we're going to be sharing with you a lot of technical knowledge over the course of the next 2 days, but it's not just about the technical knowledge. Today is also an opportunity for you to connect with the peers that you know and learn from industry experts and discover the latest trends that are shaping DevOps, platform engineering, and developer experience. And so we've lined up an amazing group of speakers and panelists who bring years of industry insight and expertise. So I would encourage you strongly, don't be shy. If you've got a question, pose it to the chat. We're watching the chat there, and we'll be tracking that throughout the next 2 days. We want you to pose your questions there, and we'll be answering them live. This is a live event, after all. So by demonstration, we've got also representation here in Poland, which is awesome. So if you go to the Shipped website today, you'll see a site that looks like this. This is where, of course, you registered. On that site, you'll also see our schedule, which is the sessions that we have planned out. We have, as I said, an action-packed full schedule here of sessions tailored for all the things I mentioned earlier. So we're going to start off with an opening keynote with Paul and Colin, and then we're going to get right into it. As you can see, it's pretty crammed. There's lots and lots of sessions to be had. And this is only day one. Day two, we'll focus on other topics as well. So if you want to check out more, you can do so by visiting the schedule at /schedule, which is available there. But for those folks who are wondering, I can't dedicate my entire time here watching a live stream. I've got some other things to do. But I would love to maybe catch up on what is being broadcast, etc., or watch them afterwards. You can actually watch all of the sessions after the fact up on our YouTube channel. So we'll make sure to have all these available for you. You can go ahead and like and subscribe, as they say, over at youtube.com/Octopus Deploy. And while you're there, also subscribe to our CodeFresh channel, which is at /CodeFreshCICD. In addition to that, we've also got to incentivize you to ask questions, we've also got a really neat hashtag, a very innovative hashtag that you can pose in your comments. So if you use the hashtag SHIPPED24 in the comments, we will identify those folks who ask questions, and we'll be giving out prizes throughout the entire course of the events surrounding SHIPPED, which is awesome. So great to see you all, and it's awesome to have you here. This is great. So, as I was saying before, don't be shy, ask a question, feel free to learn from those folks who are here, and make sure to use the hashtag SHIPPED24 with your comments. And we'll give you a chance to win a gift voucher for our Octo Shop, which is our online store, or even a GitOps certification at learning.codefresh.io. So get those questions rolling. We're excited to hear from you. For those who don't know, this is our GitOps certification location. You can find out more information by visiting this website. Again, that's at learning.codefresh.io. And we've got a new certification here to mention, which is our GitOps Enterprise certification. This is brand new. We shipped this last week at KubeCon, which was awesome. So you can go check that out there if you're all inclined to do so. Awesome. So if you need to find out more information, make sure to check out the schedule. It's action-packed and full of information. The other thing I want to make sure that I mention is that the Octopus community is at the heart of everything that we do. So part of the reason why we do this is because we have a vibrant and collaborative group of technical professionals who share a passion for improving software delivery. So you can join our community here. We have a Slack channel of over 6,000 members. And if you have any questions, you can pose them there. And so whether you're just getting started or you're a seasoned expert, our community is here to help support you through all of the ways in which you can ask questions through Slack or knowledge sharing and a lot of real world insights available for you to use. And so if you're looking to basically contribute best practices or participate through webinars and meetups and online discussions that we have, the Octopus Deploy community is where all of that happens. So make sure to join the conversation, connect with your peers, and be a part of the network that we have for shaping this all out. You'll find this all up on our website, which is at octopus.com/community. Make it a bookmark, if not your homepage. We'd love to see you there. So make sure to check that out. So as I mentioned before, all the content will be recorded. So don't worry if you have to duck out and take a look at some work items there. It's all good. But anyways, on with the show. Let's go ahead and get things started. We're kicking off SHIPPED24 with an inspiring keynote featuring Paul Stovell, our founder and CEO of Octopus Deploy, and Colin Bowern, who's the Senior Vice President of Product. And together, they'll set the tone from a day-by-day sharing of some exciting information of not only what we've shipped, but also what's coming. So Paul and Colin will be joined by Harriet, Ships, and Kit. They're members of the product team to showcase some of the specific features we've shipped along, and we look forward to actually checking out all those great new features. So sit back, relax, enjoy a cup of coffee or other part of beverage, and we will go ahead and kick things off with the keynote. Here we go.
Hello, everyone, and welcome to our second Shipped virtual conference. Octopus is the continuous delivery company. We set the standard for continuous delivery. And we don't just mean the technical practice of continuous delivery, but the philosophy behind it. We deeply believe that the principles of continuous delivery and agile software practices are the best way to create software that delights customers. And this quote sums up why we call this conference Shipped. It's a chance for us to share with you what we've shipped recently, what we plan to ship, and it also acts as a platform to talk about all of the human aspects involved in shipping software. But maybe before I talk about shipping, I want to focus on the valuable software part of this quote. Now, how do we know we're building valuable software? A big part of that is getting out there and talking to you. So this year, you'll have had the chance to meet us at KubeCon, at GitHub Universe, and many other events and conferences throughout the year. We ran in-person training around GitOps, and we visited dozens of customers face-to-face at their offices on site to find out how we can support customers better. So, and throughout this year, we also gather and read an enormous amount of feedback. We conduct a lot of customer interviews, and we make sure that everything that we're working on and everything that's on our roadmap reflects the things that are on your roadmaps as well, so that we can be a great partner for you. And a big part of the feedback that we get also comes from real world usage. Of every vendor that you have, I'd hope that Octopus is in the top 3 vendors as far as the support response time that we get and our ability to resolve issues and work well with you with our amazing support team that's spread around the world. Shortly, I'm going to be talking about a couple of the big trends that we focus on. And in this keynote, you're going to see a lot of focus around Kubernetes and platform engineering and those big areas of focus for us. But I don't want to make it seem like that's all that we're working on. In fact, we've got over 300 Octonauts today, and they're working on continually working on making Octopus better. And we're able to work on a lot of things in parallel too. So some of these things that we've done in the last year, you won't even necessarily see covered in this keynote, but there's a lot of very cool things that we've shipped this year, including the ability to freeze deployments during a change, freeze, support for Artifactory generic feeds, and a whole host of other features that you'll see, some throughout Shipped and some you'll have to have a look on our website. So while we shipped a lot of things in 2024, I'd say there were two major areas that we've been focused on. The first, of course, has been all around Kubernetes. It's really clear that Kubernetes is becoming the enterprise computing platform of the future. And we have many hundreds of customers, in fact, using Octopus for Kubernetes today, and many more who we know are working on Kubernetes projects that we're working with. And Kubernetes is different. It doesn't just involve new tooling, but also new paradigms around how we work. So a big part of our focus in the last year has been, the differences between continuous delivery as a practice and GitOps and those sort of paradigm differences. But generally, I think you're going to see a lot of stuff around Kubernetes in this keynote today. And I think you'll get the sense that of all the companies that are working in this space, we are the most prolific as far as different things that we're doing in terms of Kubernetes, in terms of GitOps, in terms of Argo support that you're going to see later. And we've got a lot of exciting stuff we shipped in 2024 and a lot coming soon. The second big area of focus for us is around platform engineering. And this is somewhat driven by Kubernetes. Kubernetes is often a bit complicated, and so people need to set up platform teams to be able to work with it. And we generally think that platform teams are right in the problem that they're trying to solve, to create consistency, to create economies of scale, reuse, that sort of thing. But we've got some different ideas on what we think it takes to do platforms right and to do platform engineering done right. So you're going to see a bit of that in today's keynote as well. But let's come back to Kubernetes. So when we talk to application engineers, teams who just want to ship stuff to Kubernetes, just like they ship software to anywhere else, Kubernetes is in many ways just another target. The principles of continuous delivery, how a robust CD pipeline works, they haven't really changed, even though we're going to Kubernetes. There are some differences, though. Kubernetes, for example, tends to be much more asynchronous in nature, and so it takes time for changes to replicate out, and something that looks like a successful deployment can later turn into a failed deployment. In this year, we did a lot of work around best-in-class Kubernetes deployments. We shipped our auto-scaling worker. So if you have a Kubernetes cluster, you can effectively just point Octopus at it, and we can run worker tasks directly on the cluster, creating pods and executing tasks inside of them without needing to provision anything else. And this was built on top of the agent for Kubernetes that we launched this year, which provides a faster and more secure way for Octopus to work with your Kubernetes cluster. We're also doing a lot of work around observability in Kubernetes. Because Kubernetes is so asynchronous, even if a deployment initially succeeds, something can go wrong later. And Kubernetes is a powerful system, so you can't just give every developer on your team access to be able to do the things they need to do to be able to diagnose what might be going wrong in production. But because Octopus understands how your application is structured, and because we have access to the systems, we have a very strong permission system, Octopus is going to become the place where your engineers come to understand what's going wrong with applications that are running in production. Imagine being able to receive logs to see that something has failed. And if you're familiar with the deployment dashboard in Octopus, you're typically used to seeing green ticks when deployments succeed. But in this case, you'll be able to see that, hey, the deployment succeeded, but something went wrong and the application is now down, and the dashboard will update in real time. So this isn't all. We shipped many other features related to Kubernetes this year, Helm triggers, this sort of thing, and you'll see much more about those today in the keynote. When we work with customers who are doing Kubernetes, there's something you can't ignore, though, and it's this rise of GitOps. And in particular, infrastructure engineers have really latched on to GitOps as a new way of doing operations. With Kubernetes comes YAML, a lot of YAML, and it feels very natural to take those YAML files and to put them in source control. And it sounds simple, but when you think about it, this is a real paradigm shift for infrastructure engineers. I'm a software developer. I've been using source control for 20 plus years. But for infrastructure people, this is a bit of a new phenomenon. Most infrastructure work was done at the end of an SSH terminal or a remote desktop connection. But now with Kubernetes with files that are stored in YAML, storing them in Git becomes a very powerful way to do operations, and the ability to have a pull request related to changes that we're making to our infrastructure running in production is a big paradigm shift. Now, what we find when we talk to application engineers, though, is they're not quite as excited about GitOps as the infrastructure teams are. And if you think about it, it makes sense. If I'm an infrastructure engineer changing something about how the network is configured in production, I probably should do that through a pull request. And there probably should be a review process. But if I'm an application engineer and I'm delivering software that we're building internally using continuous delivery, my pull request was reviewed quite a while ago when I merged the code into the main branch and it got built, and now it's just working through the deployment pipeline. And so future pull requests aren't really that exciting for me. And so one thing we found in the last year, particularly as we talk to customers who are all in on GitOps or just coming at Kubernetes from a CD point of view, there are these big differences in how they approach it. Now, in March this year, you might have seen that we acquired CodeFresh. And so at Octopus today, we effectively have two products. There's the continuous delivery tool that you're familiar with, where we focus on doing deployments really well, doing them at scale, and where we focus on application engineers creating robust pipelines. And then we have the CodeFresh GitOps product, which focuses on the infrastructure engineers at your company. Now, CodeFresh works as a managed control plane for Argo. The entirety of CodeFresh GitOps is built on top of Argo. And it has really powerful features like promotions, the ability to manage many clusters, many Argo instances, all in one control plane. And it works really great when you have a lot of projects, a lot of Argo instances, and a lot of Kubernetes clusters. If your infrastructure team is using Argo today, by thinking about what it would look like when you go beyond a handful of Argo instances and when you go beyond a handful of people doing GitOps and really try and roll this out at scale across your organization, you're probably going to be faced with using Argo for part of that and then building a lot of custom functionality on top of it. And that's effectively the roadmap for CodeFresh GitOps. Now at Octopus, we're actually going all in on Argo. So CodeFresh, the acquisition of CodeFresh was part of that. CodeFresh has a very long history with Argo. They were actually the first commercial vendor to lean in and support Argo when it became an open source project, when Intuit donated it to the CNCF. And they helped to launch the first ArgoCon way back in 2021. CodeFresh GitOps, as I said, is built completely on top of Argo, and so they've been contributing to the Argo code base for many years now, and they really have become the world's experts in supporting enterprises who are running software on top of Argo. But the Octopus product, I showed you the observability dashboard previously, that's also built on top of Argo. And we're seeing more and more Argo functionality and features start to make their way into Octopus. We'll be working on Argo rollouts coming into Octopus at some point next year. And like I said, a lot of the observability work that we've done is built on top of Argo. And you'll see some Argo CD targets come into Octopus as well. And we're making sure that we give back as part of this. We've got a dedicated open source engineering team. In fact, we're hiring for that team at the moment, more people, making sure that we do our job as a good commercial steward for the Argo project, and making sure that it continues to get better as we build on it. So hopefully that gives you a sense of what we're working on and doing around Kubernetes and Argo and how we see GitOps and CD coming together and evolving. The second big theme, though, is around platform engineering. But this is a good time to introduce Colin Bowern, our SVP of Product. So I'm going to thank you all for joining us today. Enjoy the rest of the keynote, and I'm going to hand over to Colin.
Thanks, Paul. Hey, over the past 10 years, we've seen the number of projects grow from hundreds to thousands, and in some cases, even tens of thousands. At the high end, we see thousands of application teams in various business units building and supporting these projects. And all of this is really coming at a time where this platform engineering concept is trying to emerge. Now, we see platform engineers working hard to create that standard process for moving code from commit to production. And building that first standard process, getting those initial projects and first teams set up, that's been fairly easy because everybody wants this simpler, easier world where people can just focus on getting stuff done. However, the other thing we've observed is the real challenge as we talk to platform teams is building up on these early successes and trying to reach the 10th team, the 100th team. And that's the thing that's proving more difficult. And platform teams, we see conducting satisfaction surveys, hiring product managers. They're all in this struggle to figure out how do we get wide adoption. And we expect them to form actually a picture of the macro challenges to achieving CD at scale. I love this quote from one of our customers where he said, it's not CD that's the real problem here. We can figure out how to build that golden path. It's trying to get 400 teams to do CD at scale consistently. So if we dive into that a little bit and try and figure out what's actually going on, there's three big themes, three big buckets that we see these problems coming up in. First, I think it's no surprise that no company will ever embrace a single tech stack fully, especially at a mid to large size scale. You have applications running on mainframes and servers, and they're probably gradually moving to containers or maybe being rewritten as serverless. However, they're going to have a variety of requirements. They're going to have legacy systems, vendor lock-in, competing priorities, all of these things that are going to drive business priorities in various different directions. And so getting to that single tech stack is often 5, 10, 15 years for some companies. Now, technology aside, you also have the different parts of the business that have their own objectives. You got stakeholders pulling in various directions. You got budget appetite to invest in standardization. All of this misalignment is actually good for large businesses because it's what helps keep them both stable and innovate in parts of the business. So if platform teams want to make a difference in this world, they're going to need to actually accept that there's natural misalignment in the business. And this is not something to fight against, it's actually to lean into and build towards. And so finally, do you have tools that can flex to these different needs of these applications or teams? Can it work at the pace of those teams? In tech, we often design tools for ideal situations, and we leave it up to users to figure out how best to adopt these and adapt these to the real world variations. One thing we consistently hear about, both at this past KubeCon and previous years, is a one size fits all approach won't really work well at scale. And of course, if platform teams get the abstraction wrong, they're risking taking on support burdens, diminishing the overall return on investment for platform engineering. So over the past 18 months, we've been ramping up our research, trying to figure out how best we can support your platform engineering efforts. And we've begun to build the first bits of our vision. I'm going to tell you the really high level, and Ships a little bit is going to give you some more of the details. But we think of it as three big areas of investment. We're developing blueprints that allow you to define those golden paths, but also that allow those teams to adapt them without becoming orphaned. We want to make sure that the benefits that they experience on day one continue to persist on day 100 and beyond. And being able to push and pull changes from the platform team in that sort of calm and orderly way, that's a way to make your application team super happy because they get to stay compliant on that golden path, but they're not forced to do it when it's inconvenient or perhaps super risky for them to take on those changes. We plan to implement guardrails to not only manage those IT risks through your standard sort of compliance and security controls. We're also looking at ways we can incentivize teams that are following good practices, shipping good, stable, safe deployments, and making sure that we can offer them ways to perhaps reduce administrative burden. Our aim at the end of the day is to build a positive experience. We want more teams in your organization to be like your best team, reaching that peak performance. And we think we can do some of that through guardrails that not just protect, but also incentivize. And finally, I mentioned that organizational, that natural misalignment in enterprise. We're factoring in exception handling right from the start, ensuring that teams who need to go outside the norm don't drop out of sight, because there's nothing worse than being surprised by shadow IT, especially when it's in the midst of a breach or a failed audit result. So from the outset, we want to make sure that we get this right, and it's really important for us. And so we're taking our time working with our customers. And so a big thank you to everybody who's joined our pre-alpha program and given us a ton of insights into how their world works, the things that they're struggling with their IDP or their DIY platform engineering efforts, and helping us figure out how can we bring product off the shelf that works for you. So this is a bit of a glimpse into the vision. We've got 2 to 3 years of investment ahead of us in this space. Lots more to come. And so stay tuned, we'll talk about it in a minute. So I want to introduce the product managers here, and we'll talk a little bit about some of the things that we've shipped and what's next. And as Paul mentioned, this isn't everything. We've got so much more that we're doing. And if you pay attention at octopus.com/roadmap or octopus.com/what's new, or read the newsletter, we're always trying to find ways to communicate with you and tell you about all the great things, both big and small, that we've been working on. Now, everything we do really sits on this consistent promise of repeatable, reliable, traceable operations. We believe that when it comes time to deploy, especially to production, that we want to make sure that we've made every effort to give you confidence that it will work. And when deployments do fail, we want to help you diagnose and recover from them fairly quickly. And we achieve this through the investments in all of the jobs to be done around continuous delivery, not just making it deploy, but getting into all those different scenarios that you want to model, run, verify, and recover from. And we're listening to your feedback as we go. We don't always get it every scenario covered in V1, and we want to make sure that we put those small improvements and fixes into the mix. Because at Octopus, we really do value your feedback. The customer feedback channel, this is one of the few places I work where pretty much everybody in the business is watching it. We read every single piece. When it comes through our roadmap, support tickets, conversation with Octonauts, and even our in-product satisfaction surveys. And for a few of you out there, we also know that you find some of those surveys a little bit annoying. We're also actively finding better ways to prompt you when it's convenient for you, because it's really important to know that we're shipping a great product experience for you. So we'll continue to work on the CNPS survey as well. But look, many of these small improvements and fixes, they were a result of the experiences that you shared with us. And while it may not always be the first time we hear a concern, sometimes it's your specific words that help us really better understand the issue and make that dot connect. And so our support, customer success, and R&D teams, we're always out there looking at the feedback, looking for the trends, looking for that opportunity to figure out what to do next. So I'm going to introduce you today to 3 big strategic areas of investment. Probably no surprise, the amount of Kubernetes we talked about earlier. We've been working on that for a while. We've still got a few big pieces left. We'll talk about developer experience, and we'll talk about platform engineering. For us, Kubernetes has made significant strides, and we've dedicated the past 2 years to simplifying the deployment of containers, ensuring it's both easy and accessible to everyone, especially that 10th and 100th application team. In terms of developer experience, we really want to keep those application engineers engaged and productive. Nobody wants to juggle yet another browser tab to find the information they need. So we're looking at all kinds of ways, and we've been investing in shipping some ways for you to integrate Octopus directly into the tools your developers already use. And finally, you might be able to tell I'm really excited to share what we've been doing in platform engineering. As I mentioned previously, this will be a critical focus for us in the next few years as we work to unlock continuous delivery at scale. Now, to give you more details on these areas, I'll invite the 3 of our product managers to share what's shipped and what's next in some of these areas. First up is Kit, who will delve into continuous delivery for Kubernetes. Over to you, Kit.
Thanks. So, hey everyone, I'm Kit. I'm product manager at Octopus. And for the past 2 years, our team has been focused on Kubernetes and deployments to Kubernetes to build the best experience in Octopus. Today, I will guide you through the challenges that many companies encounter when scaling deployments to Kubernetes, and I'll try to explain how Octopus addresses these challenges. We will also discuss what's coming next for Kubernetes and Octopus, and how you can give us feedback on that and help us to build the best experience ever. So, Octopus was built from the very beginning to simplify complex deployments across various environments. Deployments has always been complex, and as more organizations moved to Kubernetes, the challenge grew even larger. Kubernetes accelerated the adoption of microservices and made it easier to spin up new environments like dynamic environments, and allowed consistent deployments across multiple clouds and private data centers. So the number of classes targets just grew bigger. And all that led us to more complicated deployment landscape. We in Octopus, we saw this complexity, and we thought about this as an opportunity. So the question we asked ourselves was, how can we still keep deployment simple and manageable, but yet scalable and embrace all these advantages, unique opportunities with Kubernetes introduced to the whole ecosystem. So the ecosystem of Kubernetes already has a lot of great open source tools and best practices. And we don't think we should reinvent the wheel here, like introducing competing new practices or new ways of doing things. Instead, we build our solution on this strong foundation. Our idea is we need to integrate with Helm and customize and allow people to use YAML and embrace Git as much as we can and do it natively within Octopus. So with Octopus, you can automate complex workflows and manage deployments for hundreds of microservices, run deployments in the GitOps style, and all that using tools you already know and use so you don't have to start from scratch. It's about bringing the full potential of Kubernetes within Octopus platform with all the ecosystem. But here's the thing, in Kubernetes in general, as companies scale in Kubernetes, they often hit a wall where standard tools can't keep up just without adding a lot of complexity and cost. When Kubernetes adoption extends beyond a few teams, a number of microservices, environments, and regions grow, you usually reach the point where managing configurations, automating processes, and supporting very different team experience levels just become overwhelming. The cost of supporting that is growing, and the outcome kind of stays the same. So the whole idea of Octopus, as I mentioned, bringing all these tools together, it's allow us to using the same tools, again, using the same best practices, but focusing on things like templating, separation of concerns, traceability, and automation for multi-step deployments. So that's where we see Octopus playing the critical role, on top of other best practices and tools. So how do we do that? We have a few core principles in mind, how we believe you can scale Kubernetes deployments. It's not like you should use all of them. It's a choice. So you can select and embrace some of them, all of them, or none of them, and still use Octopus for your Kubernetes deployments. But I think the more principles you implement, probably easier it is to scale beyond like 100 and 300, 500 microservices and like dozens of teams. So the first idea we have is deployment process is almost never is just about applying configuration to a cluster. It's always about some other steps, like change management or test steps or notification. And all that should be straightforward, not just the actual configuration application. So when I look at our stats, a typical deployment process to Kubernetes in Octopus has at least 5 steps. And if you try to do it with scripts, automated scripts, that would be really challenging. The second idea is it doesn't matter how complex the process, your deployment process is, you should be able to create it once for all environments, for within application, and then you should be able to just reuse it instead of trying to create a process for each environment, and then adding an environment obviously gets very complicated. Then instead of managing multiple copies of the same Kubernetes manifest, and this is important because that's where complexity comes in and that a lot of hours are spent on that, you should be able to use one template, maybe across multiple microservices, but definitely across multiple environments, and that's how you reduce the cost and embrace the scale. Another one is we believe in separation of environment-specific parameters, like something small you vary from environment to environment, and actual app configuration. So, for example, think about this. If you have just 5 environments and 100 microservices, the difference between how many things should alternate could be as significant as changing and managing 500 configuration files versus one central file and just adjusting small environment properties here and there. Another one is you should be able to separate configuration updates from releasing new versions of your app software. Again, this is about scale. You can change your configuration every time you have a new version, just change the container image tag. But what if you can do it without that? So how often you actually update the actual configuration? Let's say for same example, 100 microservices, 5 environments, and you deploy them daily, you can end up with something like 10,000 commits a month to just update the image tags, versus maybe just 2 or 3 if you actually changing your configuration file and then doing the contain image tags management somewhere else. And finally, the final idea we have is everyone in the company, developers, platform engineers, QA engineers, product managers, should be able to just track deployment progression in real time with all information available in one place for all environments and all projects. So that's what we're building for. So let's put it all together. How would it look in action? Imagine have a DevOps engineer working with several teams deploying, let's say, 300 microservices across 5 regions. So the microservices are probably similar. You can create for them a single Helm chart and manage that in Git, and you're responsible for this. And all your projects will be using this. So each team are looking at like how a typical health tab looks in Octopus. Each team has its project in Octopus, and they just reference the Helm chart you created for them, but they also added their own unique Helm values files. So they just alternate this template and do a little bit of adjustments for their particular app. So they still keep responsibilities clear, so you allow them the right level of flexibility, but the configuration is still centralized. And then you deploy across multiple environments. Environments are different, but not much. So most likely, you just create something like a variable set and introduce a few environment-specific parameters and then share this variable set across all the projects. That's how you can achieve like real scale, and then adding the new project will literally take almost 0 time. And finally, you don't want to update your configuration every time you deploy a new microservice. Again, on the scale of hundreds of microservices, might be tedious. So you use release triggers in Octopus, and that's how you configure them. So Octopus will just create a new release and supply the right container image tag every time a new container is built. And that's how you reduce the load. And then you look at the Octopus dashboard, and it shows exactly which version of an app is running where, in what environment. And your teams can just have clear up-to-date insights. You can find this example with one central Helm chart and values files and dashboard in our sample instance. You see the link on the left. And yeah, just take a look. This is how you can apply all these principles and actually benefit from scale Octopus and using something like Helm, which is a native Kubernetes tool. So what's next? You can already scale, as I said, deployments to hundreds of applications and clusters, and it's relatively easy with Octopus. But we're not going to stop here. We actually have exciting plans for the coming year, and I would personally love for you to be a part of this adventure. Right now, our team is working on the next big improvement. Very soon, you'll see the live object status for Kubernetes. This feature will show you health, events, logs, and YAML configurations right in real time for the app you deployed through Octopus. We're also exploring progressive deployments like Blue, Green, and Canary, and potential integration with Argo CD, bringing the native capabilities of Argo CD in Octopus. To get an idea of what we're working on, you can take a look at our roadmap. It's like octopus.com/roadmap. And please share your feedback. Just let us know if it makes sense for you, and maybe share your stories about how you automate Kubernetes to deploy to Kubernetes right now. What tools do you use? What problems you face? I'm really looking forward to hear from you. Thank you. And yeah, over to you, Harriet.
Hi, everyone. I'm Harriet, the product manager here at Octopus Deploy, dedicated to making an uncompromised developer experience for our customers, ensuring that developers can work effectively and without interruptions. As touched on earlier, we lean heavily on the Agile Manifesto, where our priority is to satisfy the customer through early and continuous delivery. At Octopus, we are passionate about deployment frequency, and we've made it easier than ever for teams to deploy quickly and reliably. But we don't want to just stop there. We aim to create a world where developers can not only deploy quickly, but can also reduce failure rates, improve recovery times, and create a continuous feedback loop, all whilst staying in the flow. We believe this is the key to delivering the best possible developer experience. Our mission is to eliminate the distractions that pull engineers out of the flow. We are dedicated to building features that empower developers to work more efficiently right within their chosen tool. By minimizing context switching, we help teams maintain focus and boost productivity. This year, we are focused on improving the integration between Octopus Deploy and GitHub, making them better together. The reason why is pretty simple. GitHub is easily the product most commonly used in combination with Octopus. Our telemetry shows that more than 60% of Octopus customers also use GitHub. Part of our developer experience mission is to allow engineers to stay in the tools they are productive and familiar with. And for many of you, that means GitHub. To this end, we're focused on enhancing the GitHub integration in several key areas. GitHub Actions gives developers the ability to automate their builds with GitHub Actions and then integrate with Octopus to handle the complex deployments. Our GitHub Copilot extension lets developers query Octopus, manage their deployments, and create and deploy releases and runbooks from their IDE. Along with the GitHub Actions and Copilot extension integration, my team focused this year on improving the security and ease of use of Octopus's connection to GitHub with two key features. OpenID Connect for integrating GitHub Actions with Octopus, and then the Octopus Deploy GitHub app. Historically, letting tools like GitHub Actions or any other product interact with the Octopus API meant creating an Octopus API key and configuring the tool to authenticate using the API key. The downside of sharing API keys is that they have to be carefully managed. You need to store them securely to minimize the risk of leaking them to third parties, and it's good practice to regularly rotate the keys. It's also good practice to scope the keys as tightly as possible, which can mean a large number of keys to manage and a lot of overhead. OpenID Connect, or OIDC, has emerged as an elegant way to allow systems to authenticate without sharing long-lived credentials, for example, API keys or username and password. OIDC removes the need to pre-share credentials by trusting a specific issuer, in this case GitHub. Not only that, it allows trusting specific subjects, which in this case of OIDC for GitHub means specific repositories, branches, tags, or environments. This is powerful. You can now configure Octopus to allow, for example, the GitHub Actions running in the pet shop repository on the main branch to publish packages and create releases in Octopus without pre-sharing any credentials. And we've also published the Octopus Deploy GitHub app in the GitHub Marketplace, where OIDC allows connections from GitHub to Octopus without pre-shared credentials. The Octopus Deploy GitHub app will enable Octopus Deploy to connect to GitHub without configuring GitHub credentials in Octopus. The concrete benefit of this today is that config as code projects can be quickly and easily connected to your GitHub repository without spending time setting up the correct permissions to authenticate. These two key features, OIDC and the Octopus Deploy GitHub app, are central to our commitment to making your workflows more secure, efficient, and streamlined, while reducing the time and effort spent on setup and configuration, and helps lay the groundwork for what's next in the developer experience. So what is next? Well, we're just getting started. As engineers building tools for engineers, we understand the pain of constantly switching between platforms and the frustration of roadblocks. That's why we're committed to bringing Octopus Deploy directly into the developer's workflow to make tasks smoother and more efficient. Config as code for runbooks and ephemeral environments are already in the pipeline. With config as code for runbooks, which has been one of our most highly asked for features, engineers will soon be able to manage runbooks within their preferred Git repositories. This will streamline maintenance tasks and workflows entirely within the chosen IDE, improving efficiency and reducing context switching. Similarly, ephemeral environments tied to pull requests will allow engineers to test changes in isolated environments before merging them into the mainline, reducing delays and boosting confidence in the deployment process. These features are just the beginning. As we continue to evolve the developer experience, we're focused on adding even more value to your workflow. For example, features like change observability and feature toggles are on the horizon. Full traceability will give engineers greater visibility into the entire journey of a change, from commit to production, making it easier to track and manage updates across the environments. Feature toggles will offer greater control over production releases, allowing teams to activate or deactivate specific features without requiring a full rollback should something go wrong, improving both deployment confidence and recovery times. These upcoming capabilities are designed to further streamline the development and deployment processes, aligning with the key metrics that matter most to high-performing engineering teams. We're excited to continue building on the foundation to enhance your team's efficiency and help you achieve a greater success. We can't wait to see this journey, so please keep an eye out on our roadmap for updates and share any feedback you might have on any of these upcoming features. Thank you for your time. Now over to you, Ships.
Thanks, Harriet. Hi, I'm Ships. And for the past few months, I've been focusing on learning the needs of platform teams. What we've learned, I'm going to share a bit about what we've learned and give you a sneak peek of the future. First up, we've been seeing in the industry that platform engineering is gaining momentum. You can see that even on the Gartner hype cycle, developer platform and productivity is one of the emerging themes. All of this is sort of coming down to the same age-old problem of standardization. What's been happening is over the last few years, everyone's owned the full end-to-end DevOps stack, which has led to kind of reinventing the wheel and deviating and finding different ways of doing the same thing. And so platform engineering as an approach is being used to bring it back to that standardized way with best practices and compliance in place. So we're seeing that our customers are investing in building developer platforms, and we're seeing this across all sizes of organizations, small and big, thinking about building that internal developer platform. The key benefits that our customers hope to get out of an internal platform includes built-in compliance by default, best practices included into golden paths, and overall reducing that developer cognitive load and improving their internal experience. So as I mentioned, we've spoken to over 30 platform teams in the last 6 months, and we saw that companies are taking various approaches to building that internal developer platform. Some are building their golden paths using homegrown solutions with a lot of scripts to stitch together multiple tools. Others are attacking it in a different way by bringing through a developer portal solution like Backstage, which ends up providing a better developer user experience, but still needs a lot of orchestration behind the scenes. All of these approaches are not quite working well yet. And we're finding that enforcing policies as well as rolling out new changes and maintaining those golden paths in the long run is still hard. Application teams can start with templates on that day 0, day 1, and then can start to customize it and deviate from it. And so platform teams do not really get that visibility of when that happens. This means it becomes sort of an ongoing maintenance nightmare for platform teams on day 200, day 300, when they have to go and update those golden paths. They become overwhelmed with troubleshooting and firefighting and have to sort of hand roll out those changes when new standards come in. If you want to hear more about this, tune into my talk later. We're doing one on top 5 insights from talking to 30 platform teams later in the day. So tune in to hear more. But for now, we'll talk about deployment orchestration. So we're seeing that overall in the industry, there's no good solutions out there for deployment orchestration at scale, especially. Starting with IDP like a portal is a misstep. Teams should really focus on solving for that deployment and platform orchestration pieces first. And in that space, we're seeing some tools that are really helping you out by having those templates or having a solution to build templates. It helps you build that getting started kit. But there's no sort of solutions out there that solve for rolling out those new changes, managing exceptions, showing traceability, even measuring impact of your developer platform, right? And but we think that so far, Octopus really has the foundations for your future platform. We are the best CD solution out there, and we will be the best CD solution at scale, helping you standardize those deployment pipelines at scale and reducing maintenance costs and ultimately improving your internal DevEx. As Harriet mentioned just before me, we're obsessed with building an amazing developer experience. So we're really focused on this, and we're now wondering, how can we do this and help you do this without introducing yet another tool or yet another tab on that browser? And we think we have an answer. Our vision for platform teams is that Octopus Deploy offers centrally managed deployment pipeline templates with enforceable guardrails. It would help you remove friction for developers in their deployment processes. And we will have built-in exception management to work with that natural misalignment that occurs throughout big organizations and business units. We think this will improve your organization's developer experience by reducing duplication and scaling best practices to ultimately reduce that auditing burden. Now I'd like to share a bit of a sneak peek of what that means. We are thinking deeply about that pipeline standardization. And in the future, we will imagine no team will begin with an empty Octopus project. They will begin with these project templates that would be customized and provided by platform teams within their orgs. It will likely include everything surrounding the deployment context, including the process steps, variable configuration, runbooks, environment scopes, and more. And with templates, we think platform teams can go from thousands of pipelines to tens, have built-in security and compliance checks by default. We think that they'll be able to roll out new changes with ease, with a few button clicks instead of manual hand-rolling processes. And we'd love to give platform teams the ability to manage exceptions and also be able to customize their templates for that app team that's working on your new innovation project or the labs team. Ultimately, we're hoping platform teams can breeze through audit time by monitoring and rectifying pipeline compliance. And this is just the beginning, so please keep watching the space. We want to help platform teams become the hero in the eyes of application teams. And we think Octopus will be the only tool that solves for pipeline standardization at scale. We'll be investing in here over the next several years. So we're really open to your feedback and ideas, and we'd love to hear more from you. As the first step, the first tangible step on our journey here, we are building something called process templates, and an alpha version will be out March next year. We'd love for you to if you're interested to trial it, please register your interest via our roadmap. You've been hearing a lot of good stuff today from all of my colleagues. So please take that roadmap link at the bottom of the slide, bookmark it, and keep submitting your feedback and your suggestions through it. We're really, really listening and keen to hear it. We'd love to hear more about the challenges that your developer platform's facing, about your challenges that your application teams are facing, and any other things that you think Octopus should consider. So that's it from us for now. Back to you, Colin.
Thanks, Ships. I hope you spotted something that will improve how you deploy your apps. Our roadmap is influenced our vision. Our vision has influenced our roadmap. We're learning from the industry. We're learning from you. We really want to hear from you. So look, there's all kinds of ways that you can help us make this a better product for you. First and foremost, our public roadmap is updated regularly with some of the ideas we're exploring. If you find cards that resonate with you, please share your perspective. Your voice plays a crucial role in shaping our journey. Here are a few of the topics that we're hoping to hear about. Everything from feature toggles to Argo rollouts, to deployment policies, to how you track changes, and how you might want to template the entire project. If you can go to octopus.com/roadmap, you'll find a card related to these topics and more. Please share your thoughts. And stay tuned. We're also going to share a bunch of the things that we've learned in some of the upcoming sessions here at Shipped. It's important for us to not only just build great products, but also share some of the interesting insights that we get from talking to those hundreds to thousands of customers about any given topic. And you can also check out the industry surveys, the papers, and the books that we're creating to help you learn more about specific topics. These are written from the heart. We really want you to understand and see the world through the benefit of all the customers that we talk with and the patterns that we see that are working, and also the dangers that are out there, especially as you scale. We're working with customers with tens, hundreds, thousands of teams, to customers with hundreds of thousands of projects, clusters spread all over the world. We're seeing lots of different patterns, and we want to make sure that we share the things that we see are working with you, because we're excited to see our customers, our product teams, and industry experts to share how they've shipped their products. And that's why we've called this event Shipped. And so really excited to continue working with you. Thank you for choosing Octopus. And on behalf of the over 300 Octonauts, we look forward to partnering with you on continuous delivery at any scale. Let's create some happy deployers every single day. Enjoy.
Awesome stuff. That is really exciting. I am super, super keen on the project templates feature that was highlighted there. That's awesome stuff. Just wanted to bring everyone's attention to the prize draw. So I want everyone to go ahead and put this hashtag in their comment. You'll be entered into a prize. We've only got 9 entries so far. So if you want to win a chance, possibly a chance to win a free gift card to our store, or to possibly get a piece of swag, go ahead and just submit this hashtag into the comment section, and you'll be entered. In the meantime, I did want to get to some of the questions that were posed here. So there's a lot of stuff that's in that talk there that I think is worth mentioning. So there's a question here from Justin, who mentions, are there any tips or suggestions for helping to guide teams in migrating monolithic applications towards Kubernetes? It's a great question. We actually have a lot of resources available up on our website. You'll find us at /Kubernetes as well. But just thinking kind of broadly in my experience of how you might tackle this from a Kubernetes perspective, especially from a monolithic application, there's lots of different ways you can go about it. But anytime I do a migration, I always think of outlining my goals. I break it down into a series of phases, and then I start looking at the technical tangibles. Like I start preparing my Kubernetes clusters. So I'm going to choose my platform. I'll typically go with a managed service like GKE, AKS, EKS. I'll look at setting up a CI/CD pipeline. I'll use Octopus Deploy, of course. I'll use Helm, Argo CD, etc. And then thirdly, and probably most importantly, I think, is I'll also implement observability as part of that as I go through my migration to a monolith, from a monolith to a Kubernetes. Because if you're utilizing a tool like Prometheus or Grafana, you're doing logging, you're doing tracing, that's really going to give you some really good insights into what's happening there. I'll address some dependencies. I'll add external resources. If I've got a database somewhere, I'll consider persistent volumes, things like that. So there's lots of different ways you can approach this problem. It's a great question. Let's go ahead and take a look at the giveaway here. Got 17 entries. All right. Last chance to submit a hashtag into the comment section before we do a draw. All right, let's go ahead and do our draw. And I hope I don't get Octopus Deploy because I used that hashtag when I posted it. All right, let's see a one, and oh no. All right, we'll just pick out a random winner. I used the hashtag when posting a comment, so there you go. I blame myself. There you go. So we'll draw again, see who wins this one. Please not Octopus Deploy. I shouldn't use that hashtag. Oh, jeez. Okay, we're gonna pick one at random. We'll let you know in the private comments there. That's awesome. All right, so let's move on. So coming up next on the calendar or in the schedule, let's take a look here. We have just finished up the keynote, and we are on to our next session here, which is Cale Young. He's going to be doing a session here entitled CD is for Infrastructure 2. Cale's a senior SRE at Octopus Deploy. He's great. And his talk is going to talk a lot about, there are plenty of resources out there on how to do continuously deliver software, but what about infrastructure? And so Cale in this talk discusses some of the real world techniques that the team of Octopus Deploy have been using to continuously deliver their internal infrastructure over the past couple of years. So over to you, Cale.
Hi there. My name's Cale. I am a senior SRE at Octopus Deploy, where I work in a team that we look after our build and test and delivery infrastructure in order to get our product out to all of our wonderful customers. Why do this talk? I've discovered over the last little while that there's tons of material out there for continuous delivery for applications, but actually not a whole lot for infrastructure that runs those applications. So I thought, look, let's put something together and I can sort of share some of the things we've learned over the last little while. To talk about what we're going to go through today, I'm going to just define some terms. What do I mean by CD? I'm going to give you a little history lesson of where we started when I joined the company in terms of the platform that I help run today. Then we're going to get into, all right, well, how do you do CD for infrastructure? In particular, what do you do when you can't interrupt workloads easily, which is a big challenge for us? And then finally, like, how do you test changes? So what do I mean by CD? Do I mean continuous deployment, continuous delivery, continuous dishwashing? I mean continuous delivery. And I'm going to just put a quote up here from Jez Humble. I'm not going to read that whole thing out, but the stuff I put in bold there is kind of important. We need to be able to make changes safely, quickly, but also in a way that's sustainable for the team. And that's really important. So, a history lesson. I've been working at Octopus now for about 4 years, and I'm going to go back to kind of 2021 and look at the way things were in low detail for the build and test and delivery platform. We had a single CI server on a single VM that was a kind of what I'm going to say ClickOps into production. We had no infra as code describing it. And then outside of that, we had some manually created blob storage accounts. We had a manually created Artifactory set up doing some artifact handling inside a somewhat infra as coded AKS cluster. And then we had some agent compute running in ephemeral VMs that were described with Packer, which is an automation tool for building VM images. But the infrastructure those VMs ran in was, again, manually created. Now, you might be looking at that and saying, well, that looks really nice and high tech. Like, what's so bad with that? Well, one of the first things that I experienced in this team was making what I thought was a routine change, and then accidentally restarting that Artifactory instance I mentioned. And at the scale we're at, restarting Artifactory is a multiple minutes kind of affair. And lots of our platform depends on Artifactory being available, it turns out. It's kind of not a good look when your team is like, whoops, sorry, took down everyone's builds for half the day, or at least it felt like that at the time. So we thought in response to this, well, let's be careful. Let's only do these kinds of changes kind of at the edges of working hours. But that only works so far. That's fine if you do that once in a while. But the more we kind of took on this platform, we're like trying to patch third-party applications. We're trying to make improvements to the way our agent compute works. That's a lot for a small team where pretty much every week someone is having to draw the short straw and go work outside of their normal working hours. It kind of leads to this problem of, well, I didn't sign up for that. I didn't sign up to be working out of my normal hours constantly. You know, I have commitments outside of work. This leads to burnout potentially, people wanting to leave the team or leave the company. Now, this seems kind of intractable, right? Like, okay, how do you get out of that hole? What do you do? Let's talk about CD for infra. And rather than throwing like a big architectural diagram at you with the way things are right now, because I don't think that's not going to be helpful for your context necessarily, I'm going to step through some of the properties of the system we've ended up with that I think improve on the old way in a way that might be useful for you. Just before I do, though, I need to just mention most of the advice that's coming up here is going to assume that you're running on virtualizable machines, not bare metal. You know, I don't think I'm going to say anything that means you have to be running in the cloud. Most of this should work if you have like a private cloud setup. But bare metal, I can't speak to. Maybe it'll work, maybe it won't. I am also going to use some terms from Terraform, which like plan and apply. That's just because that's mostly how we work with many of these things. But I think the patterns I'm going to talk about should work with any kind of infra as code tool that you might want to use. So speaking of infra as code, I think this is foundational for CD for infra. You can't really do this without having a way to describe your infrastructure stack programmatically. You can pick any technology. We use Terraform, but I think you can use anything. Doing this might be the slowest part of this journey. If you're not already using infra as code, this might be the single slowest part of getting to this wonderful CD future. Even if it's hard, I think you should do it. We had to move that single instance CI server from its kind of snowflake clicked into existence VM. And we took that as an opportunity to rebuild using infra as code. It took us a long time because there was a lot of things we hadn't anticipated. There was a lot of things we had to glue together. But in the end, we ended up with a full production infrastructure stack described in Terraform that we could then stamp out and use in other environments and make changes too quickly, and all of the benefits we're going to talk about. It's worth doing. So once you've got the basics of infra as code, the next thing that you need to be thinking about is what I'm going to call environmental progression. So you take this code that represents your production environment and you use it to also create your pre-production environments. There's a few different ways to do this. One way that our team uses is to use Octopus Deploy, although you could use other tools, to inject what I'm going to call scoped variable values. So your infra as code will have little tokens in there. One good time that you would use this is if you want to use like large VMs in production, but smaller VMs in pre-production. So you can have a single config file that then at deployment time, when the pipeline runs, put different values in there. Beyond that, if you want different ways to think about different ways to represent this in your actual files, the simplest way is just to have production and all the pre-production environments be the same, other than maybe those variable changes. But I do know that other organizations take this approach of, well, let's have a folder per environment in our repository. So you have one for production, then you have one for pre-production, one for QA, one for staging. This works better if you've got larger differences between your environments than simple variable changes could possibly describe. And for a hard mode, you might want to use something like a code generator. Now, in Terraform land, that's a tool like TerraGrunt, which kind of merges these two ideas together. You have a single set of files that kind of describes most of your stack, and then another set that describes the way in which each environment differs, and it saves a lot of copy pasting. But there's really only value in doing that if you've got very divergent and very numerous pre-production environments. For what it's worth, we tend to use that first one. We tend to just use a single description with some variable injection. It makes onboarding really simple because we just say that's the infrastructure for this service. So once you've got progression set up, what do you do with that? Well, I'm going to say your pipeline should be automatically deploying any proposed change somewhere. Now, if this is a brand new service, maybe you're going to be deploying this straight to production. YOLO is a term we use. You only live once, kind of take a bunch of risks. If you're not actually using a production environment yet, feel free to just go send stuff straight there. Commit and ship, commit and ship, commit and ship. That's fine. But if you're beyond that, depending on how you've set up your pipeline, folder per environment or whatever, you've got to have your deployment pipeline choose what to deploy where. And this affects how you apply changes as well. I'm also going to say, if you are deploying to pre-production, your pipeline should be automatically planning, which is a Terraform term, but giving you some kind of indication of what's going to happen when this change goes to production. In our case, we use Terraform. We get out a plan that says, okay, here's what I'm going to do when I deploy to production. And a human needs to go look at that and say, yes, this makes sense. If you are deploying to production, at least in the beginning, strongly consider setting up your pipeline to stop in between that plan set stage and the apply stage and have a human look at it and go, okay, it's going to change this, it's going to add this, it's going to delete and recreate that. Do I want it to do that? What effect is that going to have? Very valuable, at least early on, before you've kind of got a sense of what sort of changes might cause what sorts of impacts. Now, everything up to here is pretty much enough if you're running replicated stateless services that can be interrupted during gradual rollout of infrastructure change. But what if you aren't? And as I said before, I work in a team that manages compute resources for builds and tests, and these are weird shaped workloads. They need heaps of compute for a short amount of time. They have tons of state they have to write down and do interactions with. And they often run for a really long time, and there's only one of them, and if they get interrupted, people get angry. This is the reason why we were doing so many out-of-hours changes, because our software engineers didn't want these long-running tests to get interrupted. So what did we do? What do you do with uninterruptible workloads? I've got some bad news potentially. This is going to require you to talk to some people, assuming that those workloads are actually important to teams outside of your own. I want to introduce you to the idea of mechanical sympathy. What I mean here is go out there and build a deep understanding of exactly what's going to happen when an interruption happens. In our case, our CI system actually automatically restarts. So it's not so bad, but it just means some lost time. And go build an understanding of what you can get away with in terms of downtime or reduced capacity. And then and only then start to form your platform around, okay, what are people actually expecting of us? So ways this might play out are, what controls can you put around unacceptable termination? So maybe some termination's okay, but not all of it. If you're running in Kubernetes, we, for example, pod disruption budgets to say, okay, we want these things to never be interrupted. We want these things to be only partially interrupted during upgrades, things like that. And as I said, you're going out and doing the legwork to figure out, okay, what am I allowed to make unavailable? What am I allowed to degrade the service? So once you've developed this sense of mechanical sympathy, what kind of infrastructure choices could you be making to enable continuous delivery? The simplest way I can put this is you need to start with two. Two of what? Well, in Kubernetes, there might be node pools. In something like Azure App Service, there might be app deployment slots. I think it's a lot harder to migrate a deployment pipeline from one thing to two things than it is to go from two to more than two, because it changes how you think about, is this a list of things or is this a single thing? So start with two, because if you start with two, you can do things like use the expand contract pattern, where when you want to make a change, just add a new thing of the thing send some traffic there, and then remove the old one. Or you can use blue-green, where if you want to try something, you can temporarily make a change to part of your system, see how it behaves, and then either commit the whole change or roll it back. Now, I said something before that's worth just leaning into a bit. You're going to need some way to manage traffic. And I don't just mean web traffic here. We've got a service that depends on the ability to create and manage pods in a Kubernetes cluster. And yeah, look, I mean, under the hood, that might be HTTP, but we're not using like a reverse proxy to do traffic management here. We have some other custom stuff we've written to say, okay, take that work and send it over to this set of node pools instead while we're making changes over here. It's critical for you to be able to make changes safely without anybody noticing. So, all right, you got your pipeline up and running. You need a way to be able to use the advantages of CD here, which is where you can test changes before you actually commit to putting them into production. And there's two kinds of things to test here. One is, will this infrastructure change actually deploy? Can I roll it out at all? And then two, if I have rolled it out, does the change actually have the effect that I want? There's a couple of ways to do this. The first is to have long-lived pre-production environments, and I think this is pretty common in most organizations. And you would test your changes in one of them, and then promote them, if you like, to your production environment. If you're finding though that your team or teams are kind of fighting over these pre-production environments, you might need to consider ephemeral pre-production environments where your pipeline actually will stand up a new set of infrastructure just to test the change you're proposing to production. Now, there's some patterns to actually run these tests. The simplest one, and one that we use for a lot of services, is you deploy the whole change to a pre-production environment when you open a pull request, but also, as I mentioned earlier, run that planning as production, show you what that's going to look like, and then merge the change into production, deploy the change into production once you've merged. There's a hard mode here where if you're finding that every once in a while, these PRs work fine in pre-production, but then when you deploy to production, don't work, where you begin with deploying the production infrastructure into pre-prod and then deploy the entire proposed change. And you only really need to do this if you're finding that individual commits deploy okay, but then the whole set of them combined don't. Because there are some infrastructure changes that work okay in a sequence, but don't work okay when you do them simultaneously. It's just the nature of the beast, unfortunately. So that's a lot of information. Let me try and bring it back to something you can kind of take away from this. Yes, you can apply CD to the infrastructure, even if the work is uninterruptible. We do it all the time. We're very happy with it. And there are two things you need to remember. Ironically, start with two. It's a lot easier to go from two to more than two. And try to develop some mechanical sympathy. Understand who uses your platform, what they use it for, and how that work behaves when it gets interrupted. Thank you so much for your time. Questions are welcome. If you want to reach me, that's my LinkedIn link there. Thank you so much.
I will unmute myself. Sorry, it's early. Okay, once again, we're going to do a prize draw. So let's make sure that we get our comments in with the hashtag SHIPPED24. I'm really hoping that we don't draw Octopus Deploy again. This tool was not written by me, by the way. So, but it does allow you to do multiple draws, and it won't redraw winners. So there you go. So make sure to submit a comment. Hashtag SHIPPED24. You'll be entered into a prize draw. Or, yep, mandatory. Here we go. This is when they all come in. Awesome. Yep, we are live, so there you go. There we go. Nice. Getting those in. So let's go ahead and do another prize draw. Let's keep our fingers crossed that this time we're not doing Octopus Deploy. That would be, oh, I saw it there, but that's for a different account. So, Josh, there you go. Congratulations. You are the winner. So for the next draw there. So I'll just take down your name here. All right. Awesome stuff. All right. Well, moving right along. We've seen a lot of great sessions so far. It's been great to see folks talking about some awesome stuff. I love CD for infrastructure. I think it's a great concept. Coming up next, let's go ahead and bring up the schedule again. Coming up next, we've got Lucy Spence talking about optimizing time-sensitive deployments, architecting Octopus for efficient large-scale rollouts. Lucy is a senior technical product manager here at Octopus Deploy, and in this presentation, she talks about how oftentimes in real-world scenarios, your deployments are time-sensitive, and that is the norm, right? You got to get it out. You got to get it out yesterday. So what Lucy does in this session is talks about some of the strategies that you can use to optimize your deployment processes for maximizing efficiency and impact within those limited time frames. So let's see that one.
Thank you everyone for joining me today. My name's Lucy, and today what we're going to be talking about is optimizing time-sensitive deployments by the choices that you can make within Octopus and architecting, I guess, for efficiency within large-scale rollouts. Specifically, we're going to talk about some strategies and signpost features that you can use, which will help increase your throughput. Let me start by giving you a bit of background on me. I'm a senior product manager at Octopus. I work in the deployment domain of how we actually, the back end that does all the deployment stuff. I've been here for a year and really been looking at how we scale that and how we can make sure we keep up with customers' increasing needs as they scale. And so I'm going to talk you through some aspects of that, ensuring that you can, if you do have time constraints around deployment windows and things like that, that you'll set up as best you can to actually make that a pretty comfortable process. So let's start off with what is typically industry best practice. I've stolen this particular image from SAFe, one of many frameworks that you can look at, but generally industry best practice is this idea of continuous deployment. And it's sort of held up as the gold standard that everyone should be working towards or aiming for. That's all well and good, but what happens if you can't do that? And it's just not a realistic goal or ambition. And there are really good business reasons for this. And some of those business reasons are as a result of technical constraints. But if you've got an older application or anything where you can't do zero downtime deployments, maybe you don't have another machine to fail over. Maybe you're doing isolated machines. Maybe you have contractually agreed deployment windows. Maybe you need to do out of hours stuff. And maybe there are just a lot of prod machines that need to be updated in a very short space of time. Otherwise, bad things happen. So what we want to look at is kind of what we're talking about. What we want to talk about is how we do lots of machines within a short period of time and what that might look like. There are some common characteristics here just in terms of this particular scenarios that we're talking about. We're talking about prod deployments typically. We're not doing large scale of machines in development environments and things like that. It's out there, it's got people using it. If we're going to cause an outage, that's going to disrupt our users. And so that needs to be managed. We usually need to finish all machines within a certain period of time. And in this case, what we're talking about is not just small number of machines, but something where we need to actively manage the throughput to achieve the goals that we want to achieve. We may require enough time to roll back within that deployment window. And because we're often not doing this particularly frequently, we might have quite a large change set that needs to go out the door. So we might have a month's worth of development that we want to release at any point in time. And there are obviously, sometimes there are contractual obligations around this. So the kind of scenarios that we see in our customers are things like, rolling out to medical devices in hospitals, rolling out to point of sale machines overnight in retail businesses, rolling out to factories and manufacturing equipment. Various things like this are where you end up, you're not able to do a zero downtime deployment. You need to manage it when the tool isn't being used, and you've got a lot of things that you need to update all in a specific set of times, and there's quite a lot of coordination around that. And so this is where throughput becomes the interesting challenge, and this is really where we're going to spend the time today. So I've mentioned throughput a couple of times. What is throughput? Throughput's really, I guess, how many deployments you can do within any given time. Every customer will have different requirements about this. We hear people having 30-minute deployment windows. We hear of people having 8-hour deployment windows. We hear of people doing it over super fast networks, and other people going, well, actually, I've got to deploy to rural communities over sort of home network environments, and broadband can be a real, a strongly influencing factor there. I guess when we talk about how to increase throughput though, other than those large system-wide constraints or environmental constraints you've got, the three things that we want to talk about are increased parallelization, shortening each deployment, and improving system performance. And that's where we're going to spend our time today. And the majority of it, we're actually going to spend talking about increasing parallelization, because it's a tricky topic. It's something that people make choices about often before they understand the implications of it. And so I just want to give people a bit of a model to think about parallelization with, so that they know where they might be getting into issues before they hit those issues. To start with, let's get everyone on the same page around when we talk about a deployment. What are we actually talking about here? In very, very simple terms, a deployment, you typically have an application, you have some sort of deployment process, and it goes out to machines. There is some configuration there are some constraints around that, and the deployment process is typically made up of steps. And we can break those steps up into the pre-flight checks, which are the things that you need to do before you actually start doing the actual deployment or the activities that may cause an outage. And then you do the thing, and then you have to validate that it's actually worked. And typically, we find that most deployment processes have some aspect of all of those. They definitely have the middle one. And usually as they get more mature, they have more around the front and the back of those. So let's talk, now that we've got that sort of understanding, things we care most about in optimizing throughput are concurrency, or that parallelization that I mentioned. And there are kind of the two levels that you can do that at. One is the task level, and the second is the step level. And we'll pick up those separately. We'll spend a bit of time there. We'll then talk about some of those pre-flight checks. This is really how you shorten your deployment duration by doing what you can ahead of where you're actually needing to do the deployment. And then there's configurations, some tweaks that will help you along the way with system performance and various aspects like that. And we can talk about failure mode and just a few quick tips and tricks to help you along the way. Right, let's focus on concurrency. I talked about two different modes of concurrency. The first is really modeling choices. I'm going to talk about this as task level concurrency, because if you're familiar with Octopus Deploy, you will be usually familiar with the task list and the task queue, and this is where you see your deployments happening. And the level of concurrency you can achieve at this level is generally determined by some of those modeling choices, which are how you manage the relationship between your application and your machines and your deployment processes. The reason I think this is really important to understand early on is because most of the time, well, what we're talking about here really is projects within, or is the construct within Octopus Deploy. And most people, when they're thinking about projects, they're thinking about how they want to split up projects. They're thinking about teams, user access, Git repos or source control, and trying to get the structure right there for how they set up their projects. But it will have an impact on the level of task concurrency you can achieve depending on how you do it. And what I mean by this is really thinking about whether you have one application to one project, whether you split an application into components across different projects, or whether you have multiple applications within one project or something else. You know, there are combinations of those that you could apply. So this is one of those decisions that people will make for a lot of reasons. There are all of those are really good things to consider. They're just a bit beyond the scope of this particular talk. So I'm going to focus on the performance aspect so that you can just understand if you're getting set up, how you're going to, what the implications are. Because the thing that we find with our customers is when they do get into kind of those moments of regret, it's often at this level and they're like, oh, we got it wrong, but now we're in the process for doing that. And that's how we've rolled out across the organization. And it's quite difficult to start changing at that point in time. So getting this right is something that's quite important. You can change a lot for a lot of the other stuff at a later point in time, but really do spend a bit of time here and just working through, if you know you've got some time pressure deployments, this is kind of the important stuff to get right, otherwise to avoid rework. The next bit is machines. You have a number of machines that you need to go out to. How do you want to manage those? Are you using targets and target tags, or are you using tenants? What we often see with tenants is that our customers use tenants to segment their customers or their locations, maybe their stores or particular cloud regions. But tenants will also impact the level of concurrency that you can achieve between your various deployment tasks. So it's worth having a think about that. I'm going to step through some examples of how this impacts those tasks, and so what happens what can happen concurrently and what it can be limited by. It is worth saying, yeah, we'll talk about task caps in a bit, but assume what you've got when you talk about task concurrency is that that is something that's very easy to increase. So one project, one deployment process to one machine would be one task. A second project deploying to a second machine would be a separate task. You could run these in parallel. If we have one project that is deploying to targets, to machines, that is one task. We don't necessarily separate out the machines at this level. It would be one task, and it would need, the deployment would need to complete on both of those machines before that task completed, and you could start another task. If, however, you use tenants and those machines are assigned to tenants, that will actually split out two tasks. So you could have exactly the same process going to the same number of machines, and in one situation it would be one task, but with the inclusion of tenants, you could make that two tasks. That gives you just a bit of optionality about which direction you want to go in for this. This, just to show you here, is the UI where I think it's in the project settings where you can allow deployments to use tenants, although you have to map the project to the tenants as well as configuring the tenants themselves. But yeah, that's a really good feature to explore if you haven't. Quite a lot of our customers do use it, but there are still some who are looking at it going, oh, don't know whether that's appropriate. This is really where it becomes super useful in terms of deployment performance. Now, if we combine those two scenarios, we have 4 machines that we want to deploy to, and we have 2 in each tenant, that would still be 2 tasks. In terms of, I think something that I didn't mention earlier is when we deploy, if we have a deployment process targeting multiple machines, it will try and do things to all of those machines at the same time, which works for a small number of machines. However, as you get to a larger number of machines, you may want to think about that slightly differently, and we'll talk about that in a little bit. Where you have a scenario, we get into this is getting into the interesting stuff, actually. This is where it sort of becomes fun and a little bit more challenging. If you were to have 2 tenants running on 1 machine, you would have 2 tasks here. And you can control that at the machine level with the concurrency tag about how many tenants you want to run or execute on that particular machine at any point in time. There are reasons why you may want to increase or decrease that. As a default, we will execute 1 task at a time per tenant on that machine, and then the other tenant will wait, I think, for that to be done. But there are times when you might want them to work in parallel. So there's some stuff. I'm not going to go into huge levels of detail on that. We have some good documentation around it, but just know that there is a tag there that can help you control that, what is actually happening on that machine between tenants. The other thing that you'll need to do, and we'll talk about this in a bit more detail, is the bypass deployment mutex. Octopus typically only runs one process on a machine at any point in time. And the reason for this is we behave defensively around file systems. We don't know what's happening in your deployment process. So we have to assume that if you try and run same processes, it might be using the same, it might be trying to access the same part of the file system, and we want to avoid locks. So it is set to execute 1 process at a time per machine. And if you want to get increased concurrency on that machine, because you know that your deployment process is safe, there is a mutex bypass tag that you can use. Another way of increasing task concurrency, if you want to, is to use the deploy release step. This is where you trigger another project to deploy as part of your first task or first deployment process. This spins off what is effectively a child task. And so this will complete. The child task should complete before the deployment process continues on. There are some really good reasons for using this. There are a couple of caveats though. If you end up doing this in a combination with tenants and you have multiple levels of deploy a release step, you can generate an awful lot of tasks very quickly. And then depending on your task cap, you might struggle to get through all of those. So there is a point where you can end up with too much parallelization. And so we would only really recommend 1 level of use of the deploy a release set, and not to chain those orchestration levels to or too many levels. If in doubt, please reach out to us and ask whether we think something is going to be problematic before you do it, because it's quite difficult to unpick once you've got there. So just going to recap some of that. Individual tasks can run in parallel, or will run in parallel where they can. This is limited by the task cap. The number of tasks will be influenced by that relationship, primarily between projects and how you're managing your machines. And the deploy release step can be used to trigger different project release processes and ensure that there is a relationship between that child project and that parent, and that they can complete in the right order. What we didn't spend a huge amount of time talking about was, which I will just say, is talk specifically about the task cap. Depending on what license you're on, you may start off with a task cap of 5. We go all the way up to a task cap of 160. We have some really exciting stuff coming down the pipeline where we're going to be able to offer a much higher task cap than that. So if you're doing really big deployments, we should be able to handle, hundreds, possibly thousands of concurrent deployments, which will ease quite a bit of that time pressure for people. So that's the task level concurrency. I wonder how many times I can actually say concurrency in a presentation. I'll have to count at the end. Now let's talk about the concurrency that you could get within a deployment process itself. The level of concurrency you have in a deployment process itself is likely to influence the length of time that particular deployment process takes to complete. And if you go back to the throughput sort of definition we were talking about, it was the number of parallel tasks and the length of each task. And so this is about how we kind of can think about the length of, one of the ways we can think about the length of each task. We looked at this model before: one project, 2 machines, 1 deployment process, that's 1 single task. However, what we talked about was it going out to all the machines at the same time, whereas there's this thing called rolling deployments. You should become familiar with rolling deployments, which is where you can set a window size to say, this is how many machines I would like to be dealt with at the same time. We typically think a window size of 10 would be a great place to start, and then from there you can dial it up or down depending on what you see happening. And that just means that we can go and tackle a certain number of machines at any point in time. We touched on this a little bit beforehand, which was the deployment mutex, which is where if you have multiple processes targeting a single machine, it will only execute one of those deployment processes at a time on that machine, or at least one of those steps, unless you say, actually, we know we've set our deployment processes up so that everything is uniquely identified and won't lock anything up, and therefore in this situation we can run more things. This will also depend on how much resource is available on that machine. Bear that in mind. Octopus assumes that it can kind of have access to everything and do everything, and it has full usage of that device's resources. So bear that in mind if there are other things happening on that device at the same time. Now, we can also do steps in parallel. This is a general configuration option on all steps. You can say run in parallel with the previous step. Again, in this situation, if you wanted those parallel steps to target the same machine, you need that mutex bypass to ensure that happens. However, if you're targeting different machines, that's okay to go ahead and do that. And that will allow you to handle multiple steps at the same time. So just to kind of signal you towards the finer grained controls we have of these things, if you're going to set up, we've talked quite a bit about the bypass mutex, that's really at the machine level. We have a couple of other tags around acquire max parallelism, which is about acquiring packages, and action max parallelism, which is how many steps do you want to, how many times do you want, or how many steps do you want to try and action at the same time. Again, we default to 10. You can increase that or decrease that. be aware of the implications that increasing that will have on that machine's resources. That's really why we can't give any strong recommendations in this space. It's sort of up to you, depending on the hardware you have, and to figure this stuff out. But these are things that you can play around with, and that task concurrency tag becomes really useful around both environments and tenants when you're running them on the same machine and you're reusing. So you might, people will typically do think about this a little bit more in terms of, I guess, some of those lower environments where there might be a lot of reuse on the same piece of hardware. But we're not talking about those today. We're talking about prod deployments today, and lots of machines, not lots and lots of stuff happening on the same machine. So that's a fairly quick overview of your options with regards to concurrency. What I want to talk to you about now is pre-flight activities. What can you do, when we talk about deployment processes and things being time constrained, let's make sure that we only need to do the things that we need to do within that time constrained window. If we can do stuff in advance, let's do stuff in advance. Let's alleviate as much of that pressure as possible. This is one of the big kind of the best techniques for doing this. In general, whether you're doing pre-flight checks or whether you're having a pause point in here or not, if you can optimize your deployment process, fewer steps is generally better. Fewer and smaller variables is generally better. And also don't forget to skip steps that are not required for prod environments. We often have, if you use life cycles, it makes it quite easy to just drop out certain environments, or to target things to particular steps, or steps to environments. Sorry, got that a bit tangled. When I talk about sort of optimizing this, I guess I'll give you some sort of guidance in terms of the number of steps. It doesn't have to be none, or a very low number. 20 steps would be quite normal. If you're getting up over 50 towards 100 or something like that, you might want to think about whether you can reduce that number of steps. We do have people go over 100 steps, but these typically take a long time, and it's just a lot more resource intensive of having to pass things back and forth between various steps within the deployment process. Okay, so that's general advice on deployment processes. What we've talked about is, I guess, those pre-flight checks and how we get between them and actually doing the main part of the deployment. And essentially what you have is you have one deployment process and you have a step for manual intervention in there. So you can pause until until the clock starts ticking, really. And that becomes the point where you want to be able to do the absolute bare minimum of what you can get away with within that period of time, so you can do it as quickly as possible. When it comes to pre-flight checks, do what you can on workers so that they're ready to go. You really want your workers, where you're using them, whether they're dynamic or self-host, you want them to be warmed up, ready to go. If they need to acquire packages, acquire those packages. On the topic of packages, do what you can to get those, moving packages around is one of the, often one of the bottlenecks. Do what you can to get them as close to the machine as possible. If you can load, or if you can move packages to the device before a deployment window starts, I highly recommend that you do that. So, if you're talking about how, trying to fine tune it so any outages are during a particular, outages occur during a maintenance window, you can do some work in advance of that to just get ready. The other thing to note here, we have had a little bit of feedback about this and I'm thinking about it, but in the meantime, what it is worth noting is that Calamari, which is part of Octopus Deploy, and if you're using Octopus Cloud, it needs to stay in sync with Octopus Cloud. One of the great things about Octopus Cloud is you get new features all the time. Every now and then, one of those features requires an update to Calamari, and Calamari will automatically update itself. What you don't want to do is to have Calamari update during one of these critical time periods. And so if you can do something ahead of time, or in the hour before your deployment window starts, it's a good thing to do, just to prompt that little update so it's not happening during your window. Then we get to actually do the fun deployment stuff. And this is where it's like, consider what you can do in parallel. We've talked about this. What can you accelerate with workers? How much stuff can you get done in advance or outside of the actual work that you need to do on the devices? It sort of goes without saying, of reduce the package size where possible. This does ladder back up to how you want to think about your projects and whether you can split out various different components for packages, but also consider your failure mode. And I'll talk about that just in a moment, because we've got a couple of configuration tweaks that you might want to make there. Jumping back into the package size piece, obviously larger packages are slower to transfer. They require more bandwidth, and a bigger package will take longer than a smaller package. They also take time to unpack, and they influence the size of the file system usage, and it can mean subsequent steps around scanning things and doing things take a little longer. So it's just, again, it's one of those things that's worth considering. Just have a think. You'll know your situation better than we will. So we can't give you any hard and fast advice, but just want you to understand that what the implications of package size are, so you can think about it in advance. So we've talked about concurrency, we've talked about pre-flight activities. Final piece is just kind of some configuration. This is really just some nudges in particular direction. I think I mentioned that the Octopus Cloud task cap goes up to 160, and hopefully fairly soon that will start to go up even higher than that. If at any point in time you do want to increase yours, is one of the easiest ways to improve throughput. Reach out to support or sales, and we'll be able to help you with that. In terms of your log files, larger log files do put the system under more pressure, because each and every step there's more work getting done. We target 20 meg, or we suggest you target that if you can, of just trying to capture things around progress and failures, and then you can publish the rest as an artifact. Similar vein, use retention policies to ensure that you're not storing too much feed information or build information within Octopus Deploy itself. If you can get more of that outside of the system, we try and make the system as performant as possible, but if you're storing years and years and years worth of data in there, things will get slower. Or you will need to buy bigger hardware or upgrade your cloud instance. So, just think about things there. The final thing I want to talk about is really around failure modes. Fail fast if you can. You don't want to be waiting up all the time or get to the end and find out that something failed. See if you can fail as quickly as possible, and then see if you can fail in ways that are easy to resume or continue. We have a feature that supports this, which is guided failure mode, where instead of failing a deployment, it puts a pause point in so that you can rectify whatever the cause may be. Perhaps a machine runs out of resource and you need to reboot it or something like that. You can use guided failure mode to continue on the deployment once you've gone and fixed the issue. And the other aspect around this is we have some recently introduced retries features around different steps and around network connections. Please do look at those and see what you can retry and think about the idempotence of your deployment process. How easy is it to get the same result if you retry it? The more you can retry, if there is something that goes wrong, the more likely you are to get to a successful deployment. That is pretty much all I wanted to cover in terms of thinking about how you can optimize your throughput and the features that we have that will support that. And I hope that's been useful and given you a bit of a whirlwind tour. I know there was quite a lot there, and it's not necessarily the most enthralling topic. However, what it should do is give you a mental model of the features that you have, and when you're looking at choices, just to be able to go, this might have an impact on our performance. We know we're going to have challenges around this. Let's make sure we factored this in the right way. And I really hope that it has provided some help in that regard if it's a topic you're interested in. If you have any questions, if you have any feedback, or you are experiencing these particular challenges, I would love to hear from you. It's something that I do spend quite a bit of time thinking about, and really trying to understand how we can help you ship what you need to ship within the time that you need to ship it. And thank you if you've made it this far, thank you very, very much for your time. I hope it was worth your efforts.
All right. Thank you, Lucy. Great presentation there. Awesome. I hope you guys all found that useful. Once again, we are going to do another prize draw, so make sure to submit those comments/questions using the hashtag SHIPPED24. We'll give you guys a few seconds here just to submit some entries. We'd like to do another prize draw. Where these sessions are coming fast and furious, so there you go. And don't worry, I'll just want to remind folks that all the sessions are being recorded, and they will be available up on our YouTube channel a little bit later today and tomorrow for the ones that are tomorrow. So don't fret if you happen to miss something. So let's get those entries in. Hashtag SHIPPED24. I see some coming in. That's great. I'll highlight a couple of comments here while we're waiting. So Sergey here writes, "Hey, Octo team, I love the Octopus." Okay. And used it for 10 plus years. Made it my main tool in my arsenal. That's awesome. Thank you, Sergey. We hear that a lot. It's sort of one of those tools that you never want to let go of. So that's awesome. All right, let's go ahead and do another draw. Hopefully we won't get Octopus Deploy this time. This is going to become a meme of me drawing Octopus Deploy each and every time. All right, Matt. All right, you are a winner. Congratulations. Let me go ahead and write down the name here. Congratulations, Matt. And we will be in contact shortly. Awesome stuff. All right, let's go ahead and jump back to our schedule. Coming up next, we've got Kirsten and Kit. They've got a talk entitled 5 Ways to Level Up Your Kubernetes Deployments with Octopus. This is a great talk. I mean, like, there's a lot of stuff that's coming down the pipe regarding Kubernetes. Like, there's tons of updates. You saw it in the keynote. You're seeing it a lot here. And if you're wondering if you're missing out on those features that could streamline your workflow, this is a great talk for you to watch. So Kirsten is our lead product designer, and Kit's our principal product manager. And together, they are giving you the TLDR on 5 powerful new ways or new Kubernetes features. And so they'll break down the benefits, the best practices, helping you quickly decide which updates are right for your team to get the most out of Octopus. So here we go.
Hello, everyone. Welcome to 5 ways to level up your Kubernetes deployment.
So we're really excited to give you the TLDR on a few powerful new features for Kubernetes in Octopus.
So, who we are and why we're here. So I'm Kit, I'm a Principal Product Manager in Octopus, and I'm from the team called Modern Deployments. This team for, I guess, 2 years now, has been fully focused on how we can make Kubernetes deployments better with Octopus.
So I'm Kirsten, and I'm a lead product designer, and I work alongside Kit and our fantastic team of engineers in the Modern Deployments team.
So, what is it all about? From the very beginning, Octopus was designed to simplify complex deployments across many environments. So it was always a problem. How can we orchestrate a few applications which we need to deploy for maybe 10, 15, 5 environments, and we need to do it in a consistent, reliable way. But something changed recently with the embracement of Kubernetes. So the challenge actually got way more complicated and way bigger. With the Kubernetes capabilities, with all this scalability and declarative approach, and the way how Kubernetes can auto-scale, and the new way to construct applications, we're now dealing with not maybe 10 or 15, but hundreds of microservices, hundreds of applications which people want to create and deploy dynamically, and sometimes do the deployment every few minutes. Moreover, due to Kubernetes and other cloud services, we now can do this. We can now have more flexibility around environments. We can create environments on the fly. We can have an environment for each code branch, and our developers can test it there before they go and deploy into shared QA, staging, or production. So the scale grew enormously, and all that should work fast, should be seamless. So all that led to a complicated deployment landscape. And we in Octopus, we saw it as an opportunity. Like, how can we actually extend our capabilities and the things we did for so many years for all our platforms to make it scalable, usable, and simple for Kubernetes? So that's why we decided to leverage all these features and deliver incredible Kubernetes experience.
So over the past few years, like it mentioned, our team has really focused on enhancing the Octopus for Kubernetes deployment experience. And we've rolled out numerous improvements, and we've seen really great uptake so far. Now, each new feature, when you consider it individually, makes deploying to Kubernetes more efficient. But when you actually combine them, these features start amplifying each other's strengths, and they can really bring your deployments to the next level. And that's what we're going to talk about today. So how can you combine some of the most powerful new features that we've built into Octopus to create a great scalable deployment system for Kubernetes?
All right, so let's make it a bit more real now. So let's imagine a customer, hypothetical but very real customer, which we helping to solve the Kubernetes deployment problem. So let's say we all work for a company with dozens of developers team. This is a significant player on a SaaS market, delivering top-notch product. We won't specify what market it is or what product it is, but assuming like more or less same problem would be applied, formal space would be applied for all SaaS companies. So we as a company, a hypothetical company, harnessing the full power of Kubernetes. We deploy across multiple environments, we manage multiple production clusters, we host maybe a cluster in each region. We as an organization maybe handle over 500 of these microservices, and many of them be deployed multiple times a day. Our engineers, our application developers, are exceptional, but they are not necessarily Kubernetes experts. We don't expect them to be, right? But our platform team, on the other hand, they are among one of the best in the industry, so they know Kubernetes in and out. In our environment, compliance and security are paramount, so we want our clients who place trust in us to be fully protected, and we take this seriously. So how can Octopus help to streamline deployments for this hypothetical company while ensuring that they remain secure. So let's go through these features and explore this together.
So here's a quick overview of exactly what we're going to cover. First, we're going to look at Git as a source of truth. Then we'll move on to how you can leverage advanced templating for Kubernetes. Next up, you'll learn how you can set up pull-driven deployments in Octopus. And then we'll move on to observability to help you with troubleshooting. And finally, we're going to share the easiest way that you can connect to your Kubernetes clusters.
So let's start by diving into one important topic: managing Kubernetes manifests, held values, and scripts. So all these are form of code. And as we all do, we probably store code and evolve these artifacts in Git, like with any other code, like with our application. What's great, that's in Octopus, you can actually seamlessly source these files right from Git. You don't need to package that, you need to send it in any other way and form for Octopus to consume it. You can just connect your Git repo straight to Octopus, and not just one repo, but as many of them as you want. Not only that, but Octopus also keeps versions of these files alongside our mutable release. So this means that you can confidently deploy your configuration even if the original source, for some reason, becomes unavailable. How great is that? So using Git as a source of truth for configurations is the best practice in the industry, in Kubernetes in particular. What you can do here is start combining, and we'll talk about this in a second, start combining Octopus variables with your Git source files so you have flexibility to implement the solution, Git-based source control solution, and also make it scalable so to cover all your needs.
All right, now let's talk about your options. So you can either create unique versions of your manifests for each environment, or second option is you can use a single configuration template across even multiple projects. So if you take the first approach, you'll maintain complete control of your configurations in Git, and every environment will have a specific version of the configuration file. Now, one thing to keep in mind with this option is that you'll need a way to automatically update these files every time you want to release a new version of your software. Now, on the other hand, if you look at the second option, you can separate routine updates like image tags from environment-specific parameters and from your core configuration. So this makes it really easy to scale. Now, if you go this route, we recommend using Octopus system variables and container references.
So what we're talking about here is basically you can implement any solution you want with Octopus, starting from everything in Git as customization option A, or one file in Git, everything else is dynamically generated, and you can find something in the middle. So if you do that, if you go into more templated and more, let's say, dynamic approach, consider setting up something like a variable set specifically for storing environment parameters. And then in this case, what it does, you can have one set of variables creating something like number of replica sets, for example, or specific maybe database strings or labels, and you can use this once defined variable across as many microservices and many projects as you want. That will allow you to share these common variables and still have one point of control. So you change them once, you control them once, and all the projects, all the microservices gets updated. So that's how you can save time and basically avoid the need to change all the files if you need to introduce just one little change across, for example, just one environment. So if you have like this variable set and one variable across all the project, you can also minimize the number of variables to manage it at the project level. That's also like helping you to get Octopus more manageable. Now, going into where you can actually find this, you can use files from Git with all of our built-in steps. So customize and all overlays can be stored in Git. All the YAML files, of course, could be stored in Git, as well as Helm. You can store like values file in Git, and again, you choose if you source just one, for example, value file per application, one values file per environment, or just one for all the microservices.
Now, imagine you're in a situation where adjusting just a few variables in your configuration template just isn't cutting it anymore. So perhaps you're looking to use one configuration template across many of your applications, and you need the flexibility to enable or disable entire configuration modules, so things like ingresses or persistent volumes at a project level. So in this case, there's a really powerful solution, and that's combining Octopus variables with Helm or Customize.
Cool. So here what I recommend. Maintain your core configuration in a central Helm chart or Customize base. For each project, you can create something like a dedicated Helm file or Customize overlay. Think about this. So I have 500 microservices, and they probably few groups of these services, right? Something like backend for front end, some APIs, maybe some front end service, etc. And they're a bit different, but I still can use one template across all of them. But for example, for one of them, I enable ingress, for others, I don't, etc. So I have one big configuration template managed by someone like my platform team, and then I'm starting to just customize it on the application level, switching on and off different things with a special overlay if we use Customize or a Helm values file. So all the project-specific adjustments now are neatly contained within these files, but these files are still stored in Git, managed through Git processes. You can apply peer reviews to, and you can just examine them all as code, right? Now, I have these files. I have a way to modify configuration to my particular project. What should I do to promote it through environments? Because here I need to modify them again. In this case, modification across environments might be not that significant, but still important, right? I need to change labels, I need to change number of replica sets. How would I do that without creating this? Let's say I have 5 environments, 5 values file for each project. So here you can use Octopus variables. And that's how you can introduce just another smaller changes for each environment. And as I said before, if you use something like system variables or variable set, it's a metric structure. So you have your variable values file per project, your variables per environments, and it's all get together nicely when you do deployment. And you have to manage just less entities. So you don't need, if you think about this, you don't actually need any special configuration Octopus to make this advanced templating work. What we recommend is just start simple, have one project, just decide if you want to use YAML, Helm, or Customize to manage configuration, and think about this as like, I'm just writing configuration for one project. And then as you go further, maybe you have a second one, think about if this project is different, or can I just reuse the same template? And if I can, what could be different about this? What should be different about this project? And then you can scale from here. Add another one, and another one. Think about the variables you want to introduce. And just go from there. Don't try to overthink it from the very beginning. Okay, so now we have a golden configuration template. This template has been reused across hundreds of projects. Many teams continuously create new versions of their applications, and they need to promote this across various environments. There is the next problem, a catch. Sometimes you also need to make tweaks in the configuration for all the projects at once. Let's say it's a critical hotfix or security update. So how can we, with all this centralized templating and sourcing everything from one place, but also having project independent, now enforce changes like, I want to update all of them at once with a configuration change? Let's talk about this.
Right, so in Octopus, every deployment begins with the creation of an immutable release. Now, there are several ways that you can do this. For example, you could add a step to your CI process to generate a new release every time you build a container. But this can become quite tedious, especially if you're managing hundreds of pipelines. Luckily, there's a better way. So Octopus now has a fantastic set of features, Git and external feed triggers. So these triggers allow Octopus to automatically discover when there are new versions of your application and then create releases on its own. So this capability extends to container images, to Helm charts, and to your Git repositories.
So you can combine triggers with lifecycles, and then possibilities are truly endless. So what you can do, you can design different promotion strategies for container images of, let's say, different tags. So you can say, if it's a hotfix, I want to deploy it straight through all environments to production. I don't need to do any separate checks, or no one should do any, none should mainly apply any of these promotions. Or, for example, if it's just a feature branch, this container should never go into production or even on staging. It should stay in the very early environments. And on the other hand, if it's a configuration change, then again, maybe if it's a critical one, it should go all the way through. So each trigger can be configured in a way that, based on something like container tag, it can choose certain lifecycle, and then it's a fully made process. As soon as you build a container, Octopus will pick it up and will deploy it according to the lifecycle you pre-created. No extra manual steps are needed. So if you are looking to deploy configuration updates across multiple projects, remember this scenario. So we have high-fired microservices. We configure triggers to deploy each of them with, let's say, every time we build a new container. But now we have a critical fault fix and we want to change the actual Helm chart. And we just can't wait. We must to deploy all of them right now because this change is really big and impactful. So in this case, in Octopus, we can use something we call orchestration projects. So this is a special project which you use for one thing and one thing only. It just creates and deploys, release and deploys all other 500 projects. So how we do this? We just create a trigger for this project. This project will look into a particular Helm chart, and as soon as there is a new version, it will trigger deployment for all other 500 projects using this Helm chart. So how can you find all these features? How can you start exploring them? It's actually quite easy. If you go on the project page, you'll find a trigger menu point there. Just click on this, add a new trigger, and start configuring it.
All right, so now you have hundreds of microservices and they're all neatly organized. Your platform team is managing a single configuration template that's stored in Git. Everything is really well structured. Every software team you have can personalize their templates through Helm values or through customized files, and they're all saved in Git. The best part is you don't have to tweak these files for every deployment. So Octopus is automatically detecting new container versions and initiating the deployment for you. But here's the challenge. How can you ensure that those deployments are actually successful on your cluster? So because Kubernetes operates on a declarative model, applying a new state doesn't always guarantee that the cluster can actually reach it.
Right, so what you can do here. So for your 500 microservices, how your team would know if the microservice is actually running in the cluster? The first and most obvious choice, you can just use something like an extra monitoring tool. So I'm a developer, I just build my new container. I know that container would be deployed within the next couple of minutes by Octopus to an environment, and I just need to open another tool and look at what's going on in the environment. And if something goes wrong, well, you can always run kubectl command, get logs from the cluster, get events, and just start your discovery. But let's be honest, this process actually feels a bit tedious. And if you think about this, requires a lot of knowledge from developers and actually also involves some risks, right? Especially if we're talking about some high environments like production staging. Do we really want people to go and investigate the issues with kubectl? Probably not really. So there is an alternative way in Octopus. So what we can do is we can verify deployments using what we call Kubernetes object status. So this feature is configured on the step level. And basically, Octopus knows what objects you want to deploy to your cluster. And as soon as you did the deployment, Octopus starts to check the status of these objects, and it waits till the cluster achieves desired state. If this desired state was achieved, all great, your step will be successful, and you will see this small but informative table showing you each object which was deployed, some basic information about it, and the status. If not, then the step will fail, even if the configuration was applied successfully. But if cluster didn't manage to achieve the state, it will fail anyway. And you'll see from the page what objects failed and also maybe what state it was. Another benefit here is just a good overview. If you want to know what was deployed, maybe you're not really as a developer familiar with the big Helm chart, you can just see it here and you say, okay, my Helm chart just produced this like 50 objects, and now I know what they actually do.
So Kubernetes object status is available with all of our YAML and customize-based built-in steps. And if you're using Helm, we suggest leveraging the atomic or the weight flags so you can achieve similar reliability. Now, we're not stopping there. Our team has been really busy, and we're actively developing a new observability feature called Live Status. Now, this is going to give you ongoing visibility into the status of your deployed resources well beyond the initial deployment. So with Live Status, every team will have instant insights into whether the configurations are actually successfully running on the cluster. Now, you'll even see a live summary for every project and environment right on the main Octopus dashboard. There'll be detailed information about each object, its health, events, logs, and the YAML that you deployed. So we're really looking forward to launching an early access release of this soon. And if you're eager to give it a try and give us some feedback, please go to the link on the screen. It's oct.to/live status to register your interest. So I'll give it a second for you to open the link because we'd really love to get your feedback on this new exciting observability feature that we've been working on. Right, back to you, Kit.
Thank you, Kirsten. Just again, really looking forward to hearing from you and getting the feature better. Finally, we just talked to how you can organize deployments for 500 microservices, how you can, instead of having 500 files or more, have just one golden template and introduce adjustments on the project level, and then with Octopus variables on the environment level, and how your developers can avoid getting into cluster or another tool to understand if the app was, if each of these microservices was actually successfully deployed or not. What we didn't talk about is how you can actually run deployment on the cluster itself. Connecting to your cluster and executing tasks on it is actually not as easy. So to streamline this process, this year we introduced Kubernetes agent. This agent operates on the cluster, and all your deployment tasks run on the cluster where the application will eventually run. So why is it great? So first of all, with the agent, you don't need to think about authentication to your cluster. You don't need to rotate your secrets or find a way to connect to your API. You also don't need to allocate extra machine, like resources, used for your deployment. In some cases, especially if you deploy often or your app is big or your deployment process is multi-step, that could be actually a challenging task. So you might need quite a lot of resources, which you would have to maintain and store somewhere else. In this case, that's not required. And finally, you don't need to open any external access. I mean, you don't need to open any ports in your firewall. You don't need to allow any external service access to your Kubernetes API. Instead, agent will talk to the Octopus server. And in this way, it will be just a safer connection. So even better is that you can actually automate the installation of the agent
as part of your cluster provisioning. So you can visit the automated installation section of the Kubernetes agent docs if you want to learn more about that. But basically, installing the agent is as easy as running a simple Helm command. And once it's set up, it'll register itself with Octopus automatically. Now, this means that adding a new deployment target has actually never been simpler, especially for Kubernetes. We recommend that you use the agent as the default method for deploying to Kubernetes. And it's really a game changer that simplifies your workflows and boosts efficiency. We've really seen great uptake and great feedback from the customers who've already started using it at scale.
Remember at the beginning, I mentioned that we didn't just have a lot of microservices, we also have multiple regions in production. Imagine this, tomorrow we want to add another region. Let's say we never had Oceania, and we now are starting to get more and more customers, and they want to have a whole region here to serve them better. So tomorrow, our infrastructure team just create a new cluster, and as a part of the installation process or the cluster creation process, we install agent there. Right after that, agent will register itself with Octopus without any other manual interventions. Octopus will know that there is a cluster, it belongs to a certain environment, and it actually a target for a group of hundreds of microservices. And then if you want to go even further and configure a special target trigger, all these 500 microservices could get deployed to this new target straight away. So no extra actions required, no extra control. You don't need to press any buttons, basically. And if you want to add another cluster tomorrow, same will work again. So that's how you can achieve true scalability. So let's sum it up. We covered quite a lot, and let's just try to highlight some takeaways. So we began our journey by examining how to source files from Git, why it's good, how can embrace declarative and version control approach to manage Kubernetes configuration. And then we talked about you can still do this, but you don't have to deal with sprawl of configuration files. You can actually allow Octopus to share configuration across multiple projects and then introduce changes with combining Octopus with Helm or Customize and elevate our configuration management to the whole new level. So we also explored the importance of separating environment and project-specific settings from a central Kubernetes configuration template. This separation is vital. In this case, we ensure that platform application teams have the right level of access while still granting them freedom they need to operate efficiently. Something like only platform team can change my central Helm chart, the golden template for all of my apps, but the application team has control over the values file to adjust this template for their project needs. And then on the platform team again, maybe have access to a variable set to change some environment-specific variables, but application team can go and change some variables on the project level. Again, maybe these are variables for the container. So that's how you can have a clear border and still provide people a lot of freedom. And yeah, this way you just don't need to manage myriads of commits to hundreds and hundreds of files every time you deploy a new version of microservice.
So as we progressed today, we covered the concept of pull-driven deployments in Octopus. So this approach will enable you to harmonize various microservices using centralized configuration templates and make your deployment process much smoother and more efficient. And near the end of the session, we discussed observability and its impact on the daily deployment experience that your developers have. So having really strong observability tools allows your developers to understand the many permutations that occur in their configurations. And it also empowers them to not only verify their deployments, but also to be able to troubleshoot issues autonomously. And finally, we mentioned the Kubernetes agent, which automates the provisioning of new clusters and also simplifies the management of your deployment infrastructure. But our journey with Kubernetes is not stopping here.
So we have exciting plans for the next year. And we do need to hear from you. We'd love to be we'd love you to be a part of this journey. So we need your insights and expertise to help us shape the future of the product. If you have any stories about maybe challenges you faced with large-scale deployments, or maybe particular examples of how you solved some problems before, maybe you have ideas about features you'd like to see in the product, or something which is not working as expected, and maybe you can do a bit better job here. Or maybe you just want a sneak peek to see what we're working on, and maybe give us some feedback on early mockups or UX, UI decisions we make. So we need to chat with you, and we're happy to do that. So down there on the slide, you'll find my email address, and you also find a link to book a quick 30 minutes chat with our team. Most likely, Chris and I will be there to talk with you. So we'd love to hear from you. Please don't hesitate. Send us the questions, send proposals, or even better, book a chat, and let's just have a live conversation. And yeah, again, love to hear from you.
All right. Thank you all for joining us today. That's it.
Bye-bye.
All right, there you go. Hope you're all taking notes. There's a lot there. Getting back, obviously, to our contest. Once again, we will do a draw for another free voucher to either the GitOps certifications that we offer or to our store. So make sure to get in your comments / question using the hashtag SHIPPED24. And by doing so, you'll register to get in the draw here. All right, so not seeing any entries right now, but that's okay. For now, what I'm going to do is just highlight something that my colleague Joanna was talking about, which is the State of GitOps report. This is a publication that we're currently working on, and this is going to be really awesome. We're actually asking a lot of folks like yourself to give us your thoughts and feelings about GitOps, and from that, we're going to generate a State of GitOps report. And so my colleague here, Steve Fenton, who's on our team, he's constructing the report. He's done a lot of writing, and he's interviewing you about GitOps, and we've been asking a lot of folks about this. And if you respond, you'll have a chance to win a prize draw for a one of 5 $100 Amazon vouchers. So make sure to sign up for that. Take the survey now. You'll find the survey. Let me see if I can find the banner here. Let's see. Yeah, here we go. So the report you can find later, and we're going to do a webinar about it. But if you want to take the survey, you go to this URL, and you'll find it there, which is awesome. All right, let's go back to our schedule. Coming up next, we've got Matt Casperson. Matt's a principal solutions engineer at Octopus Deploy, and he's going to be talking about our Copilot extension. So the title of his talk is Enhancing DevOps Managers' Efficiency with Octopus Copilot. For those who aren't aware, we actually have an extension for GitHub Copilot. You'll find it under the marketplace. So if you go to the GitHub marketplace and you do a search here for Copilot, there you'll find our extension, which is highlighted there. We were actually part of the Copilot launch, the Copilot extension launch that GitHub hosted. And so Matt was one of the engineers who worked on that Copilot extension. And so in his session here, he's going to be talking a little bit about that. So let's check out what Matt has to say about that.
Hello, and thank you all for joining this presentation called Enhancing DevOps Managers' Efficiency with Octopus Copilot Extension. My name is Matthew Casperson. I'm a Principal Solutions Engineer here at Octopus. And today I want to give you a walkthrough of the Octopus Copilot Extension where we run through the day-to-day workflow of a DevOps engineer as they commit code and push it out to production. But I really want to present this through the lens of those DevOps managers, and especially those managers who are responsible for fairly large teams. So we actually presented all of this at GitHub Universe recently. And one of the things we got to do when we were talking at GitHub Universe is really meet with these DevOps managers who are in charge of large teams. So we're talking thousands of developers and tens of thousands of applications. And they had a question around developer experience. And as an engineer, I certainly have a perspective on developer experience. But it turns out the lens through which these managers of these large DevOps teams think about developer experience is similar but slightly different to the way that an individual contributor may see it. And that's what we want to focus on today. So to give you just a quick preview of where we're going to be going with this demo, I just want to give you a sneak peek before we dive into the real details. So the first thing I'm going to do here is show the dashboard, and this will give us a little representation of the state of our environments. And through this, we're going to then promote an application through to production. So this is my application here, the audits application. I'm going to promote the release 1.84 through to the production environment. And what we'll see here is a small confirmation prompt. And once we accept that, the deployment of that application will go through to production. And the reason why I wanted to give that as a little preview is to really just set the stage and let you understand how convenient it is now to deploy applications through the Copilot extension. If we take a step back, though, what I want to do for the overall demo here is actually run through the process of committing a small feature change to our sample application and pushing that out to production. So this here is a small Node.js web application. What I'm going to do here is add a new endpoint. I'm going to commit that change and push it out to GitHub. So I will commit and push that change. And as a result of that commit, we're actually going to execute or trigger a GitHub workflow. I'm going to return back to the Copilot chat here, and this prompt here, show the GitHub workflow summary. This is really the entry point to that CI/CD pipeline or lifecycle. And from here, we get the live information or the live status of our GitHub workflow build. And as you can see, we kicked this build off 3 seconds ago, and green means complete, blue means in progress, and the other white dots here indicate jobs that have yet to be completed. And so this is live information. This is real-time information that's being pulled down into the Copilot chat through the Octopus extension. This is really one of the advantages of the extension and one of the driving forces behind the whole Copilot extension platform is really to extend the reach of this chat-based interface away from the mostly read-only interactions that developers will have as they ask about suggestions for coding, and allow it to reach out into the wider DevOps ecosystem. So I'm going to rerun that prompt, and what we'll see is we get a live view of the status of these jobs. So now the workflow is actually completed successfully, and one of the important parts of this workflow is actually this step here. This is where we hand over and create a release in Octopus and deploy that application into our development environment. So this is the CI half of the CI/CD lifecycle, and this is all handled by GitHub Actions and GitHub Workflows. But at this point now, we can show that dashboard again, and we'll get to see the CD half of this workflow. Sorry, the CD half of the CI/CD lifecycle. And what we see here is very similar to the web-based dashboard that you get to see through the Octopus web-based UI. But it is tweaked slightly to really provide an opinionated view of both the GitHub half and the Octopus half of the CI/CD lifecycle. What I mean by that is that this column here is focused on the build and the GitHub workflows. We can see here we have a link to the repo. We have the details of the workflow that was just completed a minute ago, and we have details of PRs and issues. And so this is the CI half of that CI/CD lifecycle. And then these columns here with development and production, this is the CD half, and this is the half that is managed by Octopus. And the nice thing about our extension here is that we can be really opinionated about how we display the CI/CD lifecycle. So the display that you see here isn't actually available in Octopus, nor is it available in GitHub. We have the luxury with this extension of assuming that users will be using both GitHub and Octopus. And so we can combine the information from both those sources and present it in a very opinionated and easy to consume view, which you see here. So what we're going to do again is just execute that prompt that we saw before, which was to deploy a release from one environment to the next. So we can assume that our testing of this application change in the development environment has completed successfully, and we do want to promote that deployment out to production. So this confirmation here is part of the confirmations API, which was added to the Copilot extensions. And the purpose of this is really to give people the ability to accept or dismiss changes that may mutate their environments. So in this case, we are actually doing a deployment to the production environment. And the goal here is to make sure that these values like 1.85 are matched correctly and the environments are matched correctly. So that is all matching fine. So I'll accept that change. We'll actually deploy that application out to the production environment. So we get some suggested prompts here. And one of them is to dive one layer deeper into the project dashboard. So the table that you saw before is really the space level dashboard. It shows the status of all the projects in that space. Now we're going to dive deeper and view the details of just a single project. Again, we get the full CI/CD pipeline view, which is the details of the build handled by GitHub and the details of the deployments handled by Octopus. We get some additional information here. Notably links to the artifacts. So test results here, those would be like unit test results, and the report.html, this would be the result of end-to-end tests, usually with a platform or a tool like Cypress to do browser-based testing. And we can see a little bit of the history of the deployments, but most importantly, we can see that the deployments of our application to the production environment are completed successfully, as noted by this little green dot here. So getting your deployments out to production is only half the battle, though. We still have to maintain those deployments in production and make sure they remain up and available for our end users. So we can imagine perhaps that there is a production issue, and as a result, the support team is getting notifications. And one of the common ways to rectify this issue is actually to run a runbook. So in this case, we'll run a runbook that simulates the restarting or the resetting of the web application. Again, because this is a mutating operation, we do have to confirm those changes, just making sure that the name of the runbook has been matched successfully. I'll accept that change, and the runbook has now been executed. Again, we get a couple of suggested prompts here, so I'll jump in, and we will view the dashboard of the runbooks. And here we can see that the runbook did complete successfully 14 seconds ago. And so the thing to take away from this is that within the space of a couple of minutes and using just a handful of easily remembered and easily shared prompts, we have now completed the CI/CD lifecycle for a change to our application. We built it, we pushed it to Octopus, we deployed it to the development environment, published it or promoted it out to production, and then in the production environment, we maintained it really by restarting that web app. And this really completes that CI/CD lifecycle and really encapsulates the majority of the tasks that most developers will do day to day as part of their activities. And so as a developer, this is really nice, but if we take a step back and think about this through the lens of a DevOps manager who's responsible for a team of thousands of developers and tens of thousands of applications, what we can see here is that it's actually quite easy to onboard new developers for a team that has implemented Octopus to manage their deployments. And so I guess one of the insights that we found in talking with these the engineering managers who really run these large DevOps teams is that DevOps to them is more about how disruptive is a technology if they were to introduce it. How much training do they have to have or give to their team members? What kind of interruption will the DevOps teams experience as they learn these new technologies? And how long before they can start doing those production deployments again? Because the reality is, if you have a team of 5,000 people, 4,000 of them aren't going to be interested in a tool like Octopus. It's just one tool of half a dozen that they have to use every day. And the reality is they just want to get the changes out to production. They're not necessarily interested in the details of how Octopus has been deployed. it should just be a transparent process to most developers. And the reality is they just want to get they just want to be productive. They just want to get their code out and in front of customers. And the engineering managers, of course, want to facilitate that. They want to minimize that disruption. And so one of the presentations that we actually did at GitHub Universe was exactly what I showed you there. We had a room full of 50 people, each with their own laptop. And as part of the presentation, we provided them with a half a dozen prompts that they could use through this Copilot extension in order to deploy their own application. And the results were really quite impressive. Like out of a room of 50 people, 25 or 26 of them actually managed to get a deployment of their application, a live deployment out to their first environment. And this is really quite impressive when you think about the fact that this was a room full of strangers, right? We didn't know any of these people. We'd never really talked to them. They may not have even used Octopus before. And in the space of 10 minutes in a live demonstration, they were able to get their applications out and deployed to an environment. So this is a really powerful way of onboarding developers into their deployment process. And I think for the managers of DevOps teams, it's really reassuring to know that for those developers who just want to get on with the job, don't particularly want to know or care about a tool like Octopus, that they can use a Copilot extension and just a handful of prompts that they can copy and paste and get through their day. But it's not just developers, though. It is really, there's more people involved in supporting and deploying applications. So we've already talked about the support team and maybe dealing with tickets and running runbooks like support runbooks, like restarting web apps. But there's also the SREs who are responsible for keeping those applications up and monitoring the logs and being that first line of response as problems or issues arise. And we also have support for those folks as well. So what I'm going to do here is now inspect the latest release and get a detailed list of the changes that went into it. And so the important thing to note here is that I may not be a developer. I may not be involved in committing the code, may not have necessarily a day-to-day understanding of all the changes that go out into production. But what I can do using the Copilot extension is get a detailed overview of the changes that went into production. And what's actually happening here is the extension is consuming a whole lot of information that it knows about a deployment. And that's going to be things like the diffs of the commits that were used or associated with the application that was deployed. And we get that through a feature that we call build information in Octopus. We can also get the information about GitHub issues that may have been closed as part of this release. And there's other information that we can get as well, which will be the deployment log and the actual configuration of the deployment project in Octopus. And we'll see how that becomes useful later on. But what I've done here is issued a prompt and just said, given the latest release, list each file that was changed and summarize the code differences. And so normally I would be depending on release notes for this kind of information, maybe commit messages. But as we saw before, the commit message that I made was very terse, added a new endpoint. What does that even mean? What it means is, as we can see here, that we added a new endpoint called new that attempts to call this function here. And as it turns out, we've introduced, deliberately, but we've introduced a bug where we've tried to execute a function against a null object. And the extension has actually been clever enough to understand that this is likely going to cause an error. But let's imagine now that as an SRE, I'm starting to see a whole lot of errors in the logs, a whole lot of type errors in the logs. And I need to understand what was changed, and I need to plan the next path or the next step forward. So what I'm going to do here is issue a prompt that says, given the latest release, identify any changes that may lead to a type error exception. And again, the Octopus extension here is going to reach into that deployment. It's going to consume all that information, all those Git diffs, all those GitHub issues that have been closed. And we're going to ask the LLM that backs this extension which of these changes could actually lead to this specific exception here. And the LLM is smart enough to understand that this is not valid code, and this is likely the problem. And so here we're really starting to support the wider ecosystem of the members of the DevOps teams. We've moved beyond just enabling developers to get their code out, And now we're really enabling the support layer to manage and understand deployments in a way that would be very hard to do otherwise, because Octopus has such a good understanding of what has been deployed and all the changes that went into it. An SRE could come in, understand that they're seeing these type errors in the log, and just ask the extension what may have caused this. And once we get to see changes like this and identify that this is fairly obviously a problem, we have a very quick way of moving forward and a path in order to rectify this information. So I'm going to move ahead now and actually look, instead of a deployment of code that fails, I'm going to look at a failed deployment. So when we develop the Copilot extension, we actually use GitHub Actions and Octopus. So we are a consumer of the extension that we actually write. And this here was a failed deployment of the extension some time ago. And the reason why I picked this is because it's quite a common kind of problem that DevOps teams will run into. For whatever reason, a deployment has failed, and we need to understand why. So I've specified a particular release here of a particular project to a specific environment and asked the LLM to summarize it. As it turns out, the error here is correctly identified as being caused by rate limiting in Docker. So the final step of this deployment process is to try and scan an SBOM and identify any vulnerabilities that may be present as part of this deployment. But it turns out the Docker image that we're trying to pull down that included Trivy was blocked due to rate limiting and too many requests here. So what I'm going to do actually is move away from just asking for a summary of the deployment logs and actually ask the extension to help me fix this deployment issue. And because this is a failed deployment, the extension is going to consume not only the deployment logs and things like git diffs, but also it's going to consume the configuration of the project that actually deployed this. So we're going to get the details of all the steps. And in particular, we're going to get the details of script steps where we may have custom code that could potentially be updated as a way of resolving this error. So this prompt does take a little bit longer to run. We are asking the LLM to do some heavy lifting here in terms of both consuming and parsing all this information that gets thrown at it, but also to generate a potential solution. So again, it has understood that there is a couple of errors here. There is the issue here with pulling down the Docker images. And so it has provided a couple of suggested solutions here. And the first one is to enable the retry feature. So this is really just a tick box in Octopus that allows you to retry a step on error. And for intermittent issues like this, it can be quite an easy way of resolving an issue. It's also suggested that maybe we cache the image locally, so to avoid hitting those Docker rate limits, maybe we should have our own, Docker repo, or maybe we just pull it down and make sure it's available on the worker. And so this is quite a useful suggestion as well. The other thing it's done is actually inspected the script step, which in this case is just a bash script, and offered to edit it for us. And so this may be code that we can copy and paste and actually use this as a way of resolving the issue. And so there's a lot of information here that the LLM has provided for us as a way of stepping forward. And the reason why this is really useful for those DevOps managers who are managing such a large team is that this prompt here that we just ran really represents, that first layer of help desk. So when you are supporting 5,000 engineers, there is a large support burden on you in order to keep those engineers up and running. And so if we can defer even just a fraction of that support load to an extension, then that can add up to quite a significant efficiency gain for those large teams. And so this is what we really mean by improving the efficiency of large teams, especially from the point of view of those DevOps managers who manage and are responsible for a large number of developers. We're really just removing some of those roadblocks, removing some of those points of friction, providing some assistance to potentially overcome simple and trivial errors, And the end result is that over time, the improvements or the efficiency gains that you get by applying these changes over such a large number of engineers really starts to add value. And so if we were to step back and summarize what we've just seen here, what we've seen is that the full CI/CD pipeline can now be completed just through the same chat interface that developers already use to support their development activities. At no point did I ever have to leave my IDE. Everything I did here was simple prompts that I entered into the Copilot chat window, all against the Octopus extension here, which is that at Octopus API app. And so this is really nice. It keeps me in the flow, and it really removes or reduces the cognitive load of having to understand or jump between tools. So at no point did I ever have to open a web browser, for example. I think there's the training aspect here. How quickly can we get people up and running? And the reality is, and we proved this through that interactive that interactive session at GitHub Universe, is that you can get people up and running in minutes. So you can provide people simply with a checklist of half a dozen prompts that they can copy and paste into the Copilot chat extension, and they can get their code out into production, and they can maintain that code in production. And it's very easy and very quick to get those people unblocked and up and running as you introduce Octopus into larger organizations. And I think there's also a degree of confidence that developers will have if they use the Copilot extension, because it really does boil down to just half a dozen prompts that they need to write, and it's very easy to follow these instructions. And as you saw through that confirmations API, any change that potentially does modify an environment has a confirmation where you can approve or dismiss the change. Just as importantly, what didn't we see in this demo? And what we didn't see was the traditional Octopus user interface. So everything I did here, I never had to log into another tool, didn't have to have the browser open, didn't have to learn a new user interface. Everything I did here was just reusing the same tools that I already use as a developer. And so this is really nice for that. The majority of developers who really maybe aren't interested in Octopus if it is implemented in their organization, they just want to get their code out. It's not really important how it gets out there as long as it does. And in order to get those those people who just want to get their code out, there is no additional tooling or no additional user interface that they have to become an expert in. And so, the really nice thing about this is we did validate this through that live GitHub session. It was as much as it was an experience for the attendees to get to use Octopus, it was also a chance for us to experiment and validate this hypothesis that we could actually get a room full of strangers deploying their software in just a couple of minutes. And we were successful, and that was really validating, I think, and that was quite satisfying to see. And as we move forward, it's a really great data point and example for those large teams and the managers of those large teams to say, using this extension, you really can get people up and running. So that was the demo that I wanted to give. So again, my name was Matthew Casperson. I was one of the primary authors of the extension that you see here. So if you do have any questions, feel free to reach out, and I'd love to hear your experience and your thoughts. This extension is available now for everyone to use. It is basically good to go for those users of Octopus Cloud. All the networking is taken care of, and there's nothing you need to do. If you do have an on-prem instance, you can still use this extension. There is some networking that you'll have to do in order to allow a public service to reach into your Octopus instance and just make those network connections. But we have documented the process of enabling those connections and the IP addresses that you'll have to open up. So yeah, this is live today. Everyone can use it. And let me know how it goes, because we're really interested and really excited to be sharing this new Copilot extension with you all. So thank you all. And I look forward to hearing about how you've all used the Copilot extension.
All right. Thank you very much, Matt. That's awesome. I'm a big fan of that extension. I don't know about you, but anything that allows me to stay within the confines of my development tool and be able to integrate in through AI and large language models is a big win in my book. So there you go. We're going to take a short break and we're going to prep our next presentation. So if you're looking for a quick coffee break or something like that, we'll be meeting back here in approximately 3 minutes. So don't go too far, and we'll be right back. All right, we are back. I just wanted to make sure that folks knew that we did a prize draw. There were some questions about this last time. So congratulations, Ashley. You were the winner last time. We're going to go ahead and do another prize draw. So just before I click on the draw again button, make sure to get in the hashtag SHIPPED24 into your comment/question. And that will add you to the list of potential entries there. And coming up next, just to let you folks know, we've got Carrie and Pavel coming on stage to talk about how we use Kubernetes for Octopus Cloud. So both Pavel and Carrie are software engineers at Octopus Deploy, which is awesome. And in this session, you're going to hear a lot about how we at Octopus use and manage Kubernetes clusters within Octopus Cloud to host Octopus servers for our customers. So for those who don't know, if you go to octopus.com today, you can actually sign up for a free trial. We have two ways in which you can actually start that trial. One is you can actually download and install the software on your own infrastructure. The other one is to create a new cloud account. And so the reason why I mention this is because we actually use Kubernetes for that. And so in the next presentation that you'll be hearing from Pavel and Carrie is going to be talking about just that. So they're going to be going through that in the presentation. They're going to be talking a little bit about how they go through, how they got to how we got to where we are, and what is the current state, and also what's next for our Kubernetes environments. All right, jumping back to our giveaway, we're just going to go ahead and do another draw. Drum roll. I don't have a drum roll. I should probably add that next time, but there you go. And our next winner is Colin. Congratulations. You're a winner. Awesome. I'm going to take down your name here and just make sure that we get the, we'll go ahead and reach out to you via email. But congratulations. There we go. All right. Well, without any further ado, I'd like to invite Carrie and Pavel to join the stream. Welcome, folks. How are you?
Hey, John. How are you?
I'm good. Pavel, how's it going? Nice and early for you, too.
Yes, all good. Thank you. How are you?
All right. Very, very good. We're having fun here at part of Shipped. We got lots of folks learning all kinds of cool things. I'm going to go ahead and share your screen. And now I will exit the stage. The floor is yours.
Cool. Thanks, John. Yeah, so we're going to talk today about how we use Kubernetes within Octopus Cloud. So here's a quick agenda. We're going to talk about what Octopus Cloud is, how we've got Octopus Deploy running as a containerized application, some of the external dependencies that we use for Octopus Deploy, and then we'll go into how we manage our Kubernetes clusters, how we deploy Octopus Cloud, and then we'll talk a little bit about how we scale our cloud instances and some of the future plans that we have on our roadmap. So who are we? We're Pavel and Carrie. So Pavel's a principal software engineer. He's been here since 2016, and he's responsible for a lot of the architecture behind the cloud platform that we have here at Octopus. And myself, I've been on the cloud platform team for the last couple of years, helping engineer some of the infrastructure. But we'll start with a quick disclaimer. So today we're going to talk about some specifics of how we use Kubernetes in the Octopus Cloud. This isn't going to be a tutorial for how you should use Kubernetes or a generic recipe for your own applications, but it might be some inspiration for you if you're looking to go on that journey of moving towards using Kubernetes in your infrastructure. So Octopus Deploy, I'm sure you're all familiar with it, but it's a tool for automating deployments of software and making sure that those deployments are repeatable. And so we offer it, as John mentioned earlier, we offer it both as a self-hosted solution and as Octopus Cloud, where we host it on your behalf. So one of the terms that we use here is a cloud instance. So this is referring to a single instance of Octopus Deploy hosted within the Octopus Cloud. And the beauty of having an Octopus Cloud instance is that as a customer, you don't need to worry about the infrastructure that it runs on. You don't need to worry about keeping Octopus Deploy up to date, and you can focus on your deployments. So if you're interested in starting an Octopus Cloud free trial, you can do so at octopus.com. So for the architecture of Octopus Cloud, we have some guiding principles. And Pavel's written a great blog post about this. We'll have a link to that at the end. But we want to avoid any single points of failure within the Octopus Cloud infrastructure. We expect any cloud resources to have spotty availability from time to time as networks fail and things like that. So we don't want to have any one key point of infrastructure preventing people from getting to their instances. So our Octopus Cloud infrastructure is designed to degrade gracefully or to work around any failure that we see. We also try to design for gradual rollout. So we don't want to do any big bang releases because those are an opportunity for things to go horribly wrong and for the entire system to go down. So whenever we're doing significant changes to the infrastructure or rolling out significant upgrades, we'll do those piece by piece, and we'll do a few pieces of infrastructure at a time to make sure that we're happy and confident that that rollout is going smoothly before we continue it to the full platform. We also try to make all of our infrastructure scalable by default. We know that there's always going to be more load, and we know that it's probably going to show up in places that we didn't expect it to. So we try to avoid any designs that would involve a piece that can't be scaled, because that means that we don't have the knobs that we need to be able to add more load in future and to be able to scale up to handle it. We also try to avoid temporal coupling. So we often have other third-party APIs and things that we call out to, and we don't want to have our software blocking, waiting on a response from those third-party APIs. So wherever we can, we'll send those API requests out, but we'll carry on doing other work, and then we'll check in afterwards to see if that request completed. We don't want to have everything go down just because a third-party API became temporarily unreachable. And the other thing is that we try to use officially supported APIs only. So we don't want to be handcrafting our own clients to call APIs. We don't want to be using any special APIs within Octopus Deploy that other customers can't see. We want to be making sure that we're following the same process that anyone else would, because these are well-trodden paths. Other people have been there before. They're well-tested, and we're not doing anything special. So one of the interesting things, of course, is the fact that Octopus Deploy did not start out as a cloud-native application. So Octopus Deploy was originally only available as self-hosted. And so over time, we've had to develop it and add new functionality to support being able to host it in the cloud. And one of the first steps to do that was to get it running in a container. Although it's possible to run Windows containers, we made the decision to go ahead and make sure that Octopus Deploy could run on Linux by porting it to .NET Core. This gave us a bunch of extra capability and meant that we weren't doing anything particularly special. Windows containers are somewhat special. They're not widely supported. And so, yeah, this removed a bunch of problems for us. But that initial migration from .NET Framework to .NET Core and from Windows to Linux was a little bit tricky because there were some assumptions that had already been made in the code, common assumptions, things like assuming that the file system is case insensitive, because on Windows, the case doesn't matter, but on Linux, it does. And we also found that .NET Core was fairly new at the time. So when we started doing this, we found a few platform-specific bugs in .NET Core that didn't exist in the .NET Framework. But once we had it running in .NET Core and running on Linux, we could then create a container out of it. Now, you might think that that's fairly easy. You can just go into the Visual Studio menu and just go add Docker support to your project, and straight away you've got a Docker image that you can run. But there are some other considerations that we needed to think about to make sure that it was a good container image that we could manage. So there's a bunch of different configuration that goes into Octopus Deploy, and part of making it available as a container is ensuring that those configuration settings are able to be defined at the time that you start the container. So this is things like the database connection string, being able to point the container at the database, being able to specify the credentials for the first user account. So we don't want to just have an interactive flow for setting up the first user. We want to make sure that we can spin up a container that already has a first user in there. And we also want to populate things like the license key and some of those application-specific details so that that container can immediately start taking requests as soon as it's running. Now, if you've ever installed the self-hosted version of Octopus, you would be familiar with Octopus Manager. So Octopus Manager is the tool for performing this configuration in a self-hosted environment. One of the cool things about how we've implemented things in Octopus Cloud is that the same APIs that are being used by Octopus Manager, the same command line settings and the same environment variables that are set by Octopus Manager are the same ones that we use in Octopus Cloud. Another part of moving to hosting our software in a container involved some of the other factors that just make life easier. So we we needed to make sure that the application didn't rely on any special permissions. So by default, containers run in a restricted namespace, and they can't perform the same actions that the likes of a Windows application can. So yeah, we needed to make sure that the application wasn't relying on having like admin privileges, those sorts of things. We also had to make sure that the application logged to the console, because a lot of environments, such as Kubernetes, where you deploy containers, they will have separate tools for shipping those logs out and being able to search those logs, and they expect that the logs will be written to standard out from those containers. It's also important to think about any assumptions that you might have about networking behavior. So in the case of Octopus Server, it connects to SQL Server for its database. And in a self-hosted environment, that SQL Server would be running on localhost. So you can't just assume when you move to containers that you can connect to localhost and there'll be a database there. So it's important to think about the fact that in the case of a container, localhost is just your container, and it doesn't contain any of the other services. So you need to make sure that you've got ways that you can point that container at other resources on the network. And the other thing to bear in mind is to try to work with the tooling rather than against it. So often there are sort of patterns that people have implemented when they've moved their .NET Core application to a contained application and those sorts of things. And there are often good reasons why they're doing things the way they are. So it's good to spend the time to understand the reasoning behind those patterns. So in terms of Octopus Deploy, there's a few resources that Octopus Deploy is dependent on that exist outside of that container. The most obvious one, of course, is the SQL Server database. So this is where we store information about the different spaces, the projects, the tenants, and the deployment processes. We also have a dependency on file storage. So if you use the inbuilt package repository to store your releases, they are stored on file storage. We also archive log files there and store some diagnostic data in file storage. We also want to ship those logs from Octopus Server to a logging and monitoring platform so that we can see any errors that pop up and be able to report on how things are performing. And then we've got authentication and authorization providers as well. So within your Octopus Cloud instance, you can configure Octopus Server to log in with Entra ID or Octopus ID or Google, those sorts of things. So those are all dependencies that exist outside of the Octopus Deploy container itself. So we deploy Octopus Cloud in Azure, and so we use a lot of the Azure resources to provide this functionality. So we use Azure SQL DB for our SQL Server databases. We use Azure File Share for the file storage. We use a couple of third-party tools, Sumo Logic and Seek, for logging and observability. And yeah, we've got the various authentication and authorization providers hooked up there. So what do we need to deploy when we're deploying each Octopus Cloud instance? So first and foremost, we spin up a new Kubernetes namespace that is unique to that instance, and that holds all of the components used by that instance. Within that namespace, we create an Octopus container, and that Octopus container also has ingress rules that allow inbound traffic for both the web interface and polling tentacles, which work on a different to the web interface. We also configure volume mounts for the file storage, resource limits for the CPU and memory, and we configure liveness and startup probes. So these are typically just a web request that hits the health check endpoint of Octopus Server, and this allows Kubernetes to periodically check to make sure that that container is in a healthy state. With the startup probe, we have a longer delay on that one, and that's because startup can take a little bit longer if we're applying some database migrations. So if we're in the process of upgrading the version of Octopus Server, then that first startup will be changing the database schema around, and that can take a little bit longer than the normal liveness probes would. So one of the concepts that we have within Octopus Cloud is what we call a reef. And you can think of reefs just as being a logical grouping of cloud instances. Reefs are represented in Azure by a resource group, and that resource group hosts all of the dependencies that are needed by that group of cloud instances. So within that resource group, we have our Kubernetes clusters, we have our SQL servers, and we have our storage accounts. Each reef is hosted in a specific Azure region, and we can't move the reef. So we can create other reefs, but we won't move the reef itself. Within each Azure region, we have multiple reefs, so we can move customers between reefs within that region, or we can even move customers between reefs across region if we need to. So that can happen sometimes if a customer has moved their head office from the US to Europe, they might request that we move their cloud instance closer to them. So this is one way to visualize it. So the blue boxes here are representing the Azure regions. So here we have 3 different Azure regions: West US2, West EU, and East Australia. And then within each of these blue boxes, we have 1 or more reefs. There's usually at least 2 reefs in a region, but there can be more. And then within the reef, we have the SQL servers, the storage accounts, and the Kubernetes services. So networking, how do we communicate between the different resources that we have in Azure? So we've set up a number of private virtual networks in each reef, and only the resources that need to communicate with each other have virtual endpoints within that virtual network. So cloud instances within a reef can talk to SQL servers and storage accounts within that reef, but they don't have any network access to resources in other reefs. And then Cloud Portal, which is what we call our management plane, it has access to all of the resources because it has endpoints on each of those private networks. When we're deploying our Kubernetes clusters, we use the Azure Kubernetes Service, AKS, to deploy and manage the clusters and the nodes. This is because we don't really want to be looking after individual virtual machines and their health. So we'd much rather use a managed service to provide that for us. We currently deploy those clusters in 3 different regions, the US, Australia, and Europe. And then each reef will contain multiple Kubernetes clusters. This allows us to move customers around within the reef and also makes it easier for us to perform upgrades of those clusters. We also make sure that customers' data is kept within their chosen region. So when you go through and set up your instance, you get to choose a region. And we stick with that for 2 reasons. The first is to ensure that we keep latency to a low limit, and also to ensure that we meet any data sovereignty requirements with things like GDPR and those sorts of things. So in terms of cluster security, what are the things we do to improve the security of the clusters? Well, one of the things is to ensure that the cloud instance runs in its own namespace. So we want to reduce the risk of someone breaking out of their own cloud instance and trying to attack other instances. Because they're in their own namespace, if they break out of their own cloud instance, they'll find that there's nothing else there that they have access to. We also ensure that the cluster management APIs are only accessible from private VNets. So by default, when you spin up an AKS instance, those management APIs will be accessible on the public network, the public internet, so that you can access them from wherever in the world you are. But we only ever need to manage those clusters from tools like Cloud Portal, and so all of those tools exist within our Azure private networks. Within Azure, we've configured role-based access control, so we know what each account needs to be able to do, and each account is limited to only those things that it needs to do. We don't have any sort of global super admin accounts. We just want to have accounts that are scoped to exactly what they need. And where possible, the authentication between Azure resources is performed using Azure managed identities. So these are user accounts that Azure manage and create. And every Azure resource can have a managed identity. And so in cases like this, we can configure it so that Cloud Portal, for instance, has its own account that it will use for interacting with the Azure APIs. And so we can define ahead of time with role-based access control the different APIs that Cloud Portal needs to be able to call, and it can't call any other APIs because it doesn't have permission to do that. So Kubernetes upgrades, how do we go about rolling out new versions of Kubernetes? So each Kubernetes cluster that we have, we consider it to be ephemeral. We can blow it away at any time and create a new one, and we won't have lost any customer data in doing that. We use what's known as a blue-green deployment process to upgrade those core Kubernetes components. And this involves us creating brand new empty Kubernetes clusters. We then deploy our dependencies and ensure that test workloads are running well on that new cluster. And then once we're confident that the new cluster is performing correctly, we then start moving customer instances across one by one when they reach their maintenance window. And in doing things this way, taking a slow approach to upgrading between clusters, we've got a few compatibility issues. So one of the recent ones that we found was a change in file locking behavior in AKS for our Azure file shares. So it was important that we caught that one so that we could make some changes to the product to work correctly with the new file locking behavior. So how does that look in practice? So here we have an existing cluster running Kubernetes 1.29, and it has 3 different instances on it. So these are 3 different pods, basically. Now we want to upgrade that Kubernetes cluster to 1.30. So the first thing we'll do is we'll create a brand new cluster. So we've got our blue cluster, and we now have our green cluster. You'll note that there's nothing running on that 1.30 cluster yet. That's because we've just spun it up, and we're going to go through and test it and make sure it behaves correctly. And then we're going to move our first instance across, and this is probably going to be one of our test instances. So we'll spin that instance up, we'll use the web interface and use testing to interact with that and make sure that it's behaving itself and that everything is performing correctly. And then we can start migrating other instances across one by one when they reach their maintenance window. So an hour or 2 later, instance 2 hits its maintenance window, and so we can shut down the pod on the 1.29 cluster and spin up a new pod for that instance on the 1.30 cluster. And then eventually, after about 24 hours, we'll probably have all of the instances moved across to that new cluster, and that old cluster, the 1.29 cluster, doesn't have anything running on it anymore. And so at that point, we can blow it away, and we're left with our new cluster running the new version of Kubernetes. So this is a nice approach for us because it means that at any point in the process, we can stop what we're doing, we can roll back, we can easily have different clusters in different versions where we need to when we're doing bigger upgrades. So it gives us a lot of flexibility with those things. So alternative paths. Why don't we just have one big Kubernetes cluster, a global cluster? So this is all in line with our principles, right? We want to be able to easily scale our infrastructure. We want to be able to do gradual rollouts of those infrastructure changes. We want to be able to reduce the blast radius of any incident. So in the case that something goes wrong with that first instance that we've moved across to that new cluster, we only want that instance to be impacted. We don't want all the other instances impacted at the same time. The other catch with having a large Kubernetes cluster is that it would be dependent on core Azure services in a specific region. Because each cluster can only exist in a specific region, it would be dependent on services in that region, and therefore there'd sort of be a single point of failure there. That entire region would have to be online all the time for the cluster to be reachable all the time. And this approach that we have with multiple reefs and multiple clusters also makes it really easier for us to spin up development and test environments because they can be deployed in the same way as our production environment. So there's nothing special about our production environment. It's not like it's a special production cluster. It's a cluster just like any other development or testing cluster. It's just a bit more locked down because it's production. So we've recently adopted a new feature of Octopus Deploy called the Octopus Kubernetes Agent. And this is a way that we can directly connect our clusters to Octopus Deploy. So this works really great for us because it means that the cluster itself is connecting to Octopus Deploy rather than Octopus Deploy reaching into the cluster. And so this means that we can tighten the security around our clusters, and our dynamic workers don't need to have permission to access the Kubernetes clusters because the clusters will reach out to Octopus Deploy itself. It also means that a bunch of the different deployment steps that we have within our deployment process can now be run directly as script pods on the cluster. So this avoids the need for us to use dynamic workers in a lot of cases. And so that's just another thing that speeds up the development process, the deployment process, and means that we can reuse some of that existing infrastructure for performing tasks. It also means that a lot of those things perform quicker for us because they're running directly on the cluster that they're making changes to. So pretty much every request is happening on that same node. So I'm sure you're unsurprised to find that we use Octopus Deploy to deploy Octopus Deploy. So we try to drink our own champagne. So we have Octopus Cloud instances that we spin up called hubs, and each hub manages the instances within an Octopus Cloud reef. We coordinate those hubs using our internal tool known as Cloud Portal. And so Cloud Portal will start deployment on those hubs when a customer's instance is due for an upgrade and within their maintenance window. And those hubs will go through the process of shutting down the customer's instance, ensuring that all the required components are upgraded, and then it will push out a brand new deployment to the appropriate Kubernetes cluster and wait for that deployment to come online. So Cloud Portal, we've mentioned it a few times. What is Cloud Portal? How do we manage all the infrastructure that we've got? So Cloud Portal is a custom .NET web application that we've written that ties everything together. So it runs various tasks, and each task implements what's known as the saga pattern. So this is a way for us to have long-running tasks, and each time the task performs an action, it will store its current state in the database. This means that at any time we can redeploy Cloud Portal, and it will pick up exactly where it left off from by reading the existing running tasks out of the database and resuming with the next step in that task. So Cloud Portal is responsible for lots of things within Octopus Cloud. It creates the cloud infrastructure. So when we want to create brand new reefs or we want to spin up brand new cloud instances, Cloud Portal will do that. It's also responsible for scaling and upgrading cloud instances. So it will monitor a cloud instance and see that it needs more resource, and therefore put in a request that it gets scaled up during its next maintenance window. Or that a cloud instance is running an older version of Octopus Deploy, so there will be a task set up to upgrade that cloud instance in its next maintenance window. We also use Cloud Portal for coordinating the Kubernetes cluster upgrades itself. So we can schedule those within Cloud Portal, and it will go through the steps of that we talked about earlier, the blue-green deployment. It will spin up the new cluster and slowly start moving instances across at the appropriate times. All of the tasks that happen for cloud instances happen within the maintenance window. So Cloud Portal is responsible for managing those maintenance windows and ensuring that we get as much stuff done within a maintenance window as we can. It also collects and collates some performance and availability metrics across the platform. So a lot of the resources that we use can report metrics directly into Sumo Logic, which is our metric tool that we use. But there are some other metrics that only Cloud Portal has access to, particularly things around maintenance windows, because those are a Cloud Portal specific concept. And Cloud Portal can also alert a member of the Cloud Platform team when there's something that comes up that needs our attention. And so this is a quick little screenshot of what Cloud Portal looks like in our staging environment. So this is the dashboard showing us a bunch of different metrics within the platform and showing each of the cloud instances and how they are performing in regards to that metric. So maintenance windows, I've mentioned those a few times. What are the different things that happen within a maintenance window within Octopus Cloud? So any number of these tasks can be performed, including 0. So not every maintenance window is used. We don't necessarily need to take your instance down every day, but when we need to, we will use that maintenance window to upgrade your instance to the latest release of Octopus Cloud. We also use it to make changes to the memory and CPU limits of the cloud instance. And this is because we need to restart the cloud instance for those changes to take effect. We also go through and do maintenance tasks like rebuilding database indexes and compacting the database. One of the other things that we can have is we can have cloud instances that have been quite quiet, and now that customer is doing a larger deployment and all of a sudden they need more resources. So we can move cloud instances between reefs to ensure that all of the cloud instances have all the resources that they need. And of course, we use the maintenance window for performing infrastructure upgrades. So even though the cloud instance itself might not change, we might need to change the platform underlying the cloud instance. Things like Kubernetes upgrades require us to shut down those cloud instances and spin them up on the new cluster. So scaling our cloud instances, how do we manage scaling within Octopus Cloud? So for external resources, these can be scaled independently. So things like the Azure SQL Server database, we can go into Azure and ask them to increase the number of DTUs available for that customer database if it's starting to get busy. And we can also perform vertical scaling of our cloud instances. So we can increase or decrease the CPU and memory requests and limits for that instance. We can move customer instances to other clusters when the cluster that it's on is nearly full. And we can create brand new clusters with larger VMs for each node if all of the existing clusters are full. One thing we can't do yet is that we can't yet horizontally scale a customer's instance. But that's something that we're working on. So what does that look like? So in the case of vertical scaling, we're just taking the existing pod and making that pod bigger, giving it more resources. So in this case, we've got a pod that's running 1 GB of RAM and 1 CPU, and we can vertically scale it up to have 1.5 gigs of RAM and 2 CPUs. In the case of horizontal scaling, which is what we want to be able to do, we end up just spinning up more pods. So those pods aren't any bigger, we just have more pods, and any of those pods can perform the operations within that cloud instance. So this is where we come onto our future plans. How would we like to be deploying Octopus Cloud in the future? So one of the things that the team are working on is trying to support multiple pods per instance so that we can do horizontal scaling. This would also provide some redundancy so that individual pods can be stopped and replaced. And this would mean that when we're doing things like Kubernetes upgrades, customers wouldn't notice any outage because it would only be individual pods within their instance that would be being moved at a time. So as I mentioned, that this is not yet supported. The work's ongoing. There's a lot of work that needs to happen behind the scenes to make sure that we don't end up doing things like running multiple deployments at multiple times from different pods. So we need to make sure that all of the pods for that instance have the same view of the world, and only one of them takes the action of starting a deployment. We want to make sure that those deployments recover safely when that pod is replaced. So if one pod goes down because we're moving it to another cluster, we don't want Octopus Server to forget about the deployment that it just started. And we also want to make sure that any users of that cloud instance see the same view of the world. So we wouldn't want a scenario where one customer is talking with one pod and they see that version 1 has been deployed of their application, but another customer that's hitting the second pod of their instance sees that there's a different version deployed. So there's a lot of work to make sure that Each of those pods has the same consistent view of the world, and that only one action is happening at a time for things like deployments where we can't safely run a deployment multiple times. And if you're interested in any of these things, you can follow the progress on our roadmap at roadmap.octopus.com. So useful links. So here are a bunch of the things that we talked about today, if you want to go and read more about them. So early on, we had Pavel's overview of the architecture of Octopus Cloud, and we're going through some of the guiding principles for that. Pavel has a blog post where he goes into a lot more detail about the reasoning behind those principles and how we implement them. We also mentioned the Octopus Kubernetes agent. So this is a reasonably new piece of Octopus that we're using to run part of the deployment process directly on the Kubernetes cluster. There's also links here for what's a blue-green deployment if you want to find out more, and the saga pattern that we use for tasks within Cloud Portal. And last but not least, our cloud platform team is currently looking for a senior software engineer. So if any of this appeals to you and you're a senior engineer and you'd like to come and work for us, you can check out that job posting at octopus.com/company/careers and have a read up and put your application in. So thanks, everyone. I hope that was helpful. Do we have any questions there, Pavel?
Thanks a lot, guys. I quickly created a little banner there to promote the careers page. So there you go. Hopefully someone will click on that. Awesome stuff. Just checking the comments here, see if there are any questions. These are some of the folks who are actually building Octopus Cloud. So if you're all curious about how they're utilizing Kubernetes for maintaining and building this out, this is a great resource for you to check out. All right. We don't have any questions. You guys explained it so well. Look at that. Awesome. Pavel, you had so much to say as well. There you go. Awesome. Well, I really appreciate you guys taking the time to come and present. Really, I know it's hard because it's early for both of you, as it is for me, but I know that folks probably got a lot out of that. So thanks again. Really appreciate it. I'll go ahead and let you guys go, and we'll move on. Thanks a lot. Take care, guys.
Cool. Thanks, John.
All right, moving right along. Just to, continue on with the drawing. So we've gone ahead and drew a winner last time. So make sure to get your hashtags in there into your comments there. And we'll go ahead and do another draw now. So hopefully we don't hit. This is going to be the meme of the day, I guess. Hopefully don't hit Octopus Deploy because I actually put it in there. So there you go. Victor, awesome. All right, Victor. I'm going to go ahead and quickly write down your name here, and then we will move on. That animation is so nice. I wonder if it uses CSS, utilizing the GPU there. Anyways, awesome stuff. Well, without any further ado, what I'd like to do is now invite Felix onto the stage. I'm going to go ahead and bring him into the studio. And hello, Felix. Can you hear me?
Hi, John.
Hey, how's it going? So Felix is going to be delivering a session for us. I'll just bring up the schedule here. So Felix is going to be doing a session here entitled "From Chaos to Clicks: Streamlining Deployments with Octopus Deploy." And actually, Felix is part of the great team over at Cyan IT. They're a Octopus partner, which is awesome. You can find out more by going to cyan-it.de. So Felix has joined us here and is going to share us a little bit more information about From Chaos to Clicks. So Felix, are you ready to go?
Absolutely.
Awesome stuff. Well, over to you. Thank you.
Perfect. So hello, everyone, and welcome to my talk, From Chaos to Clicks, Streamlining Deployments with Octopus Deploy. My name is Felix Notka, and I split my time equally as a DevOps engineer and a software developer at Cyan IT in southern Germany. And although you can ask questions at any time, I will dedicate the last couple of minutes to answering your questions, but you can, of course, contact me afterwards at felix.notka@cyan-it.de. And for those of you who are curious, I'd like to introduce you to my dog, Fred. He's a Labrador, he's 3, and he prefers not to be contacted. So let me tell you a bit more about the company I work for. Founded in 2011, we are a dedicated team of 26 employees committed to delivering innovative IT solutions. We specialize in developing custom software for our clients, handling every aspect from initial consulting to ongoing maintenance. And we've been using Octopus Deploy since 2012, which basically makes us early adopters. And as John said, of 2024, just a couple of weeks ago, we are proud to officially call ourselves Octopus Deploy partners. We have introduced Octopus Deploy to all our customers, offering a comprehensive range of services like trainings and workshops, consultation, installation, management, and maintenance. So basically the whole package, but you can find that on the website as well. This has given us plenty of experience and opportunities to learn from, allowing me to confidently share with you today what we have learned along the way. Over the next half hour, we will explore how we transition from a chaotic manual process back in 2012 to a streamlined automated workflow. We will delve into the challenges that we faced, the solutions we've implemented, and how this transformation has empowered everyone in our company, no matter their technical background, to deploy with ease. By the end of our time together, you will be equipped with the knowledge to transform chaotic manual deployments into efficient automated workflows, making deployments accessible to all members of your organization. So, where does it begin? Let me take you back to the year 2012. I was 15 at the time and obviously not involved in the industry, but luckily my colleagues have been more than happy to fill me in and describe to me what a general manual deployment process looked like for most of the industry back then, which, to put it mildly, was chaotic. Deployments were an all-hands-on-deck affair. From 11 p.m. to 6 a.m., everyone was involved. Application developers, operations specialists, database admins, firewall experts, and even the managers. They operated off a multi-page execution plan meticulously laid out in Excel. And this plan included exact timestamps, step descriptions, responsible departments, and contact info for each team member, complete with phone numbers and email addresses. There was also a detailed fallback plan outlining specific time windows for error correction in case things didn't go as planned. And as an operations specialist, for example, you might do something at the very beginning and then wait around for hours before being needed again. The atmosphere was very tense, since any misstep could set the deployment back by hours or even days. Deployments could easily take up to 5 hours, stretching into the early morning and leaving everyone exhausted. And these deployments, they weren't frequent. They happened only once every few months. And this infrequency added to the stress because the procedures just weren't routine. Each time felt like starting from scratch, with team members having to relearn the complex steps involved. And this also meant that updates and improvements to applications were delayed, making it hard to respond quickly to client needs or market changes. Also, scheduling was another nightmare. Coordinating a change advisory board meeting required at least 2 weeks' notice to set a new date. And any delays or need for rescheduling meant pushing back critical update. This bureaucratic layer added friction to an already cumbersome process, making agility almost impossible. The manual deployments also left a lot of room for human error, since every step had to be executed precisely as outlined, and any deviation could cause significant issues. There was no guarantee that what worked in test environment would also work the same way in production. This inconsistency made it difficult to predict outcomes and eroded confidence in the deployment process. Knowledge was gatekept too. Critical information about the deployment process resided in the minds of a few key individuals, but kept away from everyone else. If someone was unavailable due to illness or other commitments, the entire deployment could be jeopardized. There was no centralized system or documentation that could be easily accessed by anyone who needed it, creating risky dependencies. And the impact on morale was palpable. The stress of these deployments weighed heavily on everyone involved. Developers felt disconnected from the process, operation teams were overburdened, and managers were anxious about potential downtime or client satisfaction. And all of that was quite a challenge to put up with back in the day. But what's even worse is that despite the advancements in automation tools and best practices, many organizations still continue to rely on manual deployments. According to the latest State of DevOps report from 2024, companies fall into different categories based on their DevOps maturity and deployment practices. Elite performers, here in blue, About 19% of the respondents deploy on demand multiple times a day with less than a 5% failure rate and recovery times under an hour. In most cases and most projects, we fall into that category. However, lead time may sometimes be an issue. High performance, the green ones, about 22%, deploy between once per day and once per week with a 20% failure rate and recovery times under a day. Medium performers, biggest ones, 35%, deploy between once per week and once per month with a 10% failure rate and recovery times under a day. Low performers, 25%, deploy as infrequently as once per month to every 6 months with a 40% failure rate and recovery times stretching between a week to a month. And what's particularly alarming is that low performers, who make up a quarter of all respondents, are likely to depend heavily still on manual processes. These organizations seem to deploy changes infrequently and face significant risks and downtime, reflecting the ongoing reliance on outdated methods. Often this reluctance to adopt automation stems from the perceived complexity of overhauling legacy systems, even though modern tools could drastically improve their deployment frequency and reliability. So now that we've covered the general deployment process, let me illustrate how we handle deployments here at that time at Science IT. Our deployment and development processes were a blend of manual steps and partial automations. We utilized Team City for continuous integration, which helped to automate some of the aspects of the build process. Our code was stored in an SVN repository, serving as our version control system. And when it came to database migrations, the process was a bit less streamlined. We relied heavily on manual crafted SQL scripts for database changes, and unfortunately, these migrations were not automated. This manual approach often led to inconsistencies across different environments and made tracking changes much more challenging. As developers, once we completed our coding task, we would then build the application locally and create a zip file of the compiled code. And this file was then uploaded to an FTP server and passed along to the operations team, along with a list of semi-clear instructions on what they needed to do. Fully aware that the operations team knew next to nothing about the application code changes being deployed. And for us, that was basically the end of the deployment process. We had minimal involvement beyond that point and would just often wait for feedback. If any issues arose, like an error that wasn't properly logged, we might not hear about it until much later, making troubleshooting so much more difficult. Understanding the infrastructure was also a challenge. Since our role focused solely on development, we didn't have clear visibility into the infrastructure or hardware landscape. There was no scripting automation using custom tools because implementing such scripts would have required developers to have access to servers, passwords, or other sensitive information. And if we wanted to go an alternate route, we would have needed to run complex commands with an overwhelming number of parameters, which just wasn't very practical. And as I said, another significant hurdle was that database migrations were not part of our code base and were not reviewed alongside our application code. This separation meant that changes to the database weren't synchronized, which led to potential conflicts and errors during runtime. So how did we recognize the need for change? Well, basically everything began when my colleague Philip joined the operation. Philip wore multiple hats. He was involved in both software development and operations. This meant that he was on the receiving end of the zip files that the developers handed off, and he was fully aware of the challenges that came with this manual process. Coming from a larger company that had partially automated its deployments using tools like Capusano, Philip quickly realized the inefficiencies and risks inherent in our approach at that time. He promptly set out to find a better solution aiming to tackle several critical issues we were facing. We wanted to deploy to multiple servers automatically, since manually it not only took time, but also led to discrepancies between environments. We needed a solution to automate this process and ensure consistency across all instances. We wanted to include database migrations directly within our code repository, and by doing so, they would be version controlled and reviewed alongside the application code, ensuring that CIMA updates were synchronized with application deployments and just reducing the risk of runtime errors. We also wanted a centralized dashboard because we were essentially blind to the state of our deployments. Knowing what was deployed, where, and its current status was a constant struggle. A unified view of our deployment landscape was critical for improving transparency and fostering collaboration. This also meant that any error that came up during the deployment was now visible for application developers, which would just make debugging so much easier. Managing sensitive information like database passwords was a significant concern. We needed a secure place to store and handle these credentials to prevent hard coding them into scripts or exposing them during the deployment process. So, quite fortunately, the first tool Philip explored was Octopus Deploy, and it quickly became clear that it was the perfect fit for our team. We chose Octopus Deploy for several compelling reasons, which I'd like to share with you. First, it offered predefined deployment steps. Features like the IIS deployment step allowed us to simplify complex tasks without writing custom scripts from scratch. This meant we could get up and running quickly, reducing our setup time. Second, the variable management and substitution capabilities were a game changer. We were able to eliminate hard-coded values in our code by externalizing configurations. This meant our applications were more flexible and much easier to maintain, as we could easily manage environment-specific settings. Third, Octopus provided a direct overview of our environments through an intuitive dashboard. We gained immediate insights into what was deployed and where, which improved our planning and reduced deployment conflicts. This visibility was something that we just hadn't experienced before. Additionally, the tool's ability to expand functionality with custom steps meant that we could tailor it to fit our unique requirements. As our needs evolved, Octopus scaled with us, accommodating more complex deployment scenarios without a hitch. The role-based access control was another significant advantage. We could assign specific permissions to team members, ensuring that only authorized personnel could perform certain actions. This enhanced security and also allowed us to involve non-technical staff in the deployment process safely. I'll show you later some examples of that. Moreover, having a clearly defined deployment process with detailed logs brought transparency to our workflow. It made it easier for everyone to understand the deployment pipeline, and the detailed logs were invaluable when addressing errors, reducing downtime and frustration. Lastly, the secure management of sensitive data was crucial for us. Octopus Deploy's secure variable management ensured that sensitive information, like database passwords, was handled safely. By avoiding hard-coded credentials, we adhered to best practices. In summary, Octopus Deploy checked all the boxes for what we were seeking in a deployment solution. It addressed our critical needs for automation, consistency, security, and transparency. The combination of predefined steps, the variable management, and the handling of secure sensitive data made it an indispensable tool that transformed our deployment process, and it still is. Implementing Octopus Deploy then marked the beginning of a significant transformation in how we approach deployments. And as I told you before, it was literally the first tool we tried, and we've been happy with our choice ever since. So let me walk you through a bit about the process that we encountered while migrating to Octopus. Initially, we started small. Our first step was to set up Octopus Deploy to handle the deployment of one of our less critical applications. This allowed us to experiment and understand how Octopus worked without risking major disruptions. At the beginning, deployments involved manually uploading files through Octopus Deploy. This was a significant improvement on our previous step, but it still required some manual effort. We configured Octopus to deploy an application to a test environment. Leveraging the built-in steps for deploying to IIS and handle variable substitution, we also built a demo process to showcase how Octopus Deploy could streamline our workflow. As we grew more comfortable with Octopus, we began to expand its use to other applications and environments. Over time, we automated more steps, handled additional scenarios, making our deployments much more robust and reducing the potential for human error. We created standardized deployment processes that could be reused across different applications. And these projects included steps for building the application, using our continuous integration server to build them, and then package them into NuGet packages and pushing them to Octopus. Also including Fluent Migrator, to ensure database schema changes were version controlled and deployed in sync with our application code. Automating deployments to various environments such as development, testing, staging, and production. By integrating our deployment process directly within our code repository and build server, we achieved some sort of a seamless workflow. Whenever code was checked into the repository, our pipeline would automatically build the application, run unit tests, package it, and push it to Octopus Deploy. Octopus would then handle the deployment to the appropriate environment based on the branch or tag in the repository. Again, I'll show you that later. And with the use of project scope lifecycles and release channels, we could fully control the deployment process. For instance, an artifact from a feature branch could only be deployed to a test environment. A commit to the development branch would automatically deploy to the test environment, while only commits in our release or main branch were allowed to progress through staging into production. We had many hard-coded fallbacks in our code, which made maintenance very difficult. By using Octopus Deploy's variable management, we externalized these configurations, making our applications more flexible and easier to manage. Managing different configurations for each environment became much simpler and less error-prone. We no longer had to manually change configuration files, reducing mistakes such as deploying with incorrect settings. Integrating database migrations was another significant improvement. This synchronization reduced runtime errors and improved the reliability of our deployments. Automated deployments ensured that the same process was followed every time, eliminating inconsistencies that could arise from manual interventions. This significantly reduced errors and made our deployment much more reliability. Now for the sort of advanced stuff. From the developer's perspective, this transformation was eye-opening. We became more involved in the deployment process. Instead of just handing off zip files or writing deployment instructions for the operations team, we now had better visibility and could contribute to improving the deployment pipeline. One of the most transformative aspects of our journey was empowering non-technical personnel to manage deployments. With Octopus Deploy's user interface and automation of complex steps, team members without a deep technical background could initiate and monitor deployments. For example, our customers' quality assurance teams often need to test new features before they merge into the development branch. Before implementing Octopus Deploy, testers would have waited for developers to manually deploy feature branches to their test service, something that almost, I think, no one would do. But after integrating Octopus Deploy and providing a brief 15-minute training session, these QA teams could deploy feature branches to their dedicated test service themselves. This autonomy allowed them to test new features more promptly, providing a valuable feedback earlier in the development cycle. And as a result, we experienced fewer issues after the deployments since everything was thoroughly tested before merging. The transparency and visibility offered by Octopus improved collaboration between development and operations. We could easily communicate about deployment statuses and address issues promptly. The centralized dashboard allowed us to monitor deployments in real time, seeing which versions were deployed to which environments, helping us plan our work more effectively. We also leveraged Octopus Deploy scripting capabilities to handle custom deployment steps when needed. For example, we could run PowerShell scripts to perform specific tasks before or after deployment steps, such as clearing caches or performing custom application-specific health checks. We recognized that certain maintenance and operational tasks were repetitive and time-consuming. To tackle this, we implemented runbooks within Octopus Deploy. By automating tasks like server maintenance or restoring test databases, we significantly reduced the manual effort required. And this automation also enabled team members, even those without deep technical expertise, to perform these tasks effortlessly, ensuring consistency and freeing valuable time. To further enhance our deployment efficiency, we developed custom step templates tailored to our most common deployment scenarios. These templates streamlined the setup of new projects by providing reusable components that ensured consistency across different deployments. By using custom step templates, we minimized configuration errors and accelerated the deployment process, allowing us to maintain high standards of quality while deploying new projects swiftly and reliably. Effective communication with our stakeholders, including customers and partners, was another critical area of focus. We automated the email notifications to Octopus to keep stakeholders informed about the status of deployments. These notifications provided timely updates on deployment, progress, successes, and any issues that arose, ensuring transparency throughout the project. By proactively communicating deployment statuses, we improved customer relations, built trust, and enhanced overall satisfaction by keeping all stakeholders informed and engaged. The proactive communication approach ensured, Now, after I told you about the transformation we took and how that went down, we kind of developed some best practices and some pitfalls that would be best to avoid. The first pitfall, different ideas of success. The problem was when we decided to transition from our existing deployment tools like Capistrano to Octopus Deploy, we encountered a significant challenge. Various teams had different ideas about the ideal deployment process. This lack of a unified goal led to confusion and inefficiency, making it difficult to migrate our existing scripts and processes without a clear objective. The solution is actually quite easy: align the team on deployment goals. We focused on aligning the team, and we facilitated discussions to unify expectations and objectives, mapping out our current process and collectively identifying pain points. By defining what success looked like with a new deployment system, we ensured that everyone was on the same page. This shared understanding guided our implementation, helping us avoid unnecessary complications and ensuring a smoother transition. An example of what we did wrong before we had to find that out the hard way comes in our next pitfall, the all-or-nothing approach. In our eagerness to leverage Octopus Deploy, we initially tried to replicate our entire existing process within it, without making significant changes. This all-or-nothing approach meant deploying whole gigantic applications even when only small parts had changed, leading to inefficiencies and not providing the expected gains in deployment speed and reliability. The solution here is to break down the deployments into reusable components. By breaking them down into smaller components, we could deploy only what had changed, significantly improving efficiency, and utilizing Octopus Deploy's features like lifecycles and variable sets allowed us to manage different deployment scenarios effectively. Additionally, creating custom step templates for similar projects ensured consistency and reduced configuration errors, enabling us to deploy more flexibly and reliably. Now to pitfall number 3, customization overload. As our deployment needs evolved, we began developing custom deployment scripts within Octopus Deploy to address unique requirements not covered by the built-in steps and templates at that time. While customization was necessary, it led to added complexity in our deployment process, making it harder to maintain and increasing the learning curve for new team members. The solution is here to find some sort of middle ground. Customize when necessary, but keep it simple. We adopted a balanced approach to customization. We leveraged Octopus's built-in features and extended them only when necessary, avoiding overcomplicating the deployment process. This strategy ensured that our deployment workflows remained maintainable and straightforward. By keeping customization simple and purposeful, we reduced complexity and made it easier for new team members to understand and contribute to the deployment process. The next one, expectation management. With a vast array of features and possibility within Octopus Deploy, it was easy to get sidetracked by trying to implement everything at once. This happened to me the first time I implemented an Octopus project as well. It's just way too powerful and too capable, so it's quite easy to get sidetracked. So additionally, managing deployments across multiple tenants, each with their own specific needs, added to the complexity. This led to changes in setting realistic goals and prioritizing features, causing frustration among team members and stakeholders. The solution here is also quite simple, but hard to keep sometimes. Set realistic goals and add functionality over time. We focused on setting realistic goals and prioritizing features that delivered the most value in the short term. by communicating openly with our team and stakeholders about what could be achieved immediately versus what would be implemented later, we managed expectations effectively. Utilizing Octopus Deploy's multi-tenant deployment capabilities allowed us to handle different client requirements effectively without overwhelming the system. And this phased approach ensured steady progress and maintained team morale. The last pitfall is constant change chaos. One of our primary goals was to establish a deployment process that didn't require frequent adjustments. However, we found ourselves making constant changes to the deployment pipeline, which introduced instability and confusion among team members. This constant change chaos disrupted workflows and made it difficult to maintain a stable and reliable deployment process. The solution here is to design for long-term stability. To achieve said long-term stability, we designed our deployment process with consistency in mind. We avoided making unnecessary changes that could disrupt workflows and focused on iterating and improving only when essential. Thorough documentation of what had changed ensured that everyone understood the deployment pipeline, and we kept the team informed about any updates. By prioritizing stability over frequent adjustment, we created a reliable and predictable deployment environment that supported our ongoing operations effectively. That being said, I'd now like to share a practical demonstration that my colleague Anita and I prepared, since I cannot show actual customer data. But this example is taken out of a real project that we have, and we thought we'd share something with you in hopes that you also find it as cool as we do. So we got an application that's called the demo observability. It's actually quite easy to explain, but not really necessary here. You click a button and then you can provoke an error that comes up and that we can log. It has different environments. This is the production environment. This one right here is the staging environment, and this is the test environment. So far, so good. And we keep track of issues via GitHub. So let's say I have a ticket here that says update UI to show in SHIPPED24. I've pre-built this so that we wouldn't have to wait. And it went through all the different channels. It here went to the development channel because it's a feature branch. And we can actually just deploy it really quick here. So now what we can see is if we said OBS minus feature 8, oops, is it an 8? Yes, it is an 8. Testing stuff site. There's nothing here. If we, however, wait until this deployment finishes, I can spoil it to you in the process already. We actually go into DigitalOcean where the domain is hosted, and we create a custom DNS entry along with custom namespaces, just so that you can test crucial or updates before you ever review them, or after you review them, to ensure that the expected feature works. Now let's see where the deployment process is. Okay, seems to take another few seconds, but we should be good to go. Come on. Okay. Let's just wait for another few seconds before this is ready. But hopefully should be now. Okay. Okay, if that doesn't want to work, I can show you just another feature, and we'll get to that soon. I did that one just before to test. This DNS entry didn't exist before. It was all created by our script. and should hopefully be a bit faster. Hey, come on. But yeah, here you can see our channels that we have along with the custom lifecycles. The development channel only can deploy to development through the lifecycle. Our main channel needs to go through test staging to production. Release channel, I did not create a release package yet. And the test channel is for any update that's been done to the development branch, so that we always have a semi-stable development version deployed on our test system. And I really want to show that now, but somehow it takes a bit longer now than it did before, which is a shame because we have tried it many times today and it never took that long. That's just a warning in the Ingress controller Nginx. But yeah, then I need to show it on this example, which is clearly a shame. Okay, sorry. But to go back to the talk. To conclude, Octopus Deploy has truly transformed the way we operate at ScienIT. We've achieved a consistent and reliable deployments with automated processes that significantly reduce errors and discrepancies. By integrating database migrations, we've synchronized our applications and database changes, minimizing runtime issues and enhancing overall stability. As we come to the end of our journey from chaos to clicks, I hope you've gained valuable insights into transforming your deployment processes can revolutionize the way your organization operates. Our experience at ScienIT illustrates not just a change in tools, but a cultural deployment shift that empowered our entire team. Sorry. Correct. I'd like to thank my colleagues for supporting me and for all the wonderful people working at Octopus Deploy, allowing me to share our story here. And as I said, I have a couple of minutes planned for questions if you have any.
That was awesome. Thank you so much, Felix. My batteries gave out on my AirPods. I've been listening so much. There was so much information coming in there, so that was a great story. And well done. You know, for a non-English speaker, kudos. I couldn't imagine delivering a technical presentation in German. If any of you have a question for Felix regarding his experience and his company's experience with Octopus Deploy, please feel free to pose them to the comments pane. Don't forget to use the hashtag SHIPPED24 in order to enter a chance to win. Just going through the comments here, I didn't see any questions. I saw a lot of references, links, and such. So not seeing anything there. I think he kind of covered everything there, Felix. So well done.
I mean, it was a transformative process that started 12 years ago. So I think we've tried a lot in Octopus Deploy, and
yes.
It's a shame that the last process didn't work because we've tested it a lot today and we worked with the other feature branches.
It's always the case.
The
demo gods, the demo gods aren't playing nicely with you, so that's okay. We're not going to go hold it against you.
Big thank you to my colleague Anita. She really helped me out the past few days a lot with getting the demo instance ready to showcase something.
That's awesome. All right, well, Felix, we'll let you go. Thank you so much for your presentation. We really appreciate it.
Thank you for having me.
All right, thanks, Felix. That was awesome. Like I said, my AirPods gave out. There's too much audio coming through, so there you go. That was awesome. Just going back to our giveaway here. Let's go ahead and share the screen. So Victor was our last winner. Let's go ahead and draw another winner here. Looks like Octopus Deploy is still listed in there and CodeFresh. That's not good. All right, who's our next winner? Oh no! All right, we're gonna have to draw again. This is becoming the joke for this webinar, folks. That's fine. We'll just keep redrawing. The reason why it's coming up, for those who don't know, is because I posted a comment as Octopus Deploy to the chat. So that's why it happened. So, Prasant, congratulations. You are our next winner. So I'm going to go ahead and just write your name down here. And once I've got it, we will move on to the next presentation. Awesome. Well, if anyone has any questions, feel free to post them to the chat. That'd be most welcome. I love the I love the comments here. Here we go. Hashtag rig24. That's hilarious. I love that. That's it's not. I assure you it's not, but you know, sometimes we have to post updates to the chat and yeah, they get captured there. So anyways, looking back at our calendar, let's go ahead and take a look at our next one. So next we've got Ian Crosby. He's the field CTO of Aptum, another Octopus partner, delivering a session entitled Hybrid Cloud Hybrid Problems, Deployments in a Hybrid World. And so this is all talking about, you know, obviously what we're doing around hybrid deployments, especially relative to cloud. So the way that I like to think of this is that, you know, when you think about measuring your software development team's performance, it's best done through metrics like deployment speed, frequency, reliability, all the DORA metrics that we have integrated through Insights with Octopus Deploy. With continuous delivery, that's the ideal target for most organizations. So in this presentation, you know, there are some significant hurdles that Ian poses around hybrid cloud. Hybrid cloud setups feature a mix of legacy on-prem, infra, public cloud, and there's this sort of trend that you're seeing in the industry right now about what's termed as cloud repatriation, where you're taking assets that are in the cloud and bringing them back into your infrastructure. So Ian talks about all of this and more in his presentation. So let's turn it over to him and hear what he has to say.
Hello, everyone. Really excited to be here today and be part of this really great event. My name is Ian Crosby. I'm field CTO at Aptum. We are a trusted Octopus partner, but today I'm not going to be talking about Octopus Deploy. I'm going to be talking about hybrid clouds, and specifically why I think more people should be talking about hybrid cloud. What are some of the challenges with it, and what are some of the patterns that I've seen for having success in a hybrid cloud architecture? So, talking about hybrids, I think what's interesting is that hybrids weren't actually meant to be an end solution, right? When hybrids came onto the market, it was about being an intermediary step, because going from traditional gasoline-powered car to 100% electric vehicle is a very big shift, right? That's a big cultural jump. That's a big practical move. There's a lot of infrastructure involved. So by introducing hybrids, it made that transition a whole lot easier. And when you think about it, hybrids kind of have the best of both worlds, right? I get that fuel efficiency that I'm really looking for. So I'm not paying as much. I've got less of a carbon footprint, but I've still got that reliability in behind. Right? I know that I'm not going to be worried trying to find a charging station or stuck with a dead battery somewhere, because I've still got that gasoline-powered engine that's behind. However, there's obviously some difficulties that come with hybrids as well, right? Essentially, you've got two cars smushed into one. That is a whole lot of complexity, a whole lot of components, a whole lot of room for failure. And if I need somebody to work on this, I'm trying to find a mechanic. Well, it's not everybody who's going to have that knowledge to be able to work on this hybrid vehicle. Now, I'm not going to sit here and talk about cars for 30 minutes. This is a conference about ships, not cars. But I really like that analogy actually goes pretty far when we're thinking about hybrid clouds. Because in a very similar vein, hybrid was never meant to be the goal. Nobody came out and said that hybrid cloud should be the utopian that we're searching for. Anybody who's been in the industry as long as I have remembers the day when everything was on premises. And it was very painful and slow to try and get new hardware. We'd have to request out to a different team. They'd actually go and get physical boxes, and rack and stack them, and provision. It was a very long and tedious process we had to go through. And when you got that first experience of the public cloud and what was possible, it really opened up a lot of amazing options, right? I could just go from, again, trying to wait 6 to 18 months maybe to get a server, to using my command line, to just having infrastructure up in a matter of seconds. And this spurned a whole wave of innovation, right? Startups who no longer had to have a huge infrastructure budget to go and buy a bunch of hardware and servers. All they needed was an AWS account and often got a bunch of free credits and could immediately test out their idea, find product market fit. And this kind of wave of innovation led some of the traditional enterprise companies to feel a little bit left out and want some of that, positive cloud juice. And from there, we saw, kind of echoing from the mouths of every single CIO, a strategy somewhere around the lines of cloud first. And cloud first, often not really just meant to run to the cloud as quickly as possible at all costs. And obviously that came with a lot of challenges and didn't really work out in many cases. Right, the promises that we thought we were getting with cloud, right? This infinitely scalable computer. It was meant to be cost effective, right? I'm only getting paid by the minute, paid per use. So there's no waste. It should be more sustainable. These things should be secure because AWS, Google, Azure, they've got the best security engineers in the world that are working there. And they're meant to be reliable, right? I've got all the nines. Essentially, we were promised sunshine and rainbows, and what most people actually got was a lot of sleepless nights and angry CFOs. Because we thought we were getting when we were adopting cloud wasn't what actually came to pass. And this is what I've seen in talking with customers over the past couple of years, really, is this idea of cloud disillusionment. Okay, we've got there, we've done this, lift and shift, we moved everything to the cloud, but we're not just seeing the payoffs that we thought we were going to get. Cost overruns are constant because the cloud is built for consumption. So it's easy to consume. So that's what people do. That's what teams do. And that just means that the costs just become overwhelming. And there's lots of security concerns because yes, they've got wonderful security teams, but the complexity of these cloud environments make it really easy to shoot yourself in the foot. And this complexity just continues to grow. And it's a challenge that people face, which has kind of led to this idea of maybe the cloud wasn't the way that we needed to go, right? Or maybe we needn't go all in on the cloud. And people are starting to temper back a little bit and looking at, hey, maybe there's a mix of the two. And this starts to look like hybrid cloud. I see really three paths in which folks end up in a hybrid scenario. The first is where there's a hard requirement. And this means, I've got regulatory compliance. By some kind of contract, I'm bound to maybe run my data or my applications within infrastructure that I physically own. I'll put this in air quotes because these requirements aren't always written on paper. Sometimes it's just maybe the whim of the current CIO or CTO. But whatever the case, there are valid reasons where, some of my workloads, I just have to run these on premises in my own data centers or my own infrastructure. But, I still want to be able to leverage all the promises of cloud. I still want to run these burstable workloads or leverage managed databases, leverage serverless architectures. So I end up with a hybrid cloud infrastructure in that sense. The second path is the partial or sometimes never-ending migration. Speaking with a client recently who was on year 6 of their 3-year cloud migration. And this is not often an uncommon story. Folks kind of head down this path of, we're going to migrate everything to the cloud, only to find out that it's not always feasible. And other priorities get in the way, and you kind of get stuck in this hybrid scenario by accident. But this isn't always unintentional, right? If you think about these 6 R's of cloud migration, one of those R's is retain. And it's a very important category. It means like when I'm looking at my workloads, which of these does it make sense to actually keep on premise? It's not worth that return of investment of taking the work and modernizing it and moving to public cloud, but I'm going to leave it there. And again, that's where I end up in a hybrid cloud scenario. And the third path here is folks who are generally a little bit more mature, a little bit more advanced, and they're actually looking at optimizing their workloads. They've kind of realized that the public cloud doesn't make sense for everything. And especially from a cost perspective, do I really need to run everything there? You know, we've seen a lot of noise around the idea of even repatriation, right? So moving things back from public cloud to on-premise. And while sometimes this is about maybe latency or, again, governance requirements, 90% of the time it's about cost. If I have workloads that are fairly stable, fairly predictable, I'm going to be able to run that a whole lot cheaper on premises than I can in public cloud. So this gives us a lot of roads that lead to a hybrid cloud world. And, you know, similar to the hybrid vehicles, it can kind of look like maybe that gives you the best of both worlds, right? And I can have my stable, traditional on-premise infrastructure where I run my core workloads. And I know I'm not going to get surprised at the end of the month with a bill for that. I can predict how much that's going to cost. And then when I'm doing my experimenting or there's a lot more unknowns, I can leverage a public cloud to run these burstable workloads, to leverage these higher order services, you know, have a serverless architecture. And this feels like a reasonable idea on paper. But as you probably noticed from the title of this talk, I'm not here to talk about the positives of hybrid cloud. And the reality is that there is a reason that hybrid cloud wasn't a pitched utopian architecture, right? It comes with a lot of challenges. And center to all that is really about complexity. Because obviously you are at least doubling the complexity that's within your architecture, right? You are now managing two completely different environments with different needs, different requirements, different skill sets, different tools. That becomes a whole lot of cognitive load to put on your teams and your people. And out of that, we see the tool fragmentation. Generally, you have your traditional tools that you've been using for your on-premise infrastructure, but you don't want to go take that and leverage the same tooling if you're going to launch a brand new cloud native initiative in public cloud. Right? Like that's like buying a brand new Ferrari and then just keeping it in the garage. So you want to leverage those brand new tools that are out there. But this obviously comes at a cost because you're going to have to manage, operate, and solve for both. And this leads to a skill set gaps. Are you going to expect your teams to be able to understand, manage, and operate both on-premise and public cloud environments? Or are you going to split them up and have two different teams, one responsible for on-premise, one responsible for public cloud? They're probably going to be siloed. Neither of those is an ideal situation. And it really comes down to just a whole lot of operational overhead. Because there are more requirements, more things to manage. It's a much more complex environment. So I want to touch on some of the patterns, some of the strategies I've seen to have a little bit smoother, a little bit more success in a hybrid environment. And first of all, it's really about understanding your specific constraints. As I laid out earlier, there are different paths that get you to hybrid cloud. So there is no one solution that fits all. You need to understand what are your specific needs and your specific constraints. But one pattern that I've seen very successful is modernization. And specifically, this is the case where if maybe you have government regulatory reasons that you're running on premises, or maybe it's for cost. Just because you need to run certain workloads on premises doesn't mean that they can't be modern. Right? All of the advances that we've seen around cloud native tooling explosion in the past number of years means that I can have a fully cloud native modern environment running in my own data centers. It's not a problem. So if I go and modernize the workloads that I do have on premise, that makes it a whole lot easier to manage the different environments because I'm looking at a lot more parity between the two. A simple example is leveraging containers where that's possible. Right? If you have the same kind of deployable units for your applications, whether it's on premises, whether it's in public cloud, it makes the tooling, it makes the processes, everything else a whole lot simpler. The second pattern, as I talk about it, is about unified tooling. Ideally, again, you want to minimize the complexity and do that by having common tooling across both. Obviously, this is not always possible. Traditionally, we've got these what we call legacy tooling to manage our on-premises or more legacy applications. And then we've got this set of modern cloud native stuff, which tries to pretend that legacy doesn't exist. But we're seeing more and more that the need to manage these two environments is pushing tool builders, pushing product owners to build these features in. So an example of a client I was working with recently had one of the very common setups, right? Your modern stuff is written all containerized, but they still have to deal with a bunch of virtual machines. Well, with projects like KubeVirt, for example, you can still do all of that within a Kubernetes cluster. And if you want something a little bit more enterprise, Red Hat OpenShift, it's got the same functionality built upon the same tools. So you can have a single platform managing both your containers and your virtual machines. Another common challenge is around Windows environments. And there again, you can leverage tools like Windows containers. They're not ideal. You don't get the same benefits you're going to get out of most containers, but you do have that uniform building blocks to allow you to get benefits. The third pattern is around abstraction layers. And you've probably heard a lot talked about platform engineering. And this is really what it's about here. It's saying, we know we've got a lot of complexity in the setup, but let's put that complexity somewhere intentional, shift it away from our developers, let them focus on building features, adding product value. And we're going to sit that complexity within a platform engineering team who's going to build abstraction layers on top to, again, allow those developers to go and iterate quickly, have that managed within a specific team. And the final pattern is around observability. And this is something that I just continuously see companies under-investing in, right? Having proper, not just observability tooling, but processes and patterns to really understand your environments. And ideally in a hybrid environment, you want that uniform single pane of glass. So for example, us internally, we're currently going through a project where we're trying to uniform one of our more modern products where we manage public cloud platforms, and another product, where we manage traditional infrastructure. And they've always used very different observability toolings and observability platforms. And we're trying to investigate, can we find a unified platform that monitors both, really, to avoid a lot of the duplicate work and to remove some of that complexity that exists. So if we talk about deployments and what that looks like in hybrid cloud environments, and again, some of the challenges and some of the strategies that I've seen work. And the first one, and I can't believe still saying this in the year of ChatGPT 2024, but automation is really key. I was recently working with a company, and they wanted us to look at their deployment process, where they were deploying not just applications, but they deployed entire environments for their clients. And part of that environment was a very modern microservices, all containerized, all deployed on Kubernetes. Infrastructure as code. It was very automated. It was very sleek and modern and quick. But the other side they had was still some Windows virtual machines. And there was a very strong dependency between the two. So no matter how quick and how efficient they could deploy and get these modern microservices deployed, it still depended on how slow these Windows virtual machines were to deploy. And that was still a very manual process to deploy, provision. It was done through manual actions by different members of the team. So that was really the first thing that could get a really big win there of just building in that automation. And often we invest a lot of our efforts in that more modern, exciting side, but we need to invest the same amount of effort into our traditional legacy applications and legacy processes, because odds are they're going to be there for a long time. So really need to invest in having that automation that allows you to build on top. The second strategy is around release coordination. So this is something I see more in hybrid environments where we've got different dependencies we need to manage, like I mentioned, potentially between modern cloud native microservices and maybe traditional virtual machines, but also versioning, right? If I have to deploy to a public cloud, maybe a SaaS environment, and I'm also deploying on-premise, maybe I'm deploying to customers. As soon as I need to start keeping track of versions, this becomes really, really challenging. And I've seen at a number of different companies where they're kind of keeping track of which versions are deployed where, or which applications have dependencies on which versions of other applications in an actual single text file or YAML file. And I'm just hoping that that's at least stored in Git. But there are much better solutions for that. And this is one area where I do need to call out. I feel like Octopus Deploy does a great job of handling this. There are other tools, but it's really important to solve this in an intelligent way, because in a hybrid cloud situation, these complexities are just going to proliferate. Which leads to the third point, is really invest in the tooling. Understand what are your needs, what are your requirements, and find a tooling that fits that. As I said, even the modern cloud native tools are starting to adapt and understand that they also need to solve the use cases of the more legacy world. So maybe you looked a couple of years ago, but it's worth looking again. A lot of tooling are really trying to solve both. So make sure that you find one that fits. And finally, once you do have a strong deployment process in place, you have automated deployment pipelines, you can really use the CI/CD as an enabler in your hybrid strategy, right? When we get into the situation where we're looking at right clouds, right workloads, well, if you have a CI/CD pipeline that's truly automated and you have proper metrics around it, then you can start running experiments. What does it look like to deploy this workload on premise instead of in public cloud? Do I save money? Do I lose out on reliability? That's where you really get to tweak and optimize and get to an ideal hybrid cloud situation. So wrapping things up, hybrid cloud is not the hero we deserve, but it's the hero we need right now. And for better or worse, this is what most of us are going to be working with for the foreseeable future. So it's really important to strike that balance, right? Be intentional about what do we want to run in public cloud and what makes sense to run on-premise. And we're trying to tackle the challenges that are there. It's all about the complexity. Try to move complexity away as much as you can, because just by having a hybrid environment, we've already introduced a lot. So commonalities where you can, across your tooling, across your processes, look for single panes of glass. And again, shift that away from the development teams. Try and centralize that within abstraction layers, within a platform engineering team when possible. And finally, it's about optimization, right? Just as hybrid cloud is not an end state, it's not a final state whatsoever. It's going to continuously be evolving as your workloads change, as needs change, as infrastructure changes. So ensure that you're measuring, you're understanding the state of your environment, and able to optimize as the situation changes. That's all I had for today. Thanks so much. Again, my name is Ian Crosby, Field CTO at Aptum. Would love to answer any questions. Please reach out if you've got anything to say, any challenges that you have around hybrid cloud. Thank you very much.
Awesome stuff. Thank you very much, Ian. Really thought-provoking stuff around hybrid cloud, especially cloud repatriation. It's something that you're seeing as a trend these days. We are back with another draw. Amazing. It just keeps happening over and over again. So we have our previous winner. Don't forget to get your entries in there now using the hashtag SHIPPED24. By doing so, you'll enter to win a couple of vouchers that we're giving away. One for our GitOps certification and one for our store. If you haven't seen the store, you can check it out at shop.octopus.com. There you'll see a site that looks like this. And we've got fabulous swag here. Our t-shirts are highly coveted. When people see these at dev events, they love them. So we've got t-shirts, we've got hoodies, we've got headwear. We've got lots and lots of stuff here. So if you're at all curious, maybe you might want to buy one of these. You could win one by submitting a comment with the hashtag SHIPPED24. So there you go. In addition to that, I just wanted to mention a couple of things. So One of the resources that we often tout is this one here, which is our webinars. So for those who don't know, we run webinars almost weekly now at these times. So if you go to this URL at octopus.com/webinars, you'll see a page that looks like this. We've got a bunch of webinars that are coming up. Next week, we've got Nathan Harvey from Google joining me to talk about a new State of DevOps report. So the State of DevOps report from DORA has been published for a long time, and it comes out yearly, and there's a lot of really cool insights that come out of it. So if you're at all keen hearing about what's happening around DevOps in various organizations based on the data that's been collected, then this is a great webinar for you to attend. The other webinar that we've got is a series called Octopus 101, and we run these monthly, and it's basically like kicking the tires of Octopus. If you want to see nothing but demos of what Octopus looks like, this would be another great webinar for you to check out. And then in February, we've got introducing config as code for runbooks. This is a feature that was touted during, obviously, the keynote, so you can check that out as well. All these and more you'll find at octopus.com/webinars. Make sure to bookmark it. We put all kinds of webinars up here all the time, which is awesome. All right, going back to our giveaway, let's go ahead and draw a new entry. Come on. This is like press your luck. No octopus. No octopus. All right, who we got? Doug, Dennis, CodeFresh. Oh, Yuri. Hey, I was going to say, not CodeFresh. I know, it's the hashtag rigged24. All right, let me go ahead and write down this name, and then we will move on to our next presentation. Again, if you have any questions or comments you'd like to use in the comment section, please go ahead and do so. Use that tag, SHIPPED24, and you'll offer a chance to win. Awesome stuff. All right, let's go back to our schedule. Moving on, we've got Pradmoth, who is a member of the team, DevTools. DevTools is a Octopus partner in India, and he'll be presenting a talk entitled Accelerate Digital Transformation with Best-of-Breed Pipelines. So the abstract I got from him was actually quite interesting. He was talking a lot about basically providing best-of-breed pipelines. And so in this session, he takes a look at a variety of things, including GitHub, JFrog, Octopus Deploy, and how they all kind of work together. So let's go ahead and welcome him to the stage. All right. Hello. I think you're good to go. There you go.
Hey, John.
Hey.
Hi, everyone.
All right, I'll leave the stage.
Thank you. Yeah, let's start. Hello, everybody. Hope everyone is having a good day. I'm here to take you through a session on how you can leverage the integrations from several DevOps tools to reduce the context switching. And this session is mainly focused on tools such as GitHub Actions, JFrog, and Octopus Deploy, leveraging the best of breed pipelines and how the information flows into at tools. So I'm Pramod and excited to have all of you here. We'll start with a brief introduction of DevTools, the company that I'm working in, and a premium partner of Octopus Deploy for a little over 2 years now. With over 13 years of experience, we have had the privilege of working with around 600 plus customers across various industries, helping them achieve their technology goals. Our leadership brings in a combined 250 plus years of expertise, which guides everything we do. What sets us apart is our strong ecosystem with 12 plus partnerships with leading DevSecOps providers around the globe, ensure that we deliver top-notch, secure, and scalable solutions. This foundation has helped us become a trusted partner for digital transformation. Simply put, we are here to make our customer journey smoother, faster, and more secure. We have observed these key challenges our customers face, and our focus is to address them and go beyond. At DevTools, we focus on solving the real world problems like team misalignment, ensuring the projects stay on track, and enhancing the customer satisfaction. We work to improve quality code, developer satisfaction, and secure the software supply chain. And this is just a tip of iceberg. On the operational side, we simply work on the cloud adoption, data migration, and adoption of engineering and ITSM platforms. We also ensure the applications are highly available, perform reliably, and are secure, all while reducing the inefficiencies like manual builds and deployments. Our approach is to tackle these issues holistically, helping the teams achieve efficiency, security, and scalability in their development workflows. The strength of our ecosystem through our partnerships is highlighted here, and DevTools has established certified and premier partnerships with some of the most recognized names in the DevSecOps area, as you can see. At DevTools, we help customers streamline their workflows, automate processes, and adopt best solutions available in the areas of DevSecOps, GitOps, ITSM, and even GRC as well. Our focus is solving the business critical challenges over here. Last slide on the DevTools introduction. Our clients span a variety of industries, including aerospace, healthcare, and financial services. This diverse um, client base demonstrates our ability to adapt our solutions to different sectors, ensuring that we have met specific needs of each industries, be it with compliance, be it with the approach that we take towards the implementation of a product, and even the adoption as well. DevTools is not just a service provider, we are a strategic partner dedicated to helping our clients achieve their goals. So it is important that the organizations enable to build, deploy, and scale faster while maintaining the highest standards of quality and security. By bringing together the right tools and practices, we will explore how modern pipelines can help achieve better collaboration, faster delivery, and more secure applications. So this is what we are going to focus on. Um, Let's start with the importance of SDLC. At the heart of every successful digital transformation lies the software development lifecycle. This process ensures that we deliver quality software by focusing on every phase, and any frameworks with uh, that is associated with SDLC revolves around it, be it planning, coding, building, testing, even releasing and deploying, and after which operations and monitoring will come into stage. Each stage plays a critical role, and when optimized, the SDLC helps team deliver reliable and scalable solutions faster. Today, we will dive deeper into how tools like GitHub, JFrog, and Octopus Deploy integrate seamlessly into this lifecycle, making it more efficient and secure while driving the business value at every stage. We see an example of multiple tools bringing the development lifecycle with cohesive integration, which is not only uh, which does not accelerate the delivery but also enhances the security and ensure smooth workflow for the development teams. Starting from Jira, let's take an example for issue tracking and manage project management, to GitHub for source control and GitHub Actions for automating the workflows. This pipeline ensures efficiency at every step. JFrog Artifactory, where we manage secure artifacts, followed with the Octopus Deploy to automate deployments across environments. Finally, applications that are deployed seamlessly to production environments. So let's break down the key tools in this pipeline at each stage and the value that they bring in. So first and foremost, the pipeline integration integrates the tools like Jira, GitHub, JFrog, and Octopus Deploy to create a cohesive workflow addressing the challenges like manual inefficiencies and security vulnerabilities. Coming over to GitHub Actions, uh, GitHub Actions helps us to automate workflows right from GitHub repo. It enables the efficient code integration, build, and testing, making it easier for teams to ship the code faster. JFrog acts as a universal artifact manager, providing a secure storage when we have X-ray as well in place, and it's a comprehensive vulnerability scanning tool. This ensures that all the build outputs are safe, including the ones that are coming in from the remote repositories, and it is organized and compliant. Coming over to Octopus Deploy, simply put, it simplifies and automates the deployment across various environments, ensuring the consistency and reducing the risk of errors during the releases. Each of these tools play a critical role in creating modern, secure, and an efficient software delivery pipeline. One of the key advantages of integrating tools like what we have mentioned over here is the ability to minimize the context switching, where you see the flow of data from one tool to another. Now that we have the AI capabilities bringing into these tools, you'll also be able to provide the context much quicker. And by creating a seamless flow between these platforms, teams can stay focused, collaborate efficiently, and reduce the inefficiencies caused by jumping between disconnected systems. This integration drives productivity and ensures smoother, faster workflows from the development teams till the deployment stage. So let's focus on the tools one by one. We will go to GitHub. GitHub is more than just a source code system as of now. It offers robust features like branching and pull request workflows to streamline the team collaboration. GitHub Actions, a powerful automation tool that enables us to build, test right from the GitHub ecosystem. Tools like Dependabot also helps us to keep the dependencies up to date automatically and ensuring the security and reliability of the software. GitHub's native automation capabilities eliminate the need for additional tools that we keep separately. Coming over to JFrog, here is where we manage the artifacts, binaries, and containers, and several other packages that it supports in a single and organized system. It acts as a trusted central hub for managing and securing your DevOps workflow. It ensures comprehensive audits and tracking of changes across all builds and releases. It incorporates the industry-leading security scanning and helping the teams catch vulnerabilities early. It provides the global scale governance, ensuring compliance, reliability in the even most complex environments, right? Octopus Deploy simplifies and automates the deployment process, providing repeatable and reliable deployment across environments, is what we call as channels, where the process is defined with several branches that are mapped to a Git source in GitHub, support for multi-tenancy and infrastructure at scale, making it ideal for enterprise operations. Insights into DORA metrics helping teams measure and improve their performance. Additional features like emergency operations, automation, robust RBAC, and multi cloud capability make Octopus a critical tool for modern DevOps teams. We'll see more of Octopus Deploy features in the coming slides. Moving over to JFrog a bit further, what we have here is a platform that stands out as a comprehensive solution for managing the entire life cycle of your binaries and artifacts. Let me walk you through each one of them. Basically, what we have is a binary lifecycle management, which JFrog provides with its robust tools for OSS package curation, release management, and long-term asset archival, ensuring that you have a complete control over your binaries from creation to deprecation. With true universal feature, it supports over 30 plus packages and file types. The platform offers native support for local, remote, and even virtual repositories as well. It also enables us to seamlessly cache the open source packages, which speeds up builds and ensures the availability. Without the out-of-the-box integrations and extensive APIs or even CLI, the platform effortlessly integrates into your DevOps toolchain, automating the key processes for greater efficiency, where we were talking about the integration. Advanced metadata that captures access controls and global usage policies. These features provide complete visibility and governance, ensuring the compliance of your organization and even security across your software delivery process. Apart from this, when we talk about the tool itself, it's federated repositories, high availability architecture with multi-site support, and even project-based management make it simply to scale globally, whether you are a small team or an enterprise. So what we see here is a flexibility is at the heart of JFrog platform. You can deploy it on-premise, cloud, or even work in a hybrid environment. The focus here is how it integrates with Octopus Deploy. So let's look at this at a later stage. And coming over to Octopus Deploy, it's all about enabling teams to deliver the applications faster and with confidence. So let's go through features one by one. First one being, it focuses on the repeatable and reliable deployment processes, which we saw earlier. By allowing you to define your steps once and you use them across environments. It protects your workflow with granular permissions, version control, while offering a vast library of over 500 deployment templates to simplify the complex tasks. Octopus ensures every release is smooth, secure, and efficient. One standout feature of Octopus Deploy is that is its ability to handle the multi-tenancy deployments at scale. This means you can deploy the same software to multiple tenants, whether they are customers, stores, or even regions. They are different use cases, while maintaining the consistency and control. It's designed to scale the complex deployments to thousands of tenants effortlessly, making it perfect for organization with distributed or large-scale environments. Moving over to the daily operations, where you see an effective way of managing the backbone of any IT or DevOps team activities, right? Especially when it comes to day-to operations. With automation, we are taking a routine and emergency operations to the next level with Octopus Deploy. Imagine automating a task like database backup or destroying an unused test infrastructure. This reduces the manual effort, minimizes errors, and ensures the fastest response during these critical situations. This approach empowers developers, IT teams, non-admins with self-service operations. Imagine you given access to a L1 support team guy or the one who is newly onboarded, and you just want to have an option of click of a button to operate some tasks with them. So this feature will really help them to leverage this and then make the most of it. By integrating automated runbooks, we cut down the ITSM ticket queues as well, where they raise a ticket and then after that there is a delay in operating on that ticket, right? So basically it's an efficient and agile way of working. Let's talk about the performance visibility, where I was talking about the metrics. So deployment frequency, lead time, failure rates, and recovery time are some of the critical metrics for measuring the DevOps success, commonly referred to as DORA metrics, right? These insights aren't just numbers, they are the key to identifying the bottlenecks and driving improvements in your deployment process. When we measure these metrics accurately, we gain a clear picture of what's working and what's not. And that's when we see an improvement that is required in the team. For instance, by reducing the deployment failure rates and improving the recovery time, teams can ensure more reliable systems. The goal here is simple: continuously improve, and the deployment performance will also in turn improve, and the stability that comes out of it is um, very reliable, right? Creating a culture of innovation and resilience. In today's IT landscape, we need a solution that can handle everything from legacy to modern cloud native infrastructure. That's where our platform shines. Whether it's ARM or ARM64 system, Linux, Octopus Deploy covers everything. We have also centralized cloud infrastructure with integrations across all the major cloud providers, AWS, Azure, and even Google Cloud. Um, Basically, a containerized workload, Octopus Deploy will be able to support. So basically, the deployment pipeline simplification is boosting the team productivity. And coming over to the critical aspects, where we see the modern infrastructure has to ensure the transparency and accountability, where we see the audit and security logging. This is where the Octopus Deploy tool will really help in capturing and even the searchable items. So this means you can pinpoint exactly who made the changes, when and where, and including the verbosity as well. Not only does this improve the traceability, but also make it easier to integrate it with SIEM solutions. This ensures that you have the logs um, that are just not stored, but also actively monitored, helping you to identify the issues and mitigate the potential risks quickly. Let's talk about a bit of API integrations, or how Octopus Deploy offers integration with APIs. This is an API first approach, which ensures that anything that you have in the UI, you also have it in the API. This opens up endless possibilities for automation and scripting, right? When we say templates, right? Whether you prefer Python, PowerShell, or Bash, um, Octopus Deploy offers scripting in popular languages with the CLI tools as well. Common API commands is supported. Moving on to the compliance part of Octopus Deploy, what we have here is RBAC and granular permissions that come in. Teams can self-service and manage their deployments independently, but there are guardrails which helps us to control the permissions. For instance, not everyone can deploy to production or manage the critical infrastructure. These permissions should be restricted, which this tool supports. This ensures that security while empowering the teams to operate efficiently within their scope. So this is all about Octopus Deploy and the integration with GitHub and JFrog. I Hope that you got the insights on how we can leverage these tools for building the best breed of pipelines. Thank you all for taking the time to this session. I hope this session has given you valuable insights into how best of breed pipelines powered by some of these tools which we saw can accelerate your digital transformation journey. Thank you all.
Awesome stuff. Thank you very much. That was great. Especially like the integration with the CLI. I actually worked on that a little bit, so I know that quite well. CLI is one of my favorite tools. Power to the people who use command lines. So,
Right.
awesome stuff. So, if you have any questions, let us know in the chat. As always, feel free to use the hashtag SHIPPED24. Just include it here, just so folks know. And we'll do another draw here shortly. But make sure to submit those through so you can be included in the giveaway tool. I got to figure out how to get this giveaway tool program better so that it doesn't offer up so many Octopus and CodeFresh results. But there you go. It's rigged 24, as Sievert was mentioning earlier. Anyways, I'll let you go. Thank you very much. We're going to go ahead and do another draw here. I don't see any questions in the queue, but thanks a lot. Really appreciate it.
Thank you all.
All right. Okay, so let's go ahead and jump now back over to the giveaway tool. Yuri was our last winner. Lucky Yuri. Make sure to submit your sessions here, or rather your comments. Sorry, it's that time of day for me. All right, our next winner will be CodeFresh. That's not good. All right, let's do this again. Sorry, it's because we have like 5 accounts linked up. That's why it is acting the way it is. That's too much confetti. Let's go ahead and draw this again. Remember to use that. Yeah, I know. It's getting worse and worse every time I do this. It's like, this is rigged. It's not. Thomas. All right. There you go. So Thomas is our lucky winner. Awesome. We will send you a note to let you know more. All right. Coming up next, we are in the home stretch for day 1. How are you feeling? Still got some life in you? Great. I know it's been a long day. But it's great. It's like it's just being shotgun blasted with all this information into your head, which is great. This next session is entitled Simplicity or Compliance, Why Not Both? And this is from Ivan at CROZ. CROZ is yet another partner of ours in Europe, and he's the director of engineering there. And in this session, he makes reference to DORA. No, not the DORA that you're expecting around metrics, but DORA, which is a compliance regulation that's being enforced in Europe. And so in this session, Ivan talks a lot about this and some of the things that you have to deal with when looking at various aspects of compliance relative to that. So let's go ahead and see what Ivan has to say.
Hi all. I'm sure I won't surprise you when I say that we live in times of increased cybersecurity risks. Various regulations are in place to help us become more resilient. We all want to be more resilient and compliant, yet we don't want to sacrifice the pace at which we are delivering value, and we don't have to. There is a way to be both fast and compliant. And to achieve that, several pieces need to come together, and today I'll show you how Octopus Deploy is an important piece of this puzzle. My name is Ivan Krnic. I'm Director of Engineering at CROZ, a Croatian-German BizTech consultancy. I'm also hosting the 0800 DevOps podcast. If you haven't so far, please give it a chance. And I'm O'Reilly author in 97 Things Every Cloud Engineer Should Know. Currently, I'm in this attempt to finish my book on modern service providers and their collaboration with clients. So if you are a service provider or if you use their services, this book will be for you, so please stay tuned. Much of what I'll share today comes from the BizTech perspective of looking at our clients' business needs and designing with them appropriate technical solutions. As a BizTech consultancy, we operate on the intersection of business and technology. And this approach enabled us to first deeply understand client needs and then use those insights to suggest technical solutions. Operating on this intersection of business and technology means that over time we have deliberately built diverse capabilities ranging from strategy and service design to engineering and operational support. This approach of first understanding the business context and then looking for a technical solution is what led us in our conversations with our clients regarding regulatory needs. And so please let me share my personal DORA experience. You know, in my life, I met 3 DORAs so far, which is probably more than many people can brag with. My kids introduced me to the first one, and this one focused on teamwork and having a clear goal. And if you're familiar with this DORA, you will know that she is very much into systematic approach and putting together a clear plan for achieving the goal. This DORA also taught me that adversaries often come in a friendly form, but if we want to build resilience, we should nevertheless be relentless in solving problems while they are still small. So, swiper, don't swipe. And then I met my second DORA, DevOps Research and Assessment DORA. It's an amazing study that started back in 2013, and many teams look into it. I'm sure you are all familiar with it. Many teams work on increasing their performance by improving the now legendary 4 key metrics. And what this DORA tells us is that it is possible to increase speed of delivery as well as the stability of our deliverables. In fact, this DORA tells us that speed and stability come hand in hand. If we are able to deliver something faster, then the feedback loop shortens, and that gives us the ability to work in small batches. Small batches are, on the other hand, correlated with less problems since changes are smaller, they are incremental, they are easier to review, and the blast radius is smaller. The other direction works as well. So if deployments are stable and we don't need to spend time in firefighting mode, we can use that additional time to actually deliver value to our clients. So this in turn makes us even faster from the perspective of value delivery. Speed and stability obviously come hand in hand, but what about regulation? So where does regulation fit into this picture? There is this notion that highly regulated organizations can't be fast. Those are, as we all know it, usually large enterprises with thousands of people, and these enterprises have made commitments to their clients in terms of service delivery, in terms of security, data privacy, regulations, ISO standards, in terms of sustainability, and they need to respect those commitments. But nevertheless, this feels like we are having the same conversation all over again. So the general notion is that if you want to be compliant with regulation, you need to take it slow. You need to check everything multiple times. You need to involve humans in as many actions as possible, because of course human species is the superior one, so they will obviously do the job well. I would, on the other hand, argue that highly regulated organizations can be fast and compliant at the same time. It's not either or, just like they can be fast and stable at the same time. Speed is achieved through continuous delivery, and compliance is achieved through smart automation, through data gathering, through reacting on events, and finally through smart dashboards that reveal the big picture. So how do speed and compliance go hand in hand? Well, if we are fast, that means we are working in small batches. And for small batches, it is much easier to assess the risk, to run checks, to react if something is not compliant. And in the other direction, automating much of the compliance work means we are not spending time gathering data or filling reports and so on, but we use this free time to deliver value. Verifying compliance should be a non-event. So this is something that should be done continuously, data that is continuously gathered and reported on, something that happens 24/7 without any human intervention. And to achieve that, several pieces need to come together, and today I'll show you how Octopus Deploy is an important part of this puzzle. There is a host of regulation around us these days, but today I would like to focus on one that is currently the hottest one in Europe. It is my third DORA, and this one stands for Digital Operational Resilience Act. Formally, DORA Act aims to achieve a high level of digital operational resilience by increasing the security of network and information systems, supporting the business processes of financial entities. In a nutshell, you know that financial institutions are the backbone of every economy, so DORA Act aims to make them more resilient to cyber attacks. So who is DORA Act for? You are affected by DORA if you are classified as a financial institution or if you are a critical ICT service provider for a financial institution. And there is a long list of financial institutions that are subject to DORA, like credit institutions, like payment institutions, so in a nutshell, banks, insurances, etc. Very, very important thing is that you're subject to DORA not only if you are a financial institution, but also if you are a service provider working for a financial institution. So for example, we at CROZ, we are a BizTech consultancy, and we work a lot with many financial institutions. As such, we are now also subject to DORA. It's not something that we wanted, but we fully understand why this is so. DORA Act aims to achieve a high level of digital operational resilience by recognizing several important domains that organizations need to address, and it defines mandatory outcomes for each one of them. DORA, however, like many other regulations, doesn't really prescribe specific ways to achieve those outcomes. It just says you need to achieve them and you need to prove that. And these domains are ICT risk management, ICT-related incident management, classification and reporting, digital operational resilience testing, managing of ICT third-party risks, and information sharing arrangements. Now, these 5 domains are very broad, and I won't go into tiniest details for each one of those, but I'd like to step into some of them to show you how Octopus Deploy can help you be compliant and by proxy increase your resilience. So let's look at the first DORA pillar. It deals with ICT risk management. Basically, financial entities, financial institutions need to have in place an internal framework for managing ICT risk. So something very similar to, for example, ISO 27001. Let's, for example, look at article number 9 of DORA. It says that financial institutions need to implement documented policies, procedures, and controls for ICT change management, including changes to software. They need to have in place change management process in order to ensure that ICT systems are recorded, tested, assessed, approved, implemented, and verified in a controlled manner. Now, this was a mouthful, and I think that this sentence pretty much sums up well how general the regulation is and how much it is up to the organization to choose its way of achieving the outcome. When you look at this requirement, some keywords pop up. I noted them with yellow. So those are procedures and controls. Those are software changes, change management process, and the governance process. And we all know what this means for delivering software solutions. So we need a robust continuous delivery tool chain that can automate and handle all these things. So let's see how Octopus Deploy can help with this article number 9. Building executables is one thing, and for me it was always the easier part. But deploying those executables correctly to the correct environment with the correct configuration, that part is trickier. And this is where Octopus Deploy comes to rescue. Octopus Deploy automates deployments with correct configurations and tracks which version is deployed in which environment. Paying attention to deploying applications with the correct configuration is super, super important. I think we all learned something from the Knight Capital incident when wrong application configuration resulted in stock exchange software buying and selling stocks at wrong positions. In the end, this incident resulted in $440 million loss, and the company went bankrupt. So configurations are super, super important. Furthermore, Octopus Deploy brings governance features such as detailed auditing, role-based access control, and single sign-on, which helps you establish governance over who introduces changes and for what reasons. Octopus Deploy captures every create, edit, or delete action with the information who initiated the action. And this includes changes to the deployment processes and variables, all changes to projects, environments, deployment targets, releases, and so on. So whenever somebody schedules or cancels the deployment, this thing is logged. And you can see all the data in the audit history together with relevant metadata. Regarding role-based access control, Octopus Deploy comes with a built-in set of roles, which are usually enough for standard environments. But if for some reason you need something custom, that's also possible. So you can define your own custom roles and assign permissions to them. So you can have a really fine-grained access control. If you are an enterprise with an existing authentication provider, there is no need to reinvent the wheel. So Octopus Deploy can also hook into your existing authentication provider, and you can have a single point to control access for all your systems. Some regulations already mandate implementation of segregation of duties principle. DORA Act is not very explicit about it, but it is implied through the requirement that all changes to ICT systems need to be assessed, approved, and verified in a controlled manner. Many highly regulated organizations turn to change advisory boards to have all changes assessed, approved, and verified. If we are looking purely at the efficiency of the process, change advisory boards are not the best way to do it. But this is one rabbit hole I won't get into today. But if you are in a need to implement segregation of duties mechanism, Octopus Deploy allows you to do that through manual approval steps. The deployment process will basically stop when you hit this manual step, and it will ask for somebody with appropriate permissions to approve the step and to continue the process. Another scenario that enterprise organizations often have is multi-tenancy scenarios, and many times basic tools break here because they cannot support this, and the complexity suddenly increases. Octopus Deploy supports multi-tenant deployments, so these scenarios are natively handled and they do not increase complexity. With multi-tenancy, you can be sure that you are always following the same process and things will happen always in the same manner, no matter where you are deploying your system. Without multi-tenancy, on the other hand, you would need to emulate this somehow, and that's usually by duplicating projects and configurations. And duplicating stuff is always a recipe for forgetting something, and you are just increasing the operational risk. Octopus Deploy lets you do that with minimal hassle and minimal risk to make a mistake. Another interesting article is article number 12. It is focused on backup and restore. So basically always have a working backup strategy. This is usually very clear when you talk about infrastructure, but let's see what this means to application services. Imagine, for example, your runtime environment goes wrong and you need to restore it. So one part of this effort is restoring the infrastructure, so spinning up virtual machines, reinstalling your Kubernetes clusters, and another part is restoring all applications with their correct configurations. Octopus Deploy easily handles these redeployments with the correct configuration. It does so through configuration management and deployment variables. Redeploying applications during recovery process can be very error prone. What usually happens is deploying wrong configurations, and suddenly you have your application in production calling APIs on test environment, or your production application talking to the test database. And the longer this lasts, the more corrupted your system gets, and you don't want to get there. So Octopus Deploy brings you maximum certainty that your configurations are correct when redeploying applications during recovery phase. Also, in case anything goes wrong with the deployment, Octopus Deploy has a robust rollback mechanism, so restoring services is a breeze. Rollbacks are not trivial, they are never trivial. Sometimes they can be trivial if you are changing only the user interface of the application or even only the business logic. But once you start meddling with the database, rollbacks can become super complex, sometimes even impossible, to the point of you not rolling back to the previous version, but rolling forward by applying a fix. But even if you are going for a rollback, Octopus Deploy can support you through this rollback automation. And this means understanding which deployment steps should be omitted in rollback. For example, if regular deployment had some database setup scripts that were already executed, you don't want to repeat them, you want to omit them. Also, if rollback requires some additional changes to the environment, Octopus Deploy can automate those changes as a part of the rollback process. So you are not relying on the operator to remember to run those scripts. You are baking those scripts right into the rollback process. Let's move on to the second pillar. Second pillar deals with ICT-related incident management classification and reporting. This means you need to be in control of how you manage incidents. When you define incident management processes in the organization, it helps when you have a single source of truth, one dashboard to rule them all. Octopus Deploy doesn't even attempt to be one tool to solve all the problems in the world. So it excels in deployment management, but it is not an incident management tool. So there are plenty of those in the world. However, Octopus Deploy fully supports incident management process, so it provides integration with familiar tools such as PagerDuty or ServiceNow and Jira Service Management to tightly connect to the incident management process. Octopus Deploy will, for example, block the deployment process if there is no approved change request in the incident management tool. More specifically, what this means is that when attempting to deploy in the production, Octopus Deploy will raise a change request in the IT service management tool, and it will wait for all approvals to happen within standard organizational change management process. So once the change is approved in the service management tool, Octopus Deploy will pick up on that approval and it will continue with the deployment. So it plays very nicely with the rest of your processes. Also, if you are unfortunately in the incident management process, you want to have prescribed ways to resolve incidents as fast as possible. Octopus Deploy supports this process by providing automated runbooks. So runbooks are a mechanism to execute prescribed steps as a countermeasure to fix the incident. Imagine, for example, that an incident is reported and you can trace it down to expired certificates. Runbooks are, for example, a great mechanism for operators to fix the issue by executing approved and versioned scripts that reissue certificates. So this is just one example. I'm sure all of us have zillions of such scripts that come handy. The problem is that these scripts were created over time by system administrators as their personal utilities. And converting these scripts to runbooks, you're making them available to everybody in the organization while preserving and controlling access control. In essence, what you're doing is you are standardizing and controlling your incident response, precisely what DORA Act is asking you to do. Moving on to the third pillar. Third pillar deals with digital operational resilience testing. So the regulator wants you to have a sound and solid testing program that will increase your resilience in case defects happen. We all know it. If we want to have a solid automated testing procedure, we also need to automate the deployment process. So here we are circling back to the importance of controlling the deployment process. So the correct application version deployed in the correct environment with the correct configuration. And today, in this microservice world where many independent components work together to create value, this becomes even more cumbersome without the tool that helps you deal with this complexity. Based on test results, you can use Octopus Deploy to promote releases through different test environments until the release is ready for production. You can't imagine the number of times I found tests fail, not because of the code defect, but because the release was not properly deployed, or all components were not there, or the configurations were not properly deployed. And it was often the thing that took the most time to debug and fix. And it was always the thing that frustrated everybody the most. So having this process under control, automated and predictable, helps developers focus their cognitive capacity where it truly matters instead of debugging wrong configurations. The fourth DORA pillar deals with managing third-party risks. So organizations that are subject to DORA regulation are not only accountable for being compliant themselves, they are also accountable that their third-party service providers are compliant as well. So for organizations, that means they need to check and they need to help their third-party providers achieve the same level of compliance as they have. Having third-party service providers embrace a tool such as Octopus Deploy will definitely make their lives easier. If you are a third-party service provider, please be aware that your clients can come for an audit, so you better make sure you have all capabilities that we mentioned before in this talk. If you are still in doubt how to build some of those, Octopus Deploy is an excellent option for you. The fifth DORA pillar deals with information sharing. The regulator here aims to build a community in which all organizations share cyber threat information and intelligence to stay ahead of the curve and maintain global resilience. This pillar is focused on community building and information sharing, and Octopus Deploy has a very vibrant community. Please take a look at the Octopus Deploy library with a huge list of community-contributed deployment steps. So good people in the community have already solved a lot of common use cases and automated these actions as community steps that you can download and you can use in your projects. Community is always above the zero-sum approach. When community is healthy, everybody progresses, everybody wins. And Octopus Deploy library is the platform on which the community exchanges insights and best practices. So helping everybody do better. To sum up, cyber threat resilience has never been more important. European Commission has recognized that and put in place a Digital Operational Resilience Act as a forcing function for financial institutions to take resilience seriously. Resilience is achieved by improving in 5 areas. It is a comprehensive effort to increase the resilience. It's not easy, but with the right approach and the right tool, you can do wonders. Octopus Deploy is a great tool to build resilience in these 5 areas, and I hope this talk will inspire you to use it to its full potential. Thank you for joining this session, and feel free to reach out and get in touch. These topics are something that I'm always in the mood for talking about, so thank you for joining, and talk soon. Thank you.
Awesome stuff. Thank you, Ivan. That was awesome. Lots of really good insights there around DORA regulations and all of that great stuff. We are going to have a small break. We're just ahead of schedule here, so we're going to take a small break, and we will reconvene here in approximately 15 minutes. So you have 15 minutes to go grab a coffee and do whatever you need to do. We will be back here at that time. So we'll see you then. All right, we are back. Thanks for indulging the intermission there. Just wanted to share with you some resources as we're going through this. One of the resources that I was noted to bring up is this one here. If you go to this URL here, which is /GitHub, you'll see a page that looks like this. Now, this is our landing page basically for all things GitHub oriented. And if you're looking for a page that kind of details or documents everything that we have on the GitHub side, this is it. So octopus.com/GitHub. And in here, we have some very nice diagrams that showcase how everything kind of works together in the context of GitHub itself. So if you're looking at using VS Code and possibly Copilot as well, there you can see how basically the deployments flow from one tool to the next, and so you can see how this is all kind of hung together. And so if you want to see a series of videos as well, I've done a few videos here talking about our GitHub Actions. Matt's done a video here talking about our Octopus extension for GitHub Copilot. There you'll find all of these available up on this website. So definitely something worth checking out. I did mention the webinars as well, which is a great location for you to check out. A lot of our stuff is there, but definitely stuff that is worth noting. All right, let's go ahead and get off to the other part. I'm going to invite Jorge here from Kinder Systems to join us here. And in a second, he'll be joining us up on stage here. Oh, Jorge's not ready. That's all right. We'll wait for Jorge to get ready. Sorry about that. I'll just keep talking while we do that. Let's do another giveaway. How about that? All right, we're going to go back to our giveaway. Thomas was our lucky winner last time. Don't forget to put the hashtag SHIPPED24 in the comment section to enter as an entry here. Let's go ahead and see if we can get another lucky winner here. I'm not seeing any code for Extra Octopus. That's awesome. All right, who do we have here? Ulfar. All right, congratulations, Ulfar. We're going to go ahead and take your name down, and just let me write this down. We'll be sending you an email letting you know about being the next winner, which is great. So congratulations, Ulfar. All right. Jorge, do you want to give me a thumbs up if you're ready? All right, he's ready. Here he is. All right. Jorge, how are you?
Doing great, John. How about yourself?
I'm good. I'm good. This is the audience. Audience Jorge. Jorge audience. Jorge is the Senior Vice President of Operations at Kinder Systems. I actually brought up the webpage for Kinder Systems just to provide folks some context. You had done a webinar for us a while back talking about how Kinder Systems was using Octopus Deploy itself. Perhaps you could share with us a little bit of the story there.
Absolutely, John. Thank you for having me today. So, Kinder Systems, we obviously make software like most of you in the audience, and we are the leading provider of childcare management SaaS solutions to state agencies, Head Start programs, and childcare providers. You know, everybody in our customer base is in a slightly different place in terms of business complexity, and that's kind of part of our secret sauce, and that's part of what Octopus has helped us accomplish. So another way to say the same thing is to say that about 40% of the childcare subsidy attendance transactions in the nation go through a Kinder Systems deployment somewhere. So we are definitely, you know, out there in terms of impact and scope, but you know, we only have a little over 100 employees. And so what that means is that automation, in particular around the CI/CD pipelines, is hypercritical to our success. You know, when I first started, deployment would take, for a small product line, would sometimes take 2 to 3 days, right? There would be 2 developers, and they would do this after hours and do a handful of deployments at a time, taking backups and all that good stuff. And obviously that was not scalable. And that's sort of where Octopus and I came into the picture. You know, we, of course, because of the varying complexity of our customers, everybody does business a little bit different. So the same application in a different customer deployment could have some very big variations. So anywhere from like just a front end and a back end all the way through like 20 or so different APIs or utilities that need to be deployed. So again, automation is the name of the game. And so with Octopus, we were able to increase our deployment frequency. So John mentioned that we had previously done a webinar. Back then, the frequency had increased by about 2,000%. That's a little over a year ago. So that is probably closer to 2,600%. In other words, we in 2024 peaked at a little over 600 deployments in a single week. And all that was done with a very, very low failure rate. Again, thanks to the tooling from Octopus. So as a result of that, we shortened our release cycle and improved time savings and also, mean time to recovery. So, one of the things that Octopus enabled us to do is it allowed us to create consistent automation. And what that meant is that, our IT help desk could now do production deployments. I use the example of developers, working after hours to get the code out, and that's very expensive, right? From an opportunity cost perspective, and also just in terms of engineer burnout, right? When you have a day job to crank out new features and then you think it's 5 o'clock, you get to go home for dinner. Well, now you get to do your second job, right? Which is to get the code out there into the hands of the customer. So, our
second breakfast.
Yeah, exactly. And, our patterns are interesting. I mentioned the varying degrees of complexity, but important to call out is that we support on-prem data center deployments. We also support AWS and Azure, commercial and government. And that means that we have to leverage a lot of different endpoints, right? Depending on who's getting what. And so, again, Octopus, with the ability to set both project level and tenant variables, was hypercritical to ensuring the success. Now, we've been using Octopus for close to 6 years now, which means that, things have only continued to get more complex, but our failure rates actually continue to decrease as we progress, which, if you know what DORA metrics are, that's one of the outcomes that you measure, right? Not only how often are your deployments breaking, but how quickly do you fix them? And so in general terms, all our DORA metrics are improving. And so as a result, our speed to market is a lot faster, right? In this last year, we had a brand new application that we call Family Central. And it's a amalgamation of multiple stacks, lots of things to deploy, kind of a pivot from what we used to do, which was primarily, Microsoft related deployment. So that's kind of where Octopus started too. But my impression is that as Octopus grew, we grew. And so the ability to continue to operate from a single ecosystem, Octopus has provided that for us along the way. And so another example of that would be, we still do a lot of legacy Windows applications getting deployed, ASP.NET, that sort of thing. But we're moving more and more into orchestration with a combination of Octopus Deploy with Terraform. And we've also done some other cool stuff. For example, a single tenant may have over a dozen projects that it's connected to. But one of the challenges that we ran into is, while you might have a template for the variables, there's still a little bit of duplication, right? So you're calling out some of the same variables across multiple projects. And so what we did to sort of tackle that is we created some step templates of our own, where we essentially leverage the Octopus API to pull down the correct values. Now, in an ideal scenario, these values could be dynamically assigned, and we are certainly doing some of that. But not everything could be handled that way. So, my recommendation is that as complexity grows, the Octopus API is very, very powerful and doesn't get leveraged enough. So reuse the data that you already have in Octopus somewhere to use in new projects. That way, you're using values that have been tried in production or tried throughout the various lifecycle steps, and ensuring that your consistency stays there. So
Yeah, I'm just reading a little bit. I'm showing folks here obviously the customer story that you were kind enough to share with us. You'll find these up on if you're at all curious, you can go find it under company and then look for customer stories. And if you go there, you'll find the link to not only Kinder Systems but other stories from other industries as well. So Kinder Systems is located just here down the bottom. But it's great to see kind of like where you started from, the challenges that you were trying to overcome, manual processes, always a classic, slow speed to market, etc., staff burnout, and then where you've gone to, and Octopus is a tool as part of that. You're quoted throughout all of this, and then we give you a nice little picture of your pipeline here, everything from ADO through to your build servers, and then over to the CD process, incorporating insights as you mentioned earlier. Are you still pushing to AWS and Azure, or are you putting into any new environments?
We're primarily AWS and Azure. Again, some legacy on-prem stuff, but
right.
In terms of the CI/CD pipeline that you're showing on screen, we've added a couple extra steps. So, for example, we are now doing a lot of test automation within the pipelines, which on its own is a little bit contentious, depending on who you ask, right? Some folks want to do it as part of the build process, but we've been very intentional about making sure that Octopus is the one-stop shop for all of the groups in the company. So that means that, in development or in QA, when we fire off test automation, we collect the artifacts under certain conditions. And so now you don't have to go to ADO, Azure DevOps. You can go to Octopus. Did my deployment go well? Excellent. Let me look at the test outcomes, right? And we use that to enforce failure rates, right? If certain test cases are failing, we don't want to allow that release to go further in the pipeline. And so having that information in Octopus allows us to do that. If you have it in another system, well, you can call the APIs over there, and it makes it more complex, unnecessarily more complex. So, we do everything from static code analysis, test automation, to deployment, right? It really, Octopus should be the one-stop shop for everything that you do, unless you have some sort of edge case. But, to this day, after 6 years, we are yet to find something that we can't do in Octopus. Now, that does mean that we sometimes build our own templates, right? But all in all, it's a fine place to basically start and end every workflow.
Yep. That was my next question, actually, is how are you pausing or stopping those deployments? Are you doing it through the API? And so you answered that question there. I was curious to know, are you using runbooks at all?
Yes, we do use runbooks. Admittedly, probably not as much as we want to be, but a lot of scheduled processes fire through runbooks. And, part of the challenge there is we're getting to a place where some of our customers need to see the output of our automation. And so that means that we're looking at pulling data out of Octopus and into other systems, which has kind of slowed down the adoption. But certainly, if you're not using runbooks today, it's a good replacement for legacy automation, right? So a lot of folks use Task Scheduler or Cron Tab, and they work fine, but the visibility is just not there, right? So again, I go back to that one-stop shop for all workflows. So if you can have it in one place, you certainly should.
And earlier you mentioned your use of Terraform. Are you using it inside of Octopus or outside?
Yes. A lot of the prototyping started outside of Octopus. It's now been brought in. And again, once you get into newer technology like Terraform, and I'm saying, air quotes when I say newer, the problem that happens is if you have to do it outside of Octopus, now you're adding a dependency on what are usually very expensive resources, right? Yes. So our developers or our DevOps engineers, they have work to do that only they can do. But if you bring it outside of Octopus, now you're increasing your cost of deployment. Now you're introducing scenarios where, it's about to be Thanksgiving. Folks want to take time off. And if you build a good schedule, you always have capacity to deploy. Now, no one wants to be working on a hotfix over the holidays, but the nature of the business is that software breaks and it doesn't usually care about your schedule, right? So putting that stuff in Octopus allows us to have anyone all the way from, our help desk techs in IT through QA engineers and developers. Everybody can push a change. Now, obviously, permissions dependent, right? We don't want just anybody being able to go to prod, but what this means is that, we're in a truly remote workplace situation. And so people work different schedules, different time zones, and you don't want to have to wait for the guy that's on EST to be able to do a deployment, right? You want to be able to go whenever you need to, regardless of what time or day of the week it is. So, we, again, tried really hard to standardize on Octopus and make sure it mitigates risk across the deployments.
What's your take on the new UI? Are you a fan? Are you dark mode or light mode? People want
dark
to know.
mode. In fact, sometimes people screen sharing and I see light mode and my eyes burn. But I like the UI a lot better this way. I think it's much more elegant and concise.
I agree. A lot more room to grow as well. We used to have items listed across the top for those who are still rocking older versions of Octopus Server. You may still see that, unfortunately. But if you're running Octopus Cloud, you'll see the latest and greatest. But we are now growing top down, basically. So it gives us a lot more room to grow in that space. And I'd mentioned, or I'd asked you about Terraform earlier. So these are some of the step templates here. Are you using any of these? Is this how you're effectively using Terraform in the context of Octopus, or are you using it differently?
No, that's basically it. We
all right.
We don't like to reinvent the wheel unless we don't. We have no choice. So yeah.
Yeah, fair enough. That's cool. So yeah, if you're at all curious, you can read more about this, as I said, up on the Customer Stories website, which is listed right off the company page there. Was there anything else that you wanted to highlight that's changed? Obviously, you did the webinar quite a long time ago. I'm sure stuff has improved, hopefully, since then. Has anything major changed since then?
Terraform and test automation are sort of like the two larger themes across projects.
Okay.
We started doing deployments to Linux and that sort of thing back when we did the last webinar. So that's kind of ever been there. But the one other item that I want to mention, John, for the sake of everybody listening, is that one of the things that really helped with adoption around here was the community around Octopus, right? So the ability to get feedback or support from other folks like us who are doing similar pattern deployments. Not every vendor has that. And so the Slack community is absolutely amazing when it comes to that kind of stuff. And, shout out to the Octopus employees because they're just as involved in those channels as the other customers are.
Yeah, I think we've just passed 6,500 people in the Slack community. So you can join by going to /community. And the link to join is right there near the top. So if you click that, it will ask you to log in, obviously your Slack profile. And this is an invite to the community Slack. And once you're in there, there's a whole bunch of channels relating to individual features like multi-tenancy or runbooks or whatever you like. There's other resources here. We mentioned our webinars a ton, but that's cool that you highlighted the community Slack. It sometimes gets mentioned, but yeah, you're not alone is kind of the message, right? You have other folks there who are willing to help.
Exactly. Yeah, we've often been in a position where we think we're running into an esoteric case, and there's plenty of folks who have experience. So that's always nice to have.
Awesome. And so if any of you have a question for Jorge on the call here, let us know. You can use, again, the hashtag #SHIPPED24. If you have any questions around the implementation that they did or any use cases that was made. Justin here has a comment here saying, Terraform, TerraGrunt with version control, Git, CI/CD makes life so much easier once it is established. I would agree. What are your thoughts?
Absolutely. It's, I will say that without version control, we'd be in trouble, right? It's, you run into it. Sometimes small shops, they're pushing builds out of developer stations, and we want to forget a past where we were doing anything like that. But yeah, the way the versioning works in Octopus is generally really, really awesome.
And are you using config as code, or are you just storing everything in Octopus?
We're kind of a hybrid. Primarily, everything is in Octopus. Now, we do call various APIs, primarily cloud environments, to pull down config. So we create a lot of secrets on the fly and store that in the corresponding vaults, and that gets pulled back down. We don't store those in Octopus. We did used to store a lot of our encryption stuff in there, but given the type of data that we deal with, we'd like to keep that in as little places as possible. So generally, that means a key vault of some sort, whether it's AWS or Azure.
Yeah, something I like to point out to folks is if there's a step that's not supported out of the box, we have over 550 steps from the community. A lot of these we built ourselves, and one of the ones that we obviously integrate with is HashiCorp Vault as well. So you'll find many sort of credential storing mechanisms, either directly supported through the steps that are built into Octopus, or through integration parts with community step templates. So Azure Key Vault as an example here, but many others as well. And so you'll find these listed there. There's HashiCorp Vault. This was built out a while back. Mark Harrison of Octopus built these, and so you can see how you can utilize that as part of that. Awesome. We have another question here from Steve. Steve asks, what do your new software delivery superpowers, DORA metrics improvement, mean for your business? So for those who don't know, there's integrated DORA metric tracking through the Insights tab in Octopus. And I'm sure that you guys watch that almost daily, I'm assuming. But Steve's asking here, what sort of powers are you unlocking with those metric improvements?
That's a really great question, Steve. So it's actually rather simple. Oftentimes, when you have groups of developers that work on different parts of the platform or different product lines, every now and then, intuitively, people will make changes, right? It's either through the maturation of skills or improvements in process. So the biggest win for us in that regard is watching these separate groups and then looking at some type of divergence in the data, right? So, your deployment failure rate or recovery rate could be X, but if you have an outlier, the first question that leads to the superpower is what changed? What's being done differently? And so a lot of the knowledge of DORA metrics is really attained after you see the metric change, right? What drove the change, and can we reproduce that across other product lines? So it's sort of under the lens of continuous improvement, right? What are teams that are highly effective doing correctly, and can we teach that skill across engineering to make sure that everybody continuously improves?
I love it. So you guys are tracking this all the time, I'm assuming. You guys are jumping into the Insights tab?
Yeah, about once a week. Daily, we don't have that much time, but about once a week, we take a look and make sure that A, everything is within the benchmark of what we expect, and B, are there any outliers, whether they're good or bad, but primarily good, right? We're looking to see what are people doing that could work in other parts of the business.
Interesting. If anyone's interested, we also have a upcoming webinar. I have to plug it all the time. So we've got an interesting webinar coming up with Nathan Harvey of Google, where we're talking about the State of DevOps report. Obviously, this pertains directly to all the stuff that's going on at DORA. So you can check that out. That's on November 26th. I'll be peppering Nathan with a bunch of questions about what sort of insights and findings they had there. You can sign up today at /webinars. Awesome. Was there anything else that you want to highlight here relative to your implementation of Octopus with Kindred Systems?
I think one of the other improvements or changes since the last time we spoke is that We are also standardizing how we build documentation. And so all of our documentation gets pushed through Octopus. It's a separate project from the main application. But again, back to standardizing on a platform, right? That means that we can push updates to our documentation with very low risk to production, right? That's the name of the game, minimizing risk, but also giving everybody the same interface. So the folks that write the documentation have the ability to, with some controls in place, of course, take the changes out into production very quickly. So back in the day, our documentation was wrapped into a release, which kind of makes sense at a glance, but documentation needs revisions very often, and it's usually outside of release cycles. So that's one capability that's kind of grown with us over the last year, just standardizing documentation and deploying it through Octopus.
Do you consider build information as an input for document generation, or are you just talking about general end user documentation, not technical documentation?
It's end user documentation with a slight tingle of technical. It's really a lot of what we do in between releases. We may find grammatical issues or context that could be better provided. So generally, there's like one revision of documentation, and that's always up to the latest.
Yep. Are you guys incorporating build information at all?
No, not at this time.
Okay. Yeah, build information is valuable for folks who want to get some insight into what changes actually went into this release from a like a change request PR perspective. So if you're doing a pull request and you take your notes in and you say resolves issue 10 and that sort of thing, those can be rolled into Octopus as build info. And that's something that not a lot of people sometimes use. When they discover it, they're like, wow, this is amazing. We can actually do a lot with it. And turns out to be immensely valuable. Awesome. All right. I don't think there was any other questions listed here. So let's go ahead and let's draw for another prize. How about we do this? We'll bring up the page again here, our giveaway. And I was going to, this is one of those things where you want to have a virtual lever for you to pull as our guest here, but there you go. Let's go ahead and draw another name. Maybe your name will come up. We'll see who's next. All right. So our next winner is Suraj. All right. I will copy this. It's got truncated there, but that's all right. Just copy this into the clipboard and away we go. Awesome. Well, Jorge, I really appreciate you joining us for this brief sort of interview here style about Kinder Systems. Amazing results. It's awesome that you guys have achieved so much from a deployments perspective. This is turning into a very much a love fest regarding Octopus, which is fine. But I certainly like highlighting the success that customers have as a result. So congrats to you and your team. That's awesome.
Thank you, John.
All right. We're gonna let Jorge go, and let's go ahead and take a note here for the winner of the last draw. Great. And now, if we're checking the time, we'll go back to the schedule. Where are we? Let's go ahead and share our screen. Awesome. So we've had Jorge talk a little bit about Kinder Systems here. We are slightly almost on time, maybe on time. You know what I'm going to do? I'm going to play a little blast from the past, talk a little bit about a book that Steve Fenton has written. It's entitled Exploring Octopus Deploy. I'll just show you the URL here. And then Steve and I sat down and chatted a little bit about this. This will give us some time up until our next session. But if you're all curious, you can check this out up on our publications website. This is at /publications. And then from there, you can check out his book. It's a very good read. You can get it via PDF, or you can order it on Amazon if you so wish. But joining to talk to me about it now is Steve. So let's see what that interview is like. Steve Fenton, who's the technical content creator at Octopus Deploy. He's the person that you'll see a lot of blog posts from, books, which is why we're talking today, and other things as well. Steve, thanks for joining me. I appreciate it.
Happy to be here.
You have written a book entitled Exploring Octopus Deploy, a journey to simplify deployments and operations tasks with powerful automation. That's quite an ambitious title.
Well, I thought we ought to go for ambitious at this stage in things.
That's right.
Yeah.
Awesome. So you've made you've made the book available for free. It's available as a download from a PDF. Of course, you can choose to, if you wish, to purchase a paperback from Amazon as well. So I'd like to start by asking you what motivated you, or what inspired you to write the book?
So I actually wrote a first edition of this back in 2015, and I was just an Octopus user. We'd been looking for deployment automation tools and trying out lots of different things, and someone mentioned Octopus to me. I downloaded a free trial and I absolutely loved it. And so in the end, I wrote a book about it to tell other people about it because I loved it so much. And as chance would have it, I ended up joining Octopus Deploy, and I thought, well, the book's really out of date. 2015 is a long time ago, and Octopus has changed dramatically over the course of that time. And I thought it really needed an update so that we could actually share the features. This particular edition was really inspired by when I joined Octopus. I learned about all this stuff that I didn't even know existed. We'd used deployments and we'd used runbooks. Runbooks was a new discovery for us. We'd started using those, and it was like, wow, it's like having a second product for free. And then when I joined Octopus, I found out about spaces and tenants and all of these other things that would have been super useful to me because I was doing things like hacking my way around, not knowing that there was a feature that did what I wanted. So this is really inspired by, like, let's tell everyone about these features. So if they're using Octopus, they can find that there are these nice, easy ways of solving a whole bunch of problems.
So in the book, you claim, I say claim, but how automation brings more than just speed. Isn't that the truth? What excellent deployments look like. I'd like to ask you about that. What makes Operation Runbooks great? An overview of Octopus Deploy features, concepts, and terms. I liken that to understanding the taxonomy or the lexicon of Octopus, the fundamental stuff. You can't really talk about deployments in Octopus until you understand some of the core concepts. And then finally, how you can use Octopus to level up your deployments and runbooks. I'd like to ask you a little bit about this one. What excellent deployments look like? And I know that it's probably incidental, but I'm hoping it's intentional. You recently wrote a blog post for the new stack where you talked a little bit about some deployment patterns. Was that also intentional, or is that related to what you're referring to in this this bullet point?
So I suppose, like, it's all related really, because being around so many people who deeply understand deployments has allowed me to learn so much. Like, I thought I was doing deployments really well. What I was actually doing was like a rolling deployment where you knock a server out of balance, you update it, you bring it back in. And now that I actually understand things more deeply, I realized that some of the problems we were having, like the flip-flopping of users between two different versions, which can be a bit strange, they can be solved as part of the deployment process. So Octopus has got like a really strong view, like the Octopus way of doing deployments. And the product really supports that way. And it's kind of the learning really from all of the folks at Octopus has kind of like made me realize what like actually excellent deployments look like. Not just excellent for development teams, which is ours was fine for a development team because it was automated and it was brilliant, but also for users, like making sure they don't flip between two versions of like a web app, or making sure that they don't see a page saying we're not available, come back later, which still happens like in 2024. Like I found that on e-commerce sites where they kind of get taken down so prices can be updated overnight. And so, yeah, it's actually really like that deep knowledge from having so many people in the same space.
Did you ever find yourself struggling with deployments before joining Octopus, and then you stumbled upon this tool, and then is that how you got started?
Yeah, so my first experience of deployments was like 5 p.m. We started getting ready, taking database backups, and we had a whole crew of people that would gather round. We weren't allowed to touch the production servers, so there was a checklist, and we stood over the shoulder of the ops team as they went through ticking off things on the checklist. And then around about 8 p.m. when testing of that version was about to start, that's when we started troubleshooting. And usually around 6 a.m. the next day, things were just ready in time so that when people came into the office in the morning, they could use the software, but it had been like a series of crises and panics, and that was what deployments were like. And it was like there was free pizza, there was lots of sitting around, and there was lots of like stress. So that's why I didn't want to do it that way anymore, and I was looking for something which ideally the free pizza would remain, but all of the rest would be eliminated.
Jumping back to the book briefly, you can see the structure here. So part 1, thinking about automation, deployments, and runbooks. So I would imagine this is a brief introduction. Well, why don't you explain the structure here? We start with part 1, and then we go over to part 2, features and use cases. There's a few pages in here. So describe the structure for us.
Yeah, so it's up to the reader whether they want to kind of do everything in order. Part 1 is talking more about the kind of abstract concepts like deployments and automation and runbooks in general. Okay. And we also talk about like why the product was created and like how it helps with that. So it kind of goes into things like how this relates to continuous delivery as an example. Right. Yeah. The second part is where we zoom in on Octopus specifically, and we go through and look at like a whole host of things that are there and available. The people who have been using Octopus for a long time, like, may not be using these, and they might go, actually, that would be quite useful. Let's have a look into using that feature. So runbooks is a really good example for me, because runbooks, we were still accessing infrastructure either by logging into old school infrastructure like virtual machines, or you're clicking around in like a Azure portal to clear a cache so your test team can retry something without the cache getting in the way. And we did a whole exercise to see if we could never log into any of those things, whether it's actual infrastructure or management portals. Can we actually set up a situation where we don't do any of that? And we used runbooks to solve the problem, because we could create these automated runbooks and click a button and make the thing happen. And then we realized we could give that button to the test team. So we could give them permissions to run that just on the test environment, and they could now unblock themselves. So we stopped processing tickets for the test team needing us to do like common exercises that they do as part of testing, like recreating test data or clearing a cache, those kinds of things. Yeah. And we didn't need to have privileged access to everything. So we could then switch over to like temporary elevation when we really needed to use something, instead of like, I need to log into something every day, right? So I might as well just keep access. So it made things more secure, but also self-service.
Looking from the outside, I think a lot of people might look at Octopus and say, I can write a script for that. So why would I use Octopus? What would be your answer for that?
Yeah, I think there's a whole bunch of reasons. I mean, firstly, even if you were using a script, having it in Octopus means you can give it to people with role-based access. So that script now doesn't require me to have privileged access. Like, I don't need access to kube control to run a script. I can have very limited access to do one operation at the click of a button, instead of access to like an actual terminal where I could run any script. And if I copy and paste it and miss off an important flag, I might do something I didn't expect, or I might have the wrong thing on my clipboard when I paste it in, and something terrible can happen. Like we've all seen those things. The old one on virtual machines was you'd very carefully do the operation, and then you'd go in to log off, but accidentally shut down the machine. And so you'd take the machine offline because you accidentally shut it down instead of logging off. So it makes it much safer, but it also means I can give those operations to people who you probably wouldn't want them to be running scripts, because they're not programmers. Like if you've got a test team, or even your product owner might want to run an operation, then they may not be comfortable like having privileged access, logging into those machines, running the operation. And then on top of that, you get the audit trail, so you can see who kicked off those operations, and you've got the complete history. So like it makes, like, I hate audits because they're always like a stress, but when you can just show how your tool audits the activity and controls access, auditors are actually excited and are on your side, and like all of that compliance story becomes completely transformed. Instead of it being this like stressful exercise, it's just interesting because they're like, oh, how did you do that? Tell me more.
So the book is Exploring Octopus Deploy. Just to wrap up our interview here, is there anything that you'd like to share with readers about Octopus Deploy? Exploring Octopus Deploy itself, or the future of deployment automation?
Yeah, so I mean, there's a couple of things that I changed for this edition. One was obviously Kubernetes is now a really common deployment target, whereas back in 2015 it wasn't. So I've changed there's only one step-by-step example in here where it's like, click these buttons to get a result. And that's now a Kubernetes example because it's going to be such a common use case. And other than that, I would say it's worth, if you are an Octopus user, it's worth flicking through and just like skimming those features. I did this when I first learned C#, right? I flicked through just to see what all of the things were that were available. And it wasn't that I then immediately put them all into practice. But what will start happening is you'll start recognizing situations where there are features that will help you to do deployments even more well. So yeah, it's like you can skim it, and just knowing that this thing called tenants exists, knowing that this insights feature exists, is enough that you'll go, oh, I actually already have this thing at my fingertips that I could use right now. So yeah, hopefully you'll find new things that will bring you even more useful tools for your toolbox.
Awesome. Hey, Steve, thanks a lot. If you want to check out the book, you can download it now. It's available as a PDF, as well as you can purchase it from Amazon US, UK, and Australia. Steve, thanks a lot. Really appreciate it.
Thanks, John.
All right. Well, there you go. Let's bring up our schedule. Here we go. We are down to the last two. Congratulations. You've made it this far. It's awesome. So we've got Jeffrey Palermo. Yes, the Jeffrey Palermo talking to us about Octopus Deploy with .NET 9 and Azure Container Apps. Let me go ahead and invite Jeffrey to the stage. Hello, Jeffrey. How are you, sir?
I'm well. Thanks, John. It's exciting to be here at the Octopus Deploy SHIPPED24 conference. Thanks for having me.
No worries. I'll get out of the way. Over to you.
Fantastic. So I'm excited about all the announcements that have already been made at this conference and the focus on containers and containerized applications and the first class support for Kubernetes clusters, which are just have a whole other level of complexity. What I'm excited to talk about today is something that you can use today. I mean, you could use it last year, and that is your containerized .NET applications in Azure Container Apps. And I'm going to talk about how Azure Container Apps provides some simplified support on top of a Kubernetes cluster that Azure is hosting for us, so that we have a sort of a simplified control surface on top of the full power of Kubernetes. And that allows .NET development teams who want to start containerizing parts of their software system to do so, and can have an easy glide path into the world of containers. And then down the road, perhaps some of the system needs all of the knobs and whistles of the full Kubernetes cluster, but it's a fantastic on-ramp into the world of containerization for people who are either still deploying their software to virtual machines or even to Azure App Service. Because if you are .NET 5 and above, you can containerize your apps. And so with the .NET Conf really just a week ago, at this time, .NET 9 has been announced and released, a new version of Visual Studio and C# 13. But we're in the context of that, we're going to focus on the support that Octopus Deploy has right now for containerized applications running in the flavor of Kubernetes that is Azure Container Apps. So I'm going to dive into that today, and we'll have time for questions. So quick summary of ClearMeasure. ClearMeasure is a full-service software architecture and engineering firm that serves companies that are building mission-critical software systems using .NET, Azure, and other Microsoft technologies. developing custom software and rescuing failing projects. And we are also the North American consulting partner for .NET for Octopus Deploy, and we really love that partnership and helping .NET teams be absolutely successful using Octopus Deploy to deliver custom software. And a quick free offer, I just wrote another book. It literally just came out about a week and a half ago. You can find it on Amazon, The 5 Pillars, Leadership for Effective Custom Software. It's a software leadership book for architects and managers, but a free offer for this audience. If you'd like a free electronic copy of the entire book, just send me an email, get me a note somehow, and I'll get you that. And it kind of pulls out some of the methodology that we use to advise our clients to help make effective software teams. So with the relationship with Octopus Deploy, I've enjoyed giving some previous joint webinars with Paul, and we've been working with him since he founded Octopus Deploy. It's been a really great partnership. But let's get into the containers. And you've seen this slide a little bit earlier today, where Octopus Deploy is investing in Kubernetes continuous delivery, in the developer experience, in the platform engineering. And there's a lot of goodness, a lot of investment that is being made with the Argo acquisition and baking some of those features directly in Octopus Deploy and merging those ecosystems to make software engineering teams able to move fast and cycle quickly and ship software at a very rapid pace. And that is going to make it even simpler to use the full power of Kubernetes for your containerized applications. But let's kind of pull in the scope a little bit and talk about the containerization workflow right now for the current version of .NET 9. And by the way, just so if you're wondering, there's very little difference in the DevOps process between .NET 7, 8, and 9. So if you just moved from 6 to 8, if you're doing the long-term releases, don't fret about the version because you're going to be fully supported. And the direction that Microsoft is going with .NET Aspire is only going to give you a better return on investment for containerizing your .NET applications, because Microsoft, with the .NET tooling, is streamlining the developer loop and deployments and integration, and all of this is going to end up making it even easier to do world-class platform engineering, because the .NET platform is focused on being absolutely cloud native, with better observability and scalability, a series of libraries that are available in NuGet. And the .NET team is specifically investing more and more in containers and non-root by default and smaller base images. Just in the last year, there's been a whole lot of improvements on just the size of the containers. And so there's been a lot of really good investment in there. And so now is the perfect time. If you're not already, now is the perfect time to just modify the way that your .NET applications are being built, packaged, and deployed and operated as really the entire industry moves to containers. So hopefully the demos that I show you will kind of give you a glimpse on how you can use your existing .NET applications that are .NET 5 and above and make use of this. Now, let's give you a quick overview of the sample application that I'm going to talk about. This is one of the views of the C4 architecture method using plant UML, a diagram generated with VS Code with the plant UML add-in. But it's 3 components, and I'll show you the Visual Studio solution in just a minute. It has a Blazor WebAssembly front end, which is effectively it's the front end is going to run in the browser, and then there's a .NET Process, our web service or our app service that runs literally as a website with some web API controllers that our Blazor WebAssembly app calls into, and then the that application is going to call to an Azure SQL database. So this is pretty much a standard architecture that everybody has. Everybody has kind of a front end, something running on the server, and then some type of database. And then of course you have a lot of other things, but everybody has this. And so that's what we're going to be looking at. Now, I do want to share with you how Azure Container Apps is structured before we even look at Octopus Deploy deploying it. You've seen a lot of Kubernetes content, and so you're probably familiar with the concept of a Kubernetes cluster. And then within that, you have the networking, the VNet and the subnets. And then inside its own networking subnets, you have pods. You have multiple pods. And each of those pods can run multiple containers. But a pod, I think of a pod as a scaled down virtual server. It's going to have a private URL that we can layer on DNS and we can access things. So I can have multiple containers inside of a pod, but of course I need to know that, and I need to make sure that only one of those containers is asking for port 80 and asking for port 443, because they're all going to share the same networking, but I have multiple pods. So in that environment, we use Azure Container Registry to publish Docker images, our container images, and we can do that through our command line tooling inside Visual Studio. So let's talk about the corollaries with Azure Container Apps. There's two big concepts inside Azure. One is the Container Apps environment. When you create a Container Apps environment, you are effectively creating a Azure Kubernetes cluster. Okay, with that single click, you're creating a Kubernetes cluster. And then inside that Container Apps environment, you create multiple Azure Container Apps. Each container app itself is a pod, okay? And within the container app, you can assign a main app container, and then you can also add in different other containers to be initialization containers to run before your regular container. And you can also add sidecar containers so that you can have side jobs. But within that container app, it is a Kubernetes pod. And so the containers you run inside the container app, they need a little bit of coordination so that you don't have any port collision, so that they're not trying to claim a port that's already claimed. And within a container apps environment, just like a Kubernetes cluster, you can map storage volumes, you can map Azure files, blob storage, and just like a virtual server, you can have your code that's running inside a container app, which is a Kubernetes pod, and you can have it reference a file share, just like it was a UNC share. And as long as the container app environment has that mounted over to Azure Files, you can effectively have .NET code that thinks it's just accessing regular local files, and in effect it is, because you have storage that is connected to the container apps environment, your cluster, and your pods, your container apps, they have access to those volumes. So in a lot of ways, there's a lot of correlations. So it's an easy bridge to pull your .NET apps up where they might be used to reading and writing files, and you can just mount the drives effectively. So these are the parallels. That's what we're working with. So I wanted you to have that foundation. Okay. Now, from a platform engineering process perspective, this is the flow that we want to cause to take place between our build server and Octopus Deploy and Azure. And there's a lot of great tools in the ecosystem. This particular diagram shows the architecture with Azure pipelines, but the shape of this DevOps environment is exactly the same if you use GitHub Actions for your build server, or if you use TeamCity Cloud Edition from JetBrains for your build server, or any of the others. Remember, build servers build and package and run tests. Those are the big activities of a build server. Octopus Deploy deploys to environments, manages environments, executes runtimes, and helps with operation of those environments as they run your custom software. And so there is a method where you can have a build server completely hand off to Octopus Deploy, but in our first environment, we want to run full system tests. And so we like to use the flavor where we actually create a release and deploy, wait for it to finish, and then let Azure Pipelines get control back so that it can run full system acceptance tests against that deployed environment. But effectively, I want to hone in on the three environments. There are three distinct types of environments in any kind of DevOps environment. And you need at least one of each. The last one is production. Everybody knows you need at least one production environment. Pulling back from that is a manual test environment. Everyone needs at least one manual test environment, and most teams choose to have more than one manual test environment. You may have staging, you may have manual QA, you may have development team test. You can have as many as you want. You need at least one environment where a person can go and check something. Pulling back from that, you need this first environment depicted. You need at least one environment that is a test automation environment. I like to call it the TDD environment to invoke the concept of test-driven development. You need at least one of those so that you can run automated tests against a fully deployed instance of your application with all of its moving parts. If you don't have that, that's a missing piece in your platform engineering strategy. And I'm not going to talk about Redgate's flyway tools, or you might see some of the code in this sample because it's there, but it's kind of out of scope for this presentation. Now, if you're interested in this DevOps architecture poster, what I just showed you is only the top 1/3 of that poster. Just send me an email. I'll be happy to send you a full high resolution version of the entire DevOps poster. That'd be just send me an email or a note somehow. Okay, so let's get into how Octopus Deploy looks in this type of environment where we're building, we're containerizing the application, we're packaging it up. We have a container in Azure Container Registry ready to go. I want to talk first about lifecycle. This talk is not a getting started with Octopus Deploy. All of you probably are users of it and are familiar. You've been watching it all day. And I want to talk about the lifecycle. It is so important that you configure the lifecycle so that when you look at your dashboard of deployments, you have environments and deployments that move from left to right. If you look at your dashboard and you see just a checkerboard of environments where you have the circle slash and some don't apply, and it looks like this weird grid, then you've configured your lifecycles incorrectly, and give it some attention. So I'm going to show you the simplest of lifecycle, and it's this: your TDD environment, then user acceptance test, and then production. That's in this example where you have three distinct types of environments and you have to have at least one of each. That is your lifecycle, because this creates that linear structure where we have a new build. We deploy it to the TDD environment first, which is our test automation environment. No humans allowed, test automation. Then we deploy it to a manual test environment. And of course, if you have 2 or 3 manual test environments in sequence, this is where you would have them in sequence. And then it goes to production. And that way, when we go to production, we are promoting a version from an environment, and it's already proven this exact version was vetted in the previous environment. So it's really important that you make sure every project uses an intentional lifecycle. In our consulting and advising all kinds of teams, we see that simple little feature kind of being overlooked too often. And so this is what the tools kind of look like stitched together. And before I pull open the browser window, when a build is running in Azure Pipelines, once we've built it, once we've containerized it and pushed it to Docker, and then we're deploying to our test automation environment first automatically, and you're going to see it running in Azure Pipelines, and you're going to see it running in Octopus Deploy. That's what it should look like. And in this way, you have your personnel who have configured and built up Octopus Deploy, and they've got full access to Octopus Deploy. However, your build server and tracking work items and all that, Azure DevOps provides that support for all of your stakeholders, even people maybe who are just doing CSS and some HTML, or maybe people who are just looking at user stories or work items, but they want to say, hey, what version is in what environment? They can flip over, they can have full access to Azure pipelines, but you don't have to have that broad set of users have to have access to Octopus Deploy. And so it gives you that flexibility, and that way Azure Pipelines also has a mirrored image of your lifecycle. So that's what really you want, so that you have full visibility to all project stakeholders in Azure Pipelines if you're using that. And by the way, when you're configuring these tools to work together, there's one configuration item that I want to call out. And on line 141, right here on the screen, you can see deployment progress is true. Now, by the way, this is a file that is the configuration as code that is in the .octopus folder that's stored in the Git repository that represents the configuration of this particular project. And we are using the create release task, and we're setting deploy to environment, which is TDD, and again, line 141, deployment progress is true. If deployment progress is false, then it's a fire and forget. Your build server is just saying, hey, create release, please, and that task immediately returns, and it's asynchronous, and the build server can continue on. Deploy progress is true, makes it a blocking call, and all of the logs from Octopus Deploy stream back to the build server, so that the build server can also record all of those logs and wait for it to finish. Because in a test automation environment, we want to wait for it to finish, because then the build server is going to run more tests, and it's going to run those tests against the fully deployed environment. And so we see a lot of teams that don't have proper test automation environments, so that you can really fill out the test-driven development strategy, not just unit tests, which are important, not just component level integration tests, which are important, but full system tests, end-to-end tests with everything deployed in a representative environment. Doesn't have to be production scale, but representative in the right shape, as opposed to just running things on a developer workstation. Okay, I'm also going to highlight. Actually, I'm going to come back to the slides. I want to show in the web browser, as I pull it over, I want to show you how this looks. Okay, so we have a repository. It was .NET 8. We upgraded to .NET 9. So, but again, there's nothing magic about the .NET versions that change how you do this. Okay, Azure Pipelines. We have this. We're going to go into the TDD project, and we're creating release. And you see this delete TDD resource group. We automatically create the test automation environment, and then once we run our tests, we automatically delete it, because it has served its purpose, and that limits our Azure bill. But there's a lot of logs that I'm not going to go through here. But let me jump over to Octopus Deploy to show our project, or the process of the deployment project. And we can see that inside Octopus Deploy, inside that, if I go back, inside this create release task in Azure Pipelines, are all the steps to actually create the environment and then deploy our application. So we're going to create an Azure SQL database. Then we're going to create the database schema. And because we dynamically created it, we need to run a little bit of code to get the connection string that was just created. Then we happen to be using Redgate Flyway to actually run the scripts, create the tables. Then we're creating the container app environment and the container app itself. Then we're getting the dynamic fully qualified domain name, and then we're going to add the revision. As we go into this is where I'm going to pick back up, because we have a script here. So if I go back to I go back to the slides and go to the next one, this is the magic couple lines of code that deploys a new version of our application to Azure Container Apps. Azure has come a long way since the very first version of Azure App Service. It is absolutely trivial to push a new version to an existing Azure Container App through Octopus Deploy. And Octopus has a massive step template library with everything, but it's become even simpler because Azure, you could do everything with Azure from its command line. And so we see that, I went too far. Okay, we can see that line 35 here on the screen, we're going to log in essentially. 35 and 36 is just logging in with our credentials, and they're just PowerShell variables. We're pulling them from the variables in our Octopus project. And then line 45 is where we call AZ Container App Update. And this essentially creates a new revision, which I'm going to show you in the Azure portal, what that looks like. And we basically take the $ container image. That is the name of our container image. And we're saying, hey, this container app, I want this image to be deployed here. Go. And it does it. I'll talk about how that does it. So that's the magic inside Octopus Deploy to make that happen. So the complexity isn't necessarily in, oh, how does Octopus Deploy work with containers and work with container apps? That's pretty trivial, but you just need to know the Azure Container Apps flavor of Kubernetes. And so I'm going to talk about that a bit. All right, let's jump back into the browser with, let's see, here we go. Pull that back over. Let's go to the Azure portal. And so I have a lot of resource groups here. I'm just going to jump into, jump into this prod environment. Now, obviously, this isn't prod. It's like demo prod. In the real world, I would not have a resource group for a production environment in the same Azure subscription as resource groups for non-production environments. I would use the security boundary that is the Azure subscription. I would have a different Azure subscription for production, and then I would have an Azure subscription for non-production, because invariably you want different security controls on there. Okay, so we're going to a production environment, and there's two things here that I'm going to show you. One is the container apps environment, and here it is. And so if I open that in a new tab, and then I'm going to open it here. Okay, so this is our container apps environment. This is where we would mount volumes, and this is our cluster. This is my cluster that Azure kind of simplifies. And now if I go to apps, I can have any number of Kubernetes pods, which are called container apps, any number of them right here. I have one, which is just our kind of our running server app. And so I'm going to click inside here, and Octopus Deploy created this for us. And here's the application URL. If I control click in here, then I see that it's an older version of the application. Again, I just upgraded from .NET 8 to .NET 9 because we just had .NET Conf. .NET 9 just came out. Okay, so this is an older version, and I have a version URL /version, and I can see that the version number is 2.4.49. Okay, it's a few versions back from current. If I click back over to our pipeline, see 2.4.83, and so that's what we'll look for, 2.4.83. Now, I want to harp on something. I really want to harp on something. Our build number is 2.4.83. You can make the revision names in Octopus anything that you want. But if we go back to deployments, make your version names the build number from your build server. That way you have traceability, okay? It's possible to be creative and name your releases all kinds of stuff, and maybe you have a reason, but make sure that you have traceability and you put that build number in your revision name. on top of it, you want, let me talk about your image names as I go through here. Okay, so I'm going to click over to revisions and well, let me just show you containers. Here's our container app, and you can look at the image tag. And by the way, there is no, in Azure, there's nothing called version, but in the Docker world, there is an image tag. You can tag a container image. A container image has a name and it has a tag. The best use for those two fields is to make the name whatever the name of the component that you're building. In this case, the application we have is called Church Bulletin, and the website component is literally just called UI. So our image name is churchbulletin.ui. That is the perfect usage of the image name. Okay. Now the image tag, the perfect usage of tagging that is just the version number, just the build number straight from the build server that flows into as the release number or the release name in Octopus Deploy, and also has absolute traceability to the image tag. That makes life so much easier when you're automating all these things because you have direct traceability. Okay, let's go to revisions and replicas. Once you have a container app, then the child concept is revisions. When you want to change what is deployed to this container app, you don't actually change it. You add a revision, and the Kubernetes pod under the covers does its process of stopping the flow of traffic to the old container, spinning up the new container, starting the flow of traffic to the new container, and then doing a subnet DNS switch so that everything is stitched together. And so in order to do that, I'm gonna do this in Azure so you understand the flow of what's actually happening when, remember back here, Octopus Deploy, in effect, is integrating by running this command. Okay, regardless of step templates or whatnot, AZ container app update is happening against Azure. And so I want you to understand what happens in Azure when AZ container app update happens, because in Octopus Deploy, we don't have to run commands for set something up, switch things. With app service, we actually had to do that. In app service, we had to deploy to a staging slot. Then we had to wait for it to spin up. Then we had to check that it was healthy. And then we needed to come back and swap the slot. And that configuration needed to go in Octopus. I mean, you could do an auto swap, but with container app, it's kind of the same concept. Kubernetes does the same concept, but it's completely automatic under the covers. So let's go back to the browser. Let's see here. Pulling up the right screen. I just had it. Okay, there we go. Here's the screen. So what we're going to do is we're going to go into this revision. Actually, no, not going to go that way. I'm simpler. Create new revision. Create new revision is here, and go to main. Now, by the way, I talked about it in init containers and sidecar containers. This is the UI for that. And of course, with Octopus, you're going to use the command line version. But we have the concept within a particular Kubernetes pod. Remember, a container app is a Kubernetes pod. We can have an init container that runs before the app containers, and we can also have a sidecar container that just does something on the side, and we just need to make sure we don't compete for the same ports. So let's click on this, opens it up on the side, and I'm going to change to managed identity. Okay, so we have our registry, which is onion architecture, flyway, blah, 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 container registry. And then the image, well, we have one named image, which, by the way, this is, we're looking at this registry, and we have one stream of images, and this is the name. an image tag in this registry, we have lots of images, and the image tag is just the version number, okay? And if you remember, we were way far back, like 2.4.49. We're going to deploy latest 2.4.83, and we're just going to set system assigned. Okay, when we do it manually, you have to click a few. And of course, when you deploy something, you can either use the same CPU cores, or you can change it out. We're just going to leave the same because this simple app doesn't need much. And if we go in here, I'm just going to show you again. This is the simple Blazor WebAssembly app, and weather and counter. That's it. But what's important here is I have this web API that shows me the version number, and it's there. But let's look at, let's see, create. Let's look at the, oh, I didn't click create. Okay. As it deploys, we're going to just refresh, because I want you to see it doing a few things so that you understand what's actually happening under the covers when Octopus Deploy has received the name of an image from a build server. It's been Dockerized, and we maybe created or used the environment, and now it's time to deploy a particular version, and we're just telling Azure, hey, please do this. So it takes a little bit, and Azure runs at the pace that it runs at. But if I've learned that if I can refresh it, then what we're going to see is the replicas coming up. All right, so there we go. That's what. So 309, we're activating a new version. And when you do it automated through Octopus Deploy, you end up getting this hash. And when you do it interactively through the Azure UI, it auto assigns a 000 number. So when you kind of see that, hey, why the difference? Well, it's because I'm manually doing it with a mouse, whereas when you do it in an automated fashion, you end up getting this hash. So if I just refresh, and I know you're going to be patient with Azure, but I want you to see this process. It doesn't do a good job of auto refreshing, but you're going to see it's activating this new container. It's spinning it up. It's doing its startup process. Our old container is still running. So if I come over here with the version number and do a refresh, we're still 2.4.49. Okay, we're still there. So pretty soon we should see that the new one is activated. And sometimes it'll take 1 minute. So as you're thinking about this process, when you deploy, know that you're going to have some asynchronous deployment process here where it's running. Okay, now we're running the new one, and at the same time, Azure is deprovisioning the old one. But at this point, when I refresh, I have the new version. So the new version is running, and if I continue to refresh, it's going to deprovision, and which is effectively getting rid of it, shutting it down, and then making that container go away. So that ends up being a little bit quicker than there we go. And now we're fully done. And so if I go over, we are 2.4.83. And if I go back to the web page to see, oh, what did we change? We can see on the home page, hello.NET 9. Okay, because we deployed the latest version of this particular application. So let me go back to the PowerPoint. Okay. Now, I do want to talk about runbooks real briefly. We talked about operations earlier in the SHIP conference. One of the simplest runbooks ever is to scale up and down your environment so that non-production environments scale down almost to zero overnight because we're not using it. In production, if you have users that they're all at the office during the day and the light usage at night, you still want to scale them up and down. So that's the perfect, if you've never used runbooks before, that's the perfect initial runbook, is just to scale it up and scale it down per environment. And then you add some triggers that is just a schedule, at 8 a.m. in the morning in your area or 6 p.m. to scale it down. And the process that it runs, as I jump into the scale down, the line to look at is the script file in package at the bottom of the screen. We're looking for the scale infrastructure.ps1 package. in churchbulletin.script. Okay, so we're looking at that. Now, if I jump over to Visual Studio, it's in my Visual Studio solution, scale infrastructure.ps1, and the magic lines are line 49 and line 50, where we're really just doing an AZ container app update. And if you look at the parameters towards the right side of the line, CPU and memory, and we can parameterize that in our Octopus Deploy variables for what level it means to scale up and what level it means to scale down. So for our application, we want to scale down the container app, and we want to scale down our Azure SQL, because Azure SQL has the same concept. So those are, if you have not used Octopus Runbooks before, invariably, you could save money on Azure just by having a scheduled scale up, scale down of whatever shape of environment you are. So I wanted to harp on that. Now, we love making teams effective. If you go to clearmeasure.com/assessment or /developers assessment, then it'll help you see how you can improve your team. But I want to just kind of skip through these slides real quick and save some time for questions, because I know that I went through this information very, very quickly and it's very dense. There's a lot there. So I know we have a fantastic audience, John. Do we have any questions that have come through?
I'm just looking here. There's lots of tips and tricks being provided by Joanna, which is awesome. So we provided your LinkedIn there. If you want to reach out to Jeffrey, you can reach him here, or you can reach him in another a number of other places. Joanna also highlighted our support for Kubernetes deployments. Another link here, press release that Jeffrey mentioned, Octopus Deploy acquires CodeFresh, et cetera. So this is me tap dancing, waiting for questions to come in.
Yeah. If you've had any questions from the audience, go ahead and put them in,
right.
and love to answer them.
Awesome. I think it's like everyone else. You've given them too much to consider, so they're just stunned, into I don't know what to ask. Too much.
Yeah, this could be. There's so much. Octopus Deploy is kind of the simplest part of this, because that's its job, just to make it simple to achieve these types of capabilities. It's really the architecture that we choose that adds the complexity to what we're doing.
Right. All right. Not seeing any other questions here. I think this could be a first for you, isn't it? Like, usually you get I've seen you at conferences, you get peppered with tons of questions. This is the first time I've seen the audience not asking any questions. There you go. Oh, there you go.
Hey, no worries. No worries at all.
Awesome. All right. Well, Jeffrey, thank you very much. Really appreciate it. Great content as always. Go check out ClearMeasure, clearmeasure.com. Awesome folks. They'll definitely help you out. So lots of great feedback there. Jeffrey, I'll let you go. Thank you.
All right. Thanks so much, John.
All right. Take care. All right. We are down to the last session, believe it or not. This is unbelievable. All right. So here we go. I'm going to go ahead and just add this to the stage. Our last session here is entitled Gluing Your Platform Together. When we talk about platforms, obviously there's a lot of considerations to be accounted for. Denis here is from CROZ as well. They do a lot of work, obviously, with building out systems and utilizing facilities. Specifically, he's a senior DevOps engineer at CROZ, and he's talking about basically internal developer platforms, talking about how there's lots of work that can be done here. And so Denis talks a lot about this relative to Octopus. So let me go ahead and pull that up. Oh, I'm in the wrong place. Sorry. There's lots of stuff you're not seeing that I'm looking at. We will wrap up with this last session from Denis. Here we go.
Hello, everyone. My name is Denis Jajčević. I'm a senior platform engineer, solution architect with over 14 years of experience. My goals are to optimize SDLC and enhance developer experience and productivity with a strong focus on observability and monitoring, all under the umbrella of platform engineering practices. Let me talk about, say, a few things about the company I work for. So CROZ is a Croatian German-based tech consultancy, as opposed to some other strictly technical consultancies that focus on providing technical support in some specific areas without understanding the bigger picture. We intentionally grow our capabilities to support our clients end to end, from ideation through product management, engineering the solution, setting up development in a runtime environment, and running the solution in production. The way we can do this, because we're almost 400 people strong, and we've been collaborating with our clients this way for the last 2 decades. Over the years, the business and technology developed at their own pace. So sometimes our clients needed more support in the business domain, other times the technical domain. But over the time, we solidified our capabilities to support them end to end, from idea to production. One important aspect of this end-to-end support is that we try to be customers' partners, giving objective recommendation based on the client's needs and our experience. So what we are going to talk about today is how every internal developer platform relies on a tool that is relentless in automation while being flexible and configurable enough to integrate with a wide range of other tools to form a unique developer platform. And this tool drives the process and acts as a glue that holds all the pieces together. With drawing on years of full stack and platform engineering expertise, we'll share our experience in making Octopus Deploy a key component of internal developer platforms, showcasing an example of extending its robust core capabilities to streamline deployments on IBM Web Application Server. So we'll talk about the importance of internal developer platforms, how Octopus Deploy is an important part of IDPs, and third, how extending Octopus Deploy for specific use cases can augment your platform. So when starting and building digital platforms, let me first actually start with a quote from Ivan Butcher, a technical leader. His quote goes like, "A digital platform is a foundation of self-service APIs, tools, services, knowledge, and support, which are arranged as a compelling internal product." So autonomous delivery teams can make use of that platform to deliver product features at a higher pace with reduced coordination, and reduced coordination being a key, but higher pace. So we see that everybody now is talking about internal products, looking at your platform as a product, and that really is an important part. When planning, building, and maintaining your platform as an internal product, you strive to get insights if your platform fits your client needs. So how to do that? So there are several steps that we are going to go through and describe each of those parts. So first one, we've talked about product centricity. So with our clients, we've been successfully building digital platforms for more than a decade. Building internal or customer-facing platforms will take the same product-centric approach. Unlike project-centric approaches, which prioritize timelines and budgets for individual initiatives, a product-centric approach treats software as an ongoing, evolving asset rather than a one-off project. But unfortunately, what we see is that software platform management seems to forget that the platform is not a one-off project. It needs to evolve by following business needs and technology improvements and innovations. But okay, what is our main instrument to improve? What drives us to want to make things easier for us and to survive in this fast-changing world? Let me translate that question into children's language. How to have more fun each day. Curiosity is the thing that drives each child to explore what it can do or not, what is dangerous and what is not, what is more fun and what is less fun. Choosing the more fun, of course. In the end, we all want to have more fun each day. Every time you focus on your little one's needs, they want more, and that is a good thing. But how to know what's that good thing? So to go back to platform and clients, that we know that each of our platform clients knows that what could help them have more fun accomplishing their business tasks. So we also need to focus on that. But to figure that out, it's simple as just asking. Like, for example, using surveys like the AX, their templates from Laura Taco, to measure overall satisfaction, as well as satisfaction with team processes, tooling, focus time, and quality practices. So after you've collected the response and score the multiple choice questions, use either main, top box scoring. Mean scores are calculated, by assigning each top value from 1 to 5, taking the average. Top box scores being calculated by percentages and responses of the top 2 most favorable options. For example, DX industry benchmarks use top box scorings. And also be sure to carefully review open text responses, free text, so which can contain the most actionable bits of information. And if you've collected a large amount of comments and you don't have time to process them in a real time or in a time that you have at your disposal, you can use LLM tools such as ChatGPT that can be useful for extract core themes and suggestions. What's the main theme? And when you've finished your analysis, be sure to publish your findings back to your organization so people feel that their time filling out the survey was worthwhile. And then doing some reflection, introspective, as a digital platform architect, how to know what to focus on nowadays. So when you know what your client need is, and now you need to decide to find out what's the best tool or approach or a process to do that, what technology to choose from a large CNCF landscape, and am I even doing the right thing? Am I going in the right direction? There are a lot of questions, but not a one answer very, very, very often. That's good, actually. We don't have to change fixed mindset, or we could do better, or growth mindset. This is a major step forward. We want to know how can we do better, what to change. So posing questions and gathering answers will enable us to design and create a thinnest viable product, to know what's the baseline that will enable us to go even higher or even to be even better in our tasks. So a product based on a small set of problems or improvements. But again, doing those things, how to know if you're going in the right direction. So making small changes, measuring their effect, analyzing those effects, and providing fast feedback gives us an ability to perform course corrections, where you're going in one direction, just want to see, okay, taking out the map, or what's my position, trying to figure out where you're in the space, and see, okay, I'm going in the right direction, or I need to do a course correction. So corrections that will help us reach our goals safer and sooner. Asking questions at the start of a building platform is as essential as asking questions after certain milestones. So when you're done with something, let's see if we're going the right direction. So what we've covered, how to build digital platforms and how to start. With a product-centric approach, we will make sure that our platform evolves. With curiosity, we are exiting our comfort zones and exploring new paths. But to choose those paths wisely, we need to ask ourselves where we need to go. Answers will give us what's the right thing to do at the moment. If we have started building our platform, we need to start small, setting up a thinnest viable platform, and measure and monitor changes to make sure you're not going in the wrong direction. What we're going to hear next is an example of finding out what our clients needed then and how we helped them to build a flexible solution that will enable them to continuously improve today and tomorrow. So, digital platform consists of several key planes: management, control, runtime, and services plane. Every self-service digital platform control plane has an automation controller that needs a continuous deployment provider that will provide an engine that will automate deployments and other related tasks that we have to do manually in order to remove the manual toil. and at the same time decrease failure rates, increase our speed of delivery, deployment, and enable self-service, and most importantly, innovations. So what are main features of an automated control provider for continuous deployment? It automates deployment pipelines. So it defines and automates the steps required to deploy applications to various environments, handling complex deployment workflows. It manages configuration across environments, ensuring that settings are adapted as necessary for test staging, so production, or to any other environment that you have. It also integrates with your CI/CD pipeline. So it connects to CI/CD, and that CI/CD can trigger deployments after builds or other events on that platform. It also handles release management, provides release tracking and versioning, giving you control over which version and application are released to different environments. It orchestrates multi-environment deployments. It can deploy to multiple environments and ensures that there's a consistency between them, and there's crucial compliance and stability in production environments. So if you have, we're not talking about, it's staging or production. We're talking about, we have different environments on different, on the prem or in the cloud. And also with the security and the compliance to meet the security and compliance requirements, essential for organizations working in a regulated environment that need to have certain features in place, like change advisory boards or audits, to know who changed and what, and to control what's going into the production and what's not. Saying all that, can we extend all of those features? So can we extend Octopus for those specialized use cases that we need? So extended Octopus can unlock powerful capabilities for organizations aiming to streamline and scale their deployment workflows across diverse environments. Well, we all know that Octopus has a lot of out-of-the-box functionalities. Extending its capabilities can allow teams to tailor the platform to meet specific needs, integrate with additional tools, or further automate complex deployment processes. And what Octopus Deploy is designed with is with flexibility in mind, supporting integration and extensions to meet variety of deployment scenarios. Let's talk about how to extend, and particularly this case where we're talking about is where it can be particularly valuable for organizations to deploy in unique environments like IBM Web Server Application Server, legacy systems, or multiple cloud environments. What are the possibilities from Octopus Deploy to extend it? So there are approximately 4 of them. One being custom step templates that Octopus Deploy allows teams to create step templates, share them, and for example, you could create a template to handle specific tasks that are deploying to, for example, Web Server Application Server, or custom steps to interact with configuration management systems or monitoring tools. We can also extend it, integrate it with external APIs, or create scripts and runbooks. By using scripts like PowerShell, Bash, and Python, Octopus enables teams to automate custom tasks that may not be covered by built-in steps. And this is very, very powerful. And runbooks obviously can be scheduled to run ad hoc, or especially helpful for repetitive tasks, or triggered by some events. And also, we can extend with our platform with Octopus REST API, so we can use other tools to leverage Octopus REST API focus. API focus, where we can use other tools to automate stuff on Octopus through its API. So now let's talk about a case study. We've talked about a little bit about deploying on an IBM Web Server Application Server. It's a very interesting story where we use the possibility of step templates, so the capability to extend Octopus with step templates to achieve even more. Let's give it a bit of a context. So a customer has many applications running on IBM Web Server Application Server. They are going to stay obviously, for whatever reasons. And additionally, there are several runtimes based on Kubernetes. So we need to think of all of that. So we need something that is going to integrate all of that. So in the end, what we got at the C-level is unhappy with the speed and quality of the delivery. What their pain was, like they've presented to us, was that managers report in the product teams are not able to keep pace with business needs. To fix that, they thought of hiring even more external developers, but hiring even more will introduce even more problems like knowledge transfer, like configuring access, allowing them access, bringing them into business, etc., etc. It's not an easy task if you're trying to speed up things, if you're trying to achieve certain goals faster. So, but with our approach, we've described before, we try to understand the client's needs. With our client, we've created a survey. We've performed a survey and for developers, the DevX surveys and management surveys, to understand both of sides of business and developers, to understand what are the reasons why developers are struggling with productivity and what are the management expectations. Then again, we've done a gap analysis and proposed next actions. And with all of that analysis, we've introduced the glue, the Octopus Deploy, that will actually cover all of those scenarios where we need to have a certain specialized deployment step for IBM, the Web Server Application Server, and to be compatible to even streamline the same stuff to deploy to Kubernetes. So what we did is actually created a step template that consists of 5 to 6 general steps, where we have transfer next startup script, transfer nexus package to WASP, because we'll talk about it later, deploy the app and check if it is started, change the context map just to figure out if you can change how deployment descriptor is on web server configured, and do smoke tests in order to be sure that application is actually deployed. So the first step is transfer and extract startup script. What we've done is actually created a Python wrapper around IBM Web Server Application Server's script that's a certain CLI that allows you to interact with IBM Application Server through your command lines, through shell. With each action on your Web Server Application Server, you can get an administrative description what CLI actions can be used to perform the stuff, the configuration or the actions on the Web Server Application Server you've done before manually. And that's the thing that we've also leveraged and done a wrapper around it, just to be able to provide that script parameters of which application to which environment to which server to what context or route, etc., to be able to figure out if it can be deployed or uninstall of whatever action we need to do. And with that, we've brought that script into the Octopus to be used for further steps. What we do is download this Python wrapper and upload it to IBM Web Server Application Server Management Server, where we have that provided CLI. After that, what we do is there's CI/CD, so continuous delivery pipeline, is configured in such a way that it uploads the concrete var or ER to Sonatype Nexus. We need to download that application from Nexus to a certain location in the Web Server Application Server Management Server to be able to say, okay, now deploy this application from this location. After that, we instruct Web Server Application Server to deploy this application. Of course, making sure that everything is going okay, checking if application is already deployed, doing so stuff on Web Server Application Server. when we initiate the deployment process, we need to wait for, obviously, for application to start. But then after all checks are good, we demonstrated that we can use Octopus Deploy to also change the context and to map all of those maybe shared libraries to the same application or change the context root of the application. And this is the first step of how we can do configuration management for applications of WebSphere application server. Then, after all is done, we do a smoke test. So we know, since the application is known with our environment variables, we can define what's the, so to say, health check, like in Kubernetes, how to check if application is actually deployed. With WebSphere application server, you have one status that, okay, server's application hasn't crashed, and in logs there are no problems reported, and WebSphere application thinks, okay, now you're good. But if you cannot access any resources through that, be it browser or REST API, then you're not sure that it's even deployed correctly. So we do a smoke test. It's actually since it's a demo application for IBM WebSphere, it's provided. There's a certain endpoint where you can hit and get the send. Okay, we got the 200 and we're good. So we're sure that application is deployed as it should be. After that, let me just show you a bit of release details that we see that we've transferred two artifacts from Nexus. One is a script that we use to install it, and the other one is the concrete application that we are going to deploy. This is a short overview of the process, what the steps are, and that they're completed, and that we are sure that everything is good. So what we have succeeded is to understand what the customer needed. We find out or look at the vast CNCF landscape, and okay, let's see. We know that Octopus Deploy is the best fit, and we know that we can extend it to accompany this specific use case to deploy applications to IBM, a web service application server. That being that automation controller provider for the continuous deployment, we see that we have all the ticks around if Octopus fits in their environment. It automates deployment pipelines, it manages configuration, it integrates with our CI/CD pipeline. So we have CI/CD pipeline that's going to build WebSphere application server var or ER artifacts, publish it on Nexus, and then trigger a deployment or a release on Octopus that will actually, download that artifact and deploy it on IBM WebSphere application server. It also handles release management. So with that, we have also steps that are, okay, are you sure that you can deploy, or we can create some change advisory boards. So there needs to be some certain group of people who need to approve the deployment through certain environments. Also, it orchestrates multi-environment deployment, so we can deploy certain applications to Kubernetes or certain applications to IBM WebSphere, and many other integrations that we can think of if customer needs it. And also, like I've said, meet security and compliance requirements, like example, manual interventions. And that's it. You can reach me out if you need something, if you have some questions or you need some demonstration around it. Yeah, thanks a lot.
Thank you very much, Denis. Awesome presentation. Yeah, I'm really impressed with what the folks over at CROZ are doing relative to Octopus Deploy. Hey, guess what? You made it to the end of day one. Congratulations. Great job, everyone. Really impressed with all the content we've had today. And it's been awesome to see. So what I'd like to do now is just give you a brief glimpse of what we expect for day two. So we're going to start at 8 a.m. sharp, or sorry, 9 a.m. sharp Eastern. We're going to kick things off with Steve Fenton, a presentation entitled Effective DevOps Metrics. We'll then move on to presentations around Kubernetes, Argo, CodeFresh, more Argo, some UX talks, progressive delivery, etc. And then we'll wrap the day up with Dan Garfield and friends with a game of Jeopardy. So what a way to end. Should be awesome. Anyways, with that, let's go ahead and give away a couple of prizes. So we'll do a couple more draws here. I'll take down these names. And hopefully no Octopus or CodeFresh this time. All right. I think Josh was already on the list, if I was not mistaken or not. But no, all the names are blending into each other. All right, let's draw another one. We'll do another one here, and just for safety there, just in case Josh has already won. It shouldn't have had 2 winners, but there you go. And Michael. All right. Congratulations, Josh. Congratulations, Michael. All right. Well, with that, I am happy to say that you have reached the end of day 1. Congratulations. Thank you for attending SHIPPED24. Stay tuned for SHIPPED24 day 2 tomorrow. For those of you who are joining us via social media, such as LinkedIn, Facebook, YouTube, X, etc., the stream will end and then reconnect tomorrow. But if you want to come for day 2 here on StreamYard On Air, which is the platform you're using, just hit the same link and we'll be broadcasting here. Until next time, happy deployments, and we'll see you here tomorrow first thing. Take care, everyone.